Yes. So we are live, Dennis. Um, I'm really happy to have you here at DataBash. Um, so I didn't ask you that. Where are you currently? Where are you in the world currently?
Well, usually I live in Malta. In fact, this image that you are seeing in the screen is an image from Malta. But today, especially, I'm in Lugano because I was here delivering a technical session yesterday
Okay.
to the Ticino Power BI user group, Italian Power BI user group. So I'm delivering this session from Lugano.
Okay. So then, welcome once again, and thank you for working also on Thursday, on Saturday. Probably the reason you are not traveling home because of this session. So, but Lugano is not that bad. I've been in Lugano once, but never been in Malta, so it's not that bad, I think.
Yeah, in fact, I'll take the weekend, the rest of the weekend to enjoy a bit the city, discover a bit the city.
Okay, so sorry, I will leave the stage. There are just some minutes to go, um, and thank you very much once again. I'm pretty sure that you will rock this show and have fun, Dennis. I will leave the stage right now.
Thank you.
I try to leave the stage. Whoa. Here we go. I'm leaving.
Okay, I will start, okay? So, welcome everyone. Today I'll talk about Fabric Real-Time and CDC, ingesting in real time from Azure SQL. So, my name is Dennis Torres. I'm a former data platform MVP, work for the Tower Software and Onyx Data. I'm a trainer with some Microsoft certifications, and I'm the leader of Malta Data Platform User Group. I live in Malta. You can see on the screen my contacts. It will be a pleasure to stay in touch in social media. It will be a pleasure to connect. So, our agenda today. I'll talk about the ingestion from Azure SQL. We'll talk about the slowly changing dimension because this concept of a slowly changing dimension is very important for this kind of ingestion, which I will explain today. A bit more about ingestion, streaming CDC versus mirroring, because this is a common questioning. Which one is better? Which one should be used and why? Streaming CDC or mirroring? Let's compare both and let's see how to set up the streaming CDC. So, ingestion from Azure SQL. We have many methods to make ingestion from Azure SQL. From Azure SQL, we can use Data Factory pipelines, and I'm talking about Fabric Data Factory pipelines, Data Flows Chain 2, notebooks, and mirroring and SQL CDC streaming. All these are possible methods to ingest from Azure SQL, but only two of these methods allow the ingestion to work in real time. And these methods have big difference between them. So, to understand this difference, these methods and this difference, we need to have a clear understanding about what is slowly changing dimension in a data intelligence environment. What I'm talking about. The idea is that in a production environment, we make inserts, updates, deletes. This is usual. We make all of this for maintenance of our records. But in data intelligence, we only make insets. Why we only make insets? Because we want to keep every historical information that we receive. If the record changes, we want to know the change that happened and when it happened. So this is very useful in a data intelligence environment that we only make insets. So what happens when a production record is updated, for example? When a production record is updated, what we do is to insert a new record in the data intelligence table. Wouldn't it duplicate the record? Based on a natural key from production, yes, it would duplicate the record. But we invalidate older versions of the record, telling on the older versions, oh, this record is not the actual one anymore. One record is the actual version of the record. So we keep all the versions of the record along the time and pointing to when that record changed, when the information on that record changed. This is a slowly changing dimension. Some also call it slowly changing dimension type 2 on some definitions. So we keep multiple versions of each record. They are kept. Only one version of each record is the current version of that record. And in relation to the ingestion, there is no automatic solution to implement this, to implement a slowly changing dimension in this format which I'm explaining. We always need to make a special processing during the ingestion to ensure the implementation for a slowly changing dimension. Until today, there is no automatic way to implement a slowly changing dimension like this. Let's see an example. In this example here, I have a record of Johnny Caprio, and I have some special fields that a slowly changing dimension usually creates. This is the natural key of the record. 12 is the customer ID of Johnny Caprio. Okay, customer ID. This comes from production. But I will keep many different versions of this record, so I need another key to identify the record. One very common key that we use is to create a hash with the content of the record. We create a hash column with the content. Then we use two other keys which are date time, two other columns which are date time. Start date and end date. This tells me when this record was inserted, when this record appeared, and if this record is still valid or this record was replaced by another version. Now let's consider that this record is updated in production. Production makes an update of this record. Then, in data intelligence, we will insert a new version of the record. What will happen with the old version of the record? This old version of the record will receive an end date. See, the end date was null, and this old version of the record receives an end date. And the start date continues the same. We can note the start date, but now we know the end date. When the record was updated, this version of the record became an old historical version of the record. And the new version of the record receives the end date as null, receives a start date, which usually ends up being equal or very close to the end date of the previous one, is when this new version of the record became active, became the valid version. This is the current version of the record. And the end date is defined as null. We can easily find the current version of each record by looking for end date null. The hash is different. Why the hash is different? Because the data changed. What changed on the data? Take a look on the name. The name of the guy, the customer was updated. In fact, the image is not shown here, but the customer ID continues the same. So every one of these rows continues with customer ID 12. So the customer ID continues the same, but the hash changes. The old version gets an end date, and the new version gets an end date null. So this is what we call a slowly changing dimension. The natural key, the 12, will repeat a lot of times, but we identify each individual row by the hash key, and we identify which row is the current one by looking by the end date null. And then we identify, oh, this is the current version of the record. Why is this so important? This is important because we need to make the correct relation between facts and dimensions. What happens if in production the record of a dimension keeps changing and we keep just updating the dimension in data intelligence? What happens is that we will be creating fake facts. Let's say that the customer buys one product. The customer buys one product, buy a bike at one specific date. On that date, the customer was living in Malta. Okay. Then the customer moves from Malta to Italy. When that bike was bought when the customer was living in Malta. So I need to have the record of the customer living in Malta at that date, and I need to have the current record of the customer living in Italy. If I only make an update, I create a fake fact. Because what will happen? Where was the customer living when the bike was bought? Because I updated the record, I will see Italy, not Malta. And this is a problem. The fact becomes fake. That's why we keep the entire history of the data. The entire history of the record is a better practice to keep the entire history of the record than to stay updating the record, making updates over and over and over of the record, because we end up creating fake facts for our data intelligence environment. Okay, so we see here the change of the data journey to journey 4, the null on the DW and the date on the new version of the record. Okay. So let's talk more about ingestion. Many methods of ingestion require scheduling. Many of the possibilities that I mentioned that we can use to ingest from Azure SQL require some kind of scheduling. Data pipelines, notebooks, data flows, they require to be scheduled. So most ingestion methods need to be scheduled. And if the method is scheduled, this means that there is an interval between the executions of the method. In this way, the ingestion is not actual, a real-time ingestion. Every change that happens in the production environment between the schedule will not be immediately ingested. We'll need to wait the next ingestion is scheduled. This is not an ingestion in real time, so it's not what we intend to do. So an interval means it's not actually real time. Okay. So, what are the potential real-time ingestions? There are two. Mirroring. I can mirror an Azure SQL to Microsoft Fabric. I can create a mirror of an Azure SQL database to Microsoft Fabric. And CDC streaming. I can make a streaming of CDC to Microsoft Fabric. Let's talk more about these two methods. Let's talk more about how these two methods work, mirroring and CDC. What's CDC? CDC means change data capture. So change data capture, this means that the source will identify when an information changes and keep a record of the change that is happening. This is a capability in SQL Server. In fact, not one capability. We use the name CDC in a more generic way. We talk about CDC in a generic way, but SQL Server itself has more than one single method to apply CDC. Has many methods to apply CDC. We'll be talking about one of them. So, when we use CDC, the CDC records what operation was executed, if it was an update, an insert, a delete, the records which were affected, and the data. And in fact, CDC records what data existed before the operation and what data existed after the operation. So we have this information. We have the operation which was executed, the record affected, and the data of the record. In this way, we can query the changed data from a specific moment. Yes, we can query the changed data from a specific moment. Let me remind, at this moment, at this slide, I'm talking about CDC in a generic way, in a very generic way. So, the CDC makes an incremental ingestion to our data intelligence environment possible and easy because I can query the changes that happen from a specific moment to the current moment and ingest these changes to our data intelligence environment. So our ingestion will be always incremental. This is already an advantage. Other ingestion methods would require us to discover what is new, what changed. The most terrible ingestion methods would require us to keep ingesting the entire table over and over and over again. This is extremely heavy. Using CDC, we make incremental ingestion. Okay, is this the only advantage of CDC in this case? No, because now I'll be talking about CDC streaming. What is this? Microsoft Fabric has the event streaming option. Event streaming is used for real-time ingestion from multiple sources. From many sources, we can use event streaming for real-time ingestion. And using event streaming for real-time ingestion, we can use multiple sources. We can point to multiple sources. An event hub is streaming to Fabric, for example, a custom app is streaming to Fabric, and one of the new sources, this new source is in preview, is yet in preview, but it's working very well, is the CDC source. So the event streaming in Microsoft Fabric to read data in real time has a CDC source. So it's capable to read the CDC information which is kept in Microsoft SQL Server. More specifically, in Azure SQL. It doesn't support on-premise SQL Server yet. So it's capable to read the CDC information from Azure SQL and bring the CDC information to an event stream and allow the event stream to process the CDC information. So It's when the source SQL Server sends us the CDC updates in real time. Basically, we receive the CDC updates in real time in an event stream in Microsoft Fabric. So, event stream has a SQL Server CDC source. In fact, Azure SQL CDC source. It's not supporting a SQL Server edition yet, only Azure SQL. We receive the data in real time. So that's what makes CDC becomes a real-time streaming, a real-time ingestion, because we have a CDC source in event stream, which will be loading the CDC information immediately when a change of the data happens inside Azure SQL. So when a change happens inside Azure SQL, we will be loading information immediately. That's what makes it real time. We still need a processing for the CDC ingestion. What do I mean? We still need a processing for the CDC ingestion. We're talking about an event stream. Why can't the event stream just insert the record in the target table? Because we are talking about building slowly changing dimensions. We are talking about keeping the entire history about versions of the record. So it's not only about inserting the changed record inside the table, but I also need to look the previous version of the records and invalidate them. Reminding the example that I showed before, it means that to set the DW end date, the end date of the previous version of the record, with the specific date when this new version is arriving. So we need this additional processing. What if I don't need a slowly changing dimension? What if I don't want a slowly changing dimension? Well, if you don't need a slowly changing dimension, if you are absolutely sure that you don't need to keep the history of all changes of your record, then you don't need CDC. You have a second solution to ingest in real time without keeping this history. And the second solution to ingest in real time without keeping the history is mirroring. You can make a mirror from the Azure SQL to Microsoft Fabric. And this is exactly the difference between mirroring and streaming CDC. Both ingest information in real time, but mirroring don't keep a history, and it's extremely difficult to implement a slowly changing dimension on mirroring. I would say we don't implement a slowly changing dimension mirroring. It would be extremely difficult to do so. In this case, mirroring, when the record is updated in production, we receive the updated information. And the information just changes in our data intelligence environment. We have a new record, a changed record. But on streaming CDC, we receive the history, the information about what changed, what record changed, which fields changed, how it was before, how it is now. We receive this information the streaming CDC. And this information we receive allow us to implement the slowly changing dimension. That's the difference. If you want to implement a slowly changing dimension and keep a full history of your dimensions in your data intelligence environment, you use streaming CDC as your real-time solution. If you decide that you don't want a slowly changing dimension, that you don't need this level of history, you go for mirroring. It's easier. If you try to implement a slowly changing dimension in mirroring, you need to make a full table processing of the mirrored table to discover what changed and make an implementation for an SCD to transform the mirrored table in an SCD table. On streaming CDC, this doesn't happen. We are receiving the exactly changes, the exactly records which were changed, updated, created, or deleted in production, and we can process this information that we are receiving and ingest this information in a slowly changing dimension. How do we set up streaming CDC? So, first, some requirements. Azure SQL requirements. It needs to be an Azure SQL S3 or above. The CDC features in Azure SQL are only available on S3 level or above. So, you need to have an Azure SQL set up in this level. Then we need to go to Azure SQL and enable CDC. We need to make the enable CDC in the Azure SQL environment. At this moment, this feature is in preview. While this feature is in preview, only basic authentication is supported. Considering that only basic authentication is supported and more, this authentication needs to be owner of the database. Basically, you need to use the login that you defined as admin of Azure SQL. You need to use that login. When you provision an Azure SQL, you define the login, which will be the admin of Azure SQL. And you need to use that login to make the authentication with the CDC source. In the event stream, the event stream for the implementation of the CDC streaming for the use of the CDC source needs to have enhanced capabilities enabled. Enhanced capabilities is a feature in event stream. It is relatively recent feature which is still defined as in preview. It was not defined as being a GA feature. This means that using these combination features that I'm telling you, you'll be using two preview features. The enhanced capabilities in event stream is a preview feature, and the CDC source is a preview feature. Yes, you will be using two preview features. Does it work? According to your needs, it may work. I faced scenarios where, yes, this works. It works using this to achieve a real-time ingestion from Azure SQL and still keep an SCD history on the data. So both features are in preview. You can choose to ingest. When you configure this source, you can choose if you ingest all the tables or specific tables. You can choose to ingest one single table if you would like, or you can choose to ingest all the tables. It's a choice. The tables needs to be enabled for CDC, so you need to go to Azure SQL and enable the tables for CDC. You enable at the database level and at the table level. So you need to enable CDC for the tables. After you configure the source, the Azure SQL source, and the event stream source, you will start receiving JSON snapshots, JSON records, and JSON snapshots. What is this? When everything starts, the CDC streaming starts from the belief that you don't have the tables. You don't have the tables in your intelligence environment. So it gets a snapshot of all the tables. It gets a snapshot and sends a snapshot through event stream to you, record by record. So What this means? This means that you don't need to make a first ingestion and then enable CDC later, because you would ask, okay, CDC will be sending the change to me, but in this case, I need to have the same table in the intelligence environment and then only update the changes, right? Wrong, because the snapshot. Wrong, because when the SQL CDC streaming is enabled, it understands that you don't have the table yet and it starts sending you a snapshot. So you have the option to use this snapshot to rebuild the tables in your intelligence environment. That's exactly the purpose of the CDC streaming to be sending this snapshot to you, to rebuild the tables. Well, you will receive one JSON document for each record. Each record will always be received by the event stream as one JSON document. And there is a field called operation in the JSON document. When the snapshot is being taken, which is immediately when the SQL CDC source is enabled, the operation field is defined as R. So when your event stream receive the JSON documents with a value R on the operation, this means that this is a snapshot of the table. The CDC is giving you the pre-existing record in the table, so you can rebuild the table in your SQL intelligence environment. All tables are included, not only the filtered tables or CDC-enabled tables. What do I mean? I told before that you can choose the table that you load. For example, we can choose to only load through CDC the customer table. But for the snapshot purpose, the CDC source will send to you a snapshot of all the tables, not only the one you choose, and even if the table is not CDC enabled, it will send it to you as well on the snapshot stage. Is this correct? This is a preview feature. From my point of view, my personal opinion is that this is a bug in a preview feature. It should be sending the snapshot only of the table that you choose to ingest, not from all the tables. But we will discover soon. If this is really a bug, this will be fixed soon. As I was saying, this probably is a bug on the preview. So, a view of the JSON. Here I'm using a tool to visualize the JSON, and the root of the JSON brings the OP field, which is the operation. This starting snapshot, which I mentioned, comes with the operation R. So, when the OP is R, this means that this is a snapshot. This is a pre-existing record which is being sent to us with the intention for us to rebuild the tables on the data intelligence environment. And on the source set of data, we have the snapshot field marked as true. The snapshot field is marked as true. Once again, pointing that this is a snapshot. Besides that, it's also interesting to note that we have two nodes inside this JSON, one node called before and one node called after. What this means? This is the data, how it was before this occurrence. And this is the data, how it is after this occurrence. The snapshot action brings only the after node. The before node comes null. And about the JSON ingestion, after the snapshot, when our records in Azure SQL start to be changed, when we start getting changes in our records in Azure SQL, so we receive one document row for each change. And the operations can be C, create, a new record was created, U, a new record was updated, or D, a record was deleted. So this is an example of an update. The OP comes as U, update. The operation which happened was an update. In source, the snapshot comes as false. What this means? This means this is not part of the snapshot anymore. This is an operation which happened after the CDC was enabled. This is not a snapshot of existing records. And then you may notice the before and the after fields. The operation U brings both fields. Both fields before and after, how the fields were before the update and how the fields were after the update. And we need a processing after this ingestion. We can apply different techniques and algorithm can be implemented to get this JSON, to get the data of this JSON and make a processing with the data of this JSON. Processor means we will check the OP value, we check the operation value, check the before and after nodes, and insert this on our slowly changing dimension accordingly to the operation and to the values on the before and after node. So, the after ingestion processing. It's possible to process multiple tables at once. It's possible to make a notebook, a Python algorithm to process multiple tables at once. In a single algorithm to process all the tables which are being received. It's possible. You need to control a control table for ingestion. What do I mean? I mean that this notebook that you will make this after ingestion processing, it will be reading the JSONs from the Custo database. Custo database, what I'm talking about? We're talking about an event stream. An event stream will receive the JSONs. Where the event stream will drop these JSONs? The best place is a Custo database. Drop these JSONs in an event, a Custo database in an event house. The JSONs will be there. Then you'll be executing a notebook to make this after ingestion processing, to get the rows in this Custo table and apply these rows in your lakehouse following the rules of a slowly changing dimension. So we'll make this after ingestion processing. But to do so, we need to know on every execution, where did we stop? We need to have a control table that tells us, okay, we processed the records until this date and time. Next execution will process all the records from this date and time to the current one, and so on, and so on, and so on. So we need a control table for the ingestion to tell us where we stopped on the previous execution and where we should start on the next execution. Custo is the source for the processing. A notebook is needed exactly to process SCD, exactly what I was talking there. The event string alone is not capable to make the SCD processing. It could drop a new record, but it can't invalidate the previous versions of the record. It's not possible. So we need a notebook to make this after ingestion processing. The notebook can be scheduled. Yes, we can schedule the notebook to run every 5 minutes, every 3 minutes, we decide. The notebook will get the ingested changes and apply to the SCD table. Oh, we're talking about the scheduling something again. Is this actually real time? Could we argue that this is not real time because there is a notebook scheduled to make this after ingestion processing? Yes, we could. The event stream receives the information in real time, but to go from the JSON format, the CDC format that we receive the JSON, to a slowly changing dimension, we need this processing, and this processing is scheduled. So we could argue that this is not actual real time. Yes, it's true. At the moment, it may not be actual real time. So what I'm selling this as real time. Compare this to other possibilities. Compare this to an ingestion with a data pipeline or only with notebooks. If you are ingesting using a data pipeline, the data pipeline is scheduled and will be always scheduled. If you are ingesting with a notebook and only with a notebook, that notebook is scheduled and will always be scheduled. But if you are using this CDC ingesting through an event stream, and only this last part of processing is scheduled, I believe, and you can consider this my personal opinion, I believe this relation between the event stream and this notebook to make a after ingestion processing will evolve. This is a technology that is still evolving. There are a lot of preview features in this technology. I believe this technology will evolve to a level that the notebook will be triggered from the event stream. The event stream will directly trigger the notebook. And when the technology reaches this point, this architecture will become a full real-time architecture. It will really be using real-time and will not need the shadow notebook anymore. What I mean is that if you choose one of the other options, the other options will never be real time. Never. If you choose this option using CDC, you are making an incremental change, an incremental ingestion. You are loading only the change that happened in your source. And this architecture has the potential to be evolved to a full real-time ingestion. It may not be considered full real-time now, but it has the potential to evolve to it. I'm talking about that today we need the notebook to be shadowed. True. Today we need the notebook to be shadowed, but there is another technique that we can use besides the shadow of the notebook. Another technique that we can use is a data activator technique. There is a technique that we can use with data activator for the data activator to trigger the notebook execution when the data arrives. This is possible. How this data activator execution would work? Instead of scheduling the notebook for this after ingestion processing, how this data activator notebook execution would work? The event stream receives the data, drops the data in custom. We would need a real-time dashboard. We would need a real-time dashboard to create a data activator object. But in fact, this is outdated because in FABCON a few weeks ago, it was announced that we don't need real-time dashboards anymore to create a data activator object. So the real-time dashboard here is completely redundant. It's not really needed. What we needed is a data activator object. Just a few weeks ago, we needed the real-time dashboard, and today we don't need anymore. See how fast things are changing? Things are changing very fast. So, why I would get the data from Kusto and from Lakehouse? I would get new records from Kusto, and I need to be sure in a control table in the Lakehouse that the notebook is not being executed at the moment. I can't put the notebook to executed multiple times. So I need to be sure the notebook is not being executed at the moment. Then, from the real-time dashboard in this example, I trigger a reflex object. Based on the fact that new records arrived and the notebook is not being executed, I trigger a reflex object. The reflex object will trigger the notebook. So the notebook is not a shadow. The notebook is being triggered when new data arrives. Then the notebook reads the data which arrived from the Kusto and drop the changes into the Lakehouse. I wrote an article about how to implement this notebook execution, this continuous notebook execution triggered by data activator. This is a very interesting execution. But this is like real time. The record will arrive and the notebook will be triggered according the record arrives. Isn't this real time? Unfortunately, the current features in Data Activator doesn't make it real time because Data Activator has a delay to trigger the execution of the notebook. The Data Activator has a delay that can go from 5 minutes to 10 minutes to trigger the execution. So we can't fully call it real time because the delay that Data Activator has at the moment. This technology evolves every day, and this can change, this situation can change at any moment. And now, after all this explanation that we had, let's see how this actually works, finally. So here, I need to enable CDC in an Azure SQL. So here I use the storage procedure, system store procedure, SPCDC enable to enable CDC to a database. After that, I need to enable CDC on the table level. So SPCDC enable on the table level to enable CDC for one table. So the CDC needs to be enabled on the SQL side. I need to make the enable of the CDC in the SQL side. Then let's go to Power BI. Here I have an event string. In my event string, I use a CDC source. My CDC source is not fully active at the moment, but I already ingested some changes for our example. Our CDC source, we can see here on the configuration of the CDC source, is configured with a cloud connection to an Azure SQL. This cloud connection points to an Azure SQL, and I can choose the tables that I will ingest using this streaming. In this way, the event string will collect from Azure SQL all the changes that Azure SQL is storing as CDC changes. So I enable the CDC in Azure SQL, then I use an event string to collect the changes from Azure SQL and drop these changes in a CDC target. This CDC target is an event house, a Kusto database. So a Kusto database, which I'm seeing here, is an event house with a database CDC ingestion and a table fab CDC. Inside this event house and this table, I'm receiving the JSONs. and the payload of the JSON that I received are the changes that happen. We can see here in the OP the changes which happen. Here I'm seeing an OP-C. This means I have the creation of a record when record was created. And if I look the other ones, I have the OP-U. I have an update of the records. In fact, I have these instructions here. I have 3 updates of records. I updated 3 records and I inserted 1 record. So in this way, I have 3 updates and 1 insert. Okay. In this way, we received the CDC information using the event stream. We dropped the CDC information to a Custo database in an event house. Now we need to make the processing of this data, to take this data to the lakehouse. I can see the final lakehouse here with a customer table receiving this information. At the moment, I can check the records with ID 1, 5, and 12. Let's take a look on these records, 1, 5, and 12. It's waking up the lakehouse, just a moment. And there they are. I have one single version of each one of these records. Here we can see the 3 fields of a slowly changing dimension, exactly as I explained it. They have the hash, they have the start date, and these are the current version of these records. And the new record has a new ID. I can see the topmost ID is 3118. Okay. Now let's make the processing. The idea of the processing is that I'll get these 4 JSONs which are inside the Custo table, and I'll process them to insert into the lakehouse table. How is the processing? I have many functions here. I will summarize the explanation of this processing. So, I use an ingestion control table to decide the start date that I need to process. So once I decided the start date I need to process, I load the information from the Custo table according to the start date. If for some reason I don't have an ingestion control record, it means that I need to load everything and create a record in the end. Okay. A small check to see if I have anything to process. Then, in this cell, I'm breaking down the operations. I'm breaking down the operations U and C. This is only an example. I'm not implementing the operation D, the delete, but this is only a small example. For the operation U and C, I need to get the after fields. The after node from the JSON, the fields after the operation, this will be the new version of the records. I have a function here called add SCD fields, because the SCD fields, they don't come with the JSON. The SCD fields, they don't exist in production. What do I mean about SCD fields? I mean the 3 fields that I just showed in the lakehouse: the hash, the start date, and the end date. I need to add these 3 fields in the data frame for the processing. So I add these 3 fields in the data frame for the processing. This is just debugging. I read the existing table from the lakehouse. Then I need to process these new changes which arrive into the existing tables. I need to import updated records and import inserted record. The process is slightly different, especially because in the case of the updated record, I need to invalidate the existing month. So the process is slightly different. And finally, at the end, I save the table. I save the table into the lakehouse. Let's execute this. Let's execute this notebook. Run. It's starting the session. And processing the notebook. That's it. I completed the processing of this notebook. Now let's take a look on the lakehouse, how the lakehouse is. I can check the records 1, 5, and 12. 1, 5, and 12. Now I have 2 of each one. Yes, because these records were updated in production. Johnny became Johnny 4, Orlando became Orlando 4, and Lucy became Lucy 4. So all these 3 records were updated. Now I have 2 of each one. And I can control which one is the current version of the record by checking the DWN date as new. The new ones are the current version of the records, the new first name. The old ones were finished on a specific date and time. They were finished in this specific date and time, and another record took place at exactly same time. The start date of the new record is the same date and time as the end date of the previous record. Another record took place of the old ones. So we keep each change of the record. We keep a history of each change of each record. In this way, we can ensure that we will never create fake facts. Because if a fact happened, my company made a sale, there was an order in my company, and the dimension changed later, and I don't keep the history of the change, the fact becomes fake. I will be linking the order with a dimension record that is not the dimension record that existed at the time of the order. This is what I'm calling a fake fact that I prefer to avoid in most of the situations. And the inserted record is here as well. See, now the topmost ID is 3122. It was 3118 before, now it's 3122. It's a new record, an inserted record, so there is no old version. This is the first version of this record inserted in the table. In this way, let's review these steps. I enable CDC on the source. I used an event string to capture the CDC from the source and drop the CDC in a custom database. And then I created a notebook to process the JSON which arrived in the custom database and insert the data in the lakehouse following a slowly changing dimension process, the rules of a slowly changing dimension. In this way, we have the CDC ingestion from Azure SQL working. And we chose the CDC because we want to have slowly changing dimensions. If the slowly changing dimensions are not important for you and you don't want the slowly changing dimension, you don't need CDC at all. Use mirroring. Mirroring is better for you if you don't want a slowly changing dimension. If you want the slowly changing dimension, you need to use CDC. So, thank you very much. Let's take a look on the questions. So let's take a look on some questions we have here. Sanjay is making a very interesting question. When the table size is in terabytes, are there any implications of enabling of using CDC, or should we be using mirroring in this case? No, the result will be the same. The result will be the same. And the result will be similar, and the difference will be exactly if you want the slowly changing dimension or if you don't want the slowly changing dimension. This is mostly the implication. The bad side about the table being terabytes will happen in both. Will happen in mirroring and will happen in CDC. In mirroring, when you first enable mirroring, when you first make the enable of the mirroring, to first mirror a table in terabytes, it takes a lot of time. It takes a lot of time. So that's your bad side in mirroring. In CDC, where is the bad side? The snapshot. When you enable CDC, it will take a snapshot of the table, sending to you the JSON records with the R or P, the operation R, and it will be sending terabytes of data to you on the event stream. So both have this bad side. Both the mirroring or the CDC have the bad side of the first transfer of the table to the Microsoft Fabric environment. The transfer happens in different ways, but both have this bad side. In fact, based on my...
Dennis, please excuse me.
Yes?
So the final,
we are over time, right?
Final sentence from your side, my final sentence. Thank you very much. I learned a lot. And after that, I will add you or have our next speaker at the stage.
Yes. Thank you very much. It was a pleasure to be here. Thank you very much for our attendees. See you.
Thank you. Hey, Felix.
Hi, Tom. How's it going?
I'm fine. Thank you very much. A short question before we jump right in. And then, do you want me to post the questions or wait with the questions at the end? Or
Bring it on.
bring it on. So
let's make this super interactive. If there's questions, happy.
You with every single question, right?
Especially in the middle of my sentence, so that you completely derail me.
I am really good at that. So
awesome.
So then I will leave the stage. Can you please, before I do that, can you please share your screen? Yes, please.
Share screen. Okay.
Do you have a screen that you want to share, or?
Yeah. I'll leave it. I'll leave it to the imagination of the audience.
So
can you see my screen?
We are at the stage. So for whatever reasons, I like this red logo color thing for whatever reason. So do you want to be on the left side like Dennis was?
Oh, I don't mind. Left.
So then I like it if you are on the left side. So I will leave the stage. The stage is yours. Have fun.
All right, awesome. Thanks a lot, Tom. Hello, everybody. Well, as mentioned before, let's make this super interactive. If you have questions, hit them in the chat. And today I'm going to be talking about democratizing data and AI. And so I'll talk a little bit about some of the things that I see in the industry. We'll have a look at some practical examples, just for some of the trends or themes that I talk about, and then we're also going to have a look at not so much the technical bits of it, but then rather when it comes to the doing and how to orchestrate and organize these things. My name is Felix. I'm if you want to get in touch, reach out on LinkedIn. I live close by Munich. I work at a company called Databricks, and I've been in this. I actually come from mechanical engineering education wise. I come from big corporates or manufacturing, large manufacturing enterprises. And well, now I'm working for a US-based software company called Databricks. I'm not sure whether there's live reactions here. At least I haven't seen any. Anyways, we can try it. If somebody knows whether there's live reactions, who of you have heard about Databricks? Or who of you have heard about or heard the name Databricks before? Tom, do you know whether there's live reactions in this stream thingy? I take it as a no. I'll just continue. Well, Databricks was...
Oh, no? Here I am. Sorry. Yes, there's live interaction. And I will pass it to you directly. You can see it. But for now, no interaction right now. So I consider, when you ask, do you know Databricks? All the attendees, watchers were, what a silly question. Of course we know it. At least there's one person currently at the stage with you who's working with Databricks, who knows Databricks. So, and now this person is leaving the stage again. Please forgive me.
All right, awesome. Cool. So quick recap. So since everybody knows Databricks, awesome. Databricks was founded in 2013. Our founders, they come from academia. So the whole concept of generating knowledge and then also distributing that knowledge in a community, in an open source community, is really ingrained in our DNA. So it is not actually surprising that some of the new product announcements or features that Databricks announces are actually the follow-up to some publication, some of for example, a research paper. We have more than 10,000 customers globally, and well, as mentioned, open source is at the heart of Databricks. Here you see some of the technologies that we built at Databricks. We tested that with our customers, and then we donated it to Linux Foundation, Apache, and from there gave it over to the community in order for these technologies to thrive and prosper. One of the, I think, really landmark architecture paradigms that Databricks pioneered is the Lakehouse. So the Lakehouse is a concept, and I assume that if most of you know Databricks, then most of you have heard of the Lakehouse as well. So the idea in the Lakehouse is that you bring the performance and the reliability of a warehouse to the scalability, elasticity, and also cost effectiveness of a data lake. And you do that by really building a house. So what does the house stand on? That is open object storage with the hyperscaler. We don't, like the Lakehouse doesn't reinvent that in any form or sort. But on top, like every good house, you have a, as you say in German, Bodenplatte. So that's the concrete layer on the bottom of your house. And that consists out of a unified storage layer and a unified governance layer. So why unified storage? Well, any kind of data, whether structured, unstructured, whether used for machine learning or in multiple concurrent queries by data analysts, is stored in one open source a storage format that is that has transactions and is asset compliant. Now, on top, you have unified governance. What is unified governance? Governance from any, like governance of any asset in a data and AI operation platform, however you want to call it. Now, this is structured data, unstructured data, machine learning models, some compound AI systems, ETL pipelines that move data from A to B and do the transformations, dashboards that sit on top of it, everything in one layer of governance. And then on top of this, just like in the house that I'm sitting in, you have different rooms, so to say, with different tool sets for the people who live in that house. That is the data scientist, the data engineer, the data analyst, the AI engineer, and so on and so forth. Now, what we at Databricks are really proud of is that ever since the Lakehouse was put forward as an idea, pretty much every software vendor in the data and AI space has adopted it and has their version of a Lakehouse. There is a Microsoft interpretation of the Lakehouse, which is actually tightly linked to Databricks with Azure Databricks. There is a Snowflake interpretation of the Lakehouse. There's even an Oracle and the IBM interpretation of the Lakehouse. So I think it is fair to say that the Lakehouse as an architecture is kind of mainstream. And with that, we have the foundation to talk about the actual topic that I wanted to talk about today. So now, when I talk to especially our customers, so in my role, I work with customers all across Europe. And one of the things that we see is that with the Gen AI hype of the past 2 years, the topic AI is much more present in today's society. And member of this society are also the business people, the decision makers, the CEOs of the companies that we work with. While data and AI had, before the past 2 years, rather been an IT topic, it's much more now becoming front and center for business as well. And then obviously that raises the question, well, how do we turn that into profit? How do we turn that into competitive advantage? And the follow-up question from that I like to ask as well, how do we democratize or distribute access to insights across a complex organization that consists of out of thousands or tens of thousands of individuals spread across different cultures and different places on this world? So with that, I want to talk about 3 themes that I derive from this question. Well, how do we turn that into money? And the first one is obviously, if you look at profit, that you can increase your profit by increasing your productivity, i.e. reducing your cost. So knowledge workers benefit if they have to spend less time in order to find the information that they need, the insights that they need. Theme number 2 is about, if you look at not your cost, but your revenue that comes in, then that revenue comes from your customers. How do you increase, or how can data and AI help to increase customer loyalty, to protect this existing revenue? And then third but not least, building entirely new services and products that rely on data and AI that generate new revenue streams. All right, cool. Let's jump right into it. Theme number 1. Who of you, since you cannot have any like hearts, likes, and that stuff, I think I'm going to stop with asking questions. So I think everybody has used ChatGPT before. I really like Perplexity. This is something that I use quite a bit. And Perplexity is actually doing a pretty decent job at generating SQL code. So if I, for example, put this prompt in, I say, hey, can you give me some answers, or let's better take, turbine fleet. That fits better. So give me a SQL code that returns the forecasted energy production for my wind turbine fleet. Now you can see the different sources. You can see the answer makes sense. However, the interesting or the important bit is that you need to adjust this query based on your actual database schema. Now, if you are a data engineer or a data analyst who knows how that data estate looks like, where to find what the actual name for this table should be, then this is a really good tool in order to boost your productivity, because you don't have to look up all the syntax. You just have to exchange these things, check whether it works, and maybe debug if necessary. Now, what if I wasn't one of the few people in the enterprise, maybe one of the 10% who knows where to find their data? Well, then I am dependent on the more traditional way how to distribute information in the enterprise. Now, a classic example would be, we have some ETL pipelines that ingest data from different places. And I now have a dashboard in order to distribute this information with the rest of the organization. So you have a dashboard here, you can have maybe some filters, and then you make your way through it, and eventually you also find this bit that for the right fleet of turbines, this is the energy forecast. What if you are actually able to talk to your data? Now, text-to-SQL is not exactly new. Text-to-SQL has been around for the past 10, 15 years. However, when you, and now I'm jumping back here to the, remember, we had the lakehouse. When you have all the metadata concerning your data assets, and if you have the lineage between your different data assets, you can start to understand and make sense into your data. So as a matter of fact, the engine that is running underneath here and producing answers understands the data that is there. It also understands what the company, so in this case, energy company that has offshore wind parks, what the company or the enterprise is talking about, the specific jargon of an organization that can differ wildly. And now what I think we'll see much more in the future is different ways of interacting with data, moving beyond the traditional dashboard into something like, some people call it generative BI, others call it Genie data rooms. I don't know whether there's ever going to be this one term, but I think we'll see much more of this, where you interact with your data, where you can obviously get some visualization to it, and where you can also inspect your data. So you can have a look at the code that was generated here, see, oh yeah, this makes sense, or no, it doesn't make sense. And then you can give a feedback here, where you say, hey, this is not a good answer because of da-da-da. And then you take it from there. Now, this is the interface of Databricks. Since most of you know Databricks, I assume that you've also seen this interface before. However, since I think most of the audience here is data and AI professionals, what about the 90%, the rest of the organization, who are not into data and AI? They are a field service technician. They've never heard of Databricks, and they will also never hear of Databricks. I mean, why should they? Databricks is a specialized tool for special type of professionals. Now, I believe what we will also see much more is that this intelligence engine, if you will be abstracted behind APIs. And then from there, connected to any kind of, this is a custom application where the field technician can see, hey, we have had a drop in power output. Looks like one of these turbines is not okay, most likely the one where it says red. And where we take these existing applications. So this here is nothing new, that you have a little map and some geo coordinates and some stats on the last couple of hours. But we augment it with AI-powered, some call it co-pilots, others call it agent systems that help the worker out in the field do their job in a more productive manner. And obviously, this is not just about getting information out. So start with this turbine, continue with that one, but also about modifying data in the system. So now go to the system that holds all the service records, something like a ServiceNow, and flag this turbine 1, 2, 3, 4 as under maintenance. I believe that we will see that much more, and I also believe that from a user interface, the end users will probably not notice that much of a difference in terms of the UI, but they will notice a difference in the user experience, so UI, UX, because the experience will just be much more immersive and specific. All right, so with that, we can actually skip a couple of the next slides, which is awesome, because we just had a look at this live, and this is precisely what I was talking about. So how can we get from the 10% in the organization to all of the organization and supply them with relevant insight? Now, what makes this possible? Databricks on top of the lakehouse. So you have unified storage, unified governance, and then specific tooling for different data professionals. Introduce that concept of a intelligence engine. You can call it Databricks IQ. You can also call it something else. And we believe that this will be something that we will see across all kinds of data and AI platforms going forward. And it is this intelligence engine that understands the metadata that sits in our unified governance layer, and then turns that or uses that metadata in order to generate relevant insight. The rest of it doesn't change. So it is still built on an open data lake, something like, for example, Azure Data Lake Storage, that you can access your data from Databricks, Fabric, any other type of compute without any limitations. Essentially, Databricks, with the idea behind the data intelligence platform, started doing what we've been actually telling our customers for the past 10 years. It's like, hey, data and AI are going to disrupt your industry. If you use data and AI, you can gain a competitive advantage. So if you think about that, if you have a, I don't know, automotive car manufacturer, then AI can, for example, help to reduce maintenance intervals and cost on the shop floor. AI can help predict better sales, or maybe even generate marketing content. At Databricks, we're doing the same thing. Just our product is not a car or a or flying people across the country. Our product is a data platform. So what we started doing over the past couple of years is consequently infusing data and AI into every bit of this platform experience. And the whole thing around intelligence engine is just the tip of the iceberg. So what we just had a look at in the platform, that's really just the tip of the iceberg, because this is something that the user actually sees. There's a lot of AI-driven optimization underneath the covers, whether that is how data is written on storage, how queries are executed on the go, or how workflows are scheduled and distributed. All of this is driven by AI. So essentially, you could say Databricks is eating their own dog food by consequently doing so. Now, if we look at theme number 3, then we have the idea of, hey, and I mean, we could make it number 3, we could make it number 2. That's the same one. I mean, it's just different sides of the same coin. So one of the big excitements that was probably there 2 years ago is that finally chatbots seem to be generating somewhat sensible answers. So the answers that came out of a GPT-powered chatbot just sounded a lot better. Now, very important, and I think that was then also learning over the last 2 years, that only because something sounds better, so only because somebody speaks nicer, doesn't mean that it is more accurate. And if now your chatbot suggests that you should buy a product of the competition, then okay, maybe that is embarrassing. If, however, the chatbot hallucinates a refund policy that doesn't actually exist, well, if that happens at large, it starts getting really expensive. And well, then obviously, if the chatbot doesn't honor governance and just blasts out all kinds of information that are not supposed to be shared, well, then you may be in deep, deep trouble. So this is why it's also not surprising that a lot of the customers that we work with say, hey, this whole AI and Gen AI bit sounds amazing. I do also understand how this can help us either reduce cost or generate new revenues. However, I don't feel 100% comfortable pushing that stuff into production. So let's have a look. What's the problem? If you look at, for example, Perplexity, it is tempting to think that this is all super simple. So you have an input, you have the super powerful model underneath, and then, whoops, you have the super powerful model underneath, and then you have some output. However, this is not how it works. Who of you remembers this paper from 2015, where researchers at Google talked about technical debt in machine learning and also coined the term of ML ops, really? Now, in this paper, the conclusion was that the machine learning model, so the thing that in public perception most people focused on, was actually the smallest part of the problem. Because whilst obviously important, there's a lot of other things around it that need to go hand in hand for a machine learning model to work in production. Now, for large language models, any form of Gen AI, AI in general, this is the same. Now, for an LLM, you have different tools here in order to orchestrate that and to also handle feedback and learning on the go. But the same concept holds true. So at the center of it, you do maybe have a very powerful large language model, but around it, you need a lot of capabilities for it to work in a reliable way. And I do think that over the past 2 years, there's been a lot of advancements introducing, for example, chains, so that we can give it some structure, introducing routers to do, conditional differentiation, introducing agents that can actually take action, and guardrails to help with adhering to ethical principles, quality principles, and the forth. Now, the other thing that we see in the industry, and this is already outdated because this talks about Llama 3. In the meantime, we're at Llama 3.2, and this gap that you have here between GPT-4o and Llama 3.2 is even closer, and it will continue to close in. If you look at it, then on the one, then there's three observations on this chart. So one is, if you look at MLU 5-shot performance, you can score higher than 100. We are getting closer and closer to 100. Now, if you look at the turquoise and the purple models, so that's proprietary versus open source, we see that there's a convergence between the private and the open source models. And then it seems to be a trend going forward that the models with the most investment, so that is on the proprietary side, obviously GPT, and on the open source side, Llama, will probably be driven only by a very, very few companies. We probably, and now this is my takeaway here, will see some kind of convergence and commoditization of what an LLM brings as a capacity, as a capability to data and AI. Now, the other thing is that while the MLU benchmark really talks about a broad range of knowledge, ability to reason, and something that goes rather into general AI, what most of our customers in the industry really care about is a rather narrow and specific problem. So for this narrow and specific problem, a model or an AI system does not necessarily have to have seen everything that's been on the internet before. So we see that there is a segmentation. We see that smaller models that are equipped with specific, maybe even proprietary knowledge, so knowledge that only exists within that specific enterprise, outperform these generalistic large language models, both when it comes to quality, specificity of the answers, but also when it comes to cost and latency. And with that, having a look at the theme again, if the large language model that you can access, so to say, off the shelf, doesn't control sensitive or proprietary data, then the compound AI system is the counter proposal to that, so to say. And if you want to read up on it, there's actually a great paper that had been published beginning of this year. Check the QR code, because there, again, one of our co-founders, actually, Matej Zaharia, talks about how we see a shift from these large language models of general intelligence to compound AI systems, where think of microservices architecture in the age of AI. You have different components that play together, that are orchestrated in a meaningful way in order to solve problems in a much more narrow problem space. And obviously, you will still have large language models in there, because large language models are still good when it comes to reasoning. Large language models are great when it comes to generating nice text. And obviously, this is not just limited to text. You can also have stuff like generate images, videos, and so on and so forth. But we equip it with tools to, for example, retrieve some data from a database, or to make a call to an external API, or to look up some documents. So the classical thing that you would have in retrieval augmented or generation, or to do a calculation of whatever form or sort. So this could be expressed as some, I don't know, Python code snippet. We believe that this is what we will see much more going forward. And OpenAI is probably most known for the whole movement in the AI agents space, but there's actually a plethora of cool small startups that put together agent frameworks. Now, obviously, Databricks, being a general purpose data platform, comes with these tools as well. And we can, I mean, before we continue with the slides, let's maybe just quickly jump into the platform. So what I opened here is the playground that you have in Databricks. So you probably know that on Databricks, you have the possibility to pick any of the frontier models, like, for example, Llama, but you can also create your own models and host them on the platform. So you really have both. What I was playing around with just before the session here is that I took a Llama 70B, just like it is, and I asked it, hey, can you suggest me what I should pack for my next trip? So since Llama really wants to help me, it says, I've just found your user ID. I don't know where it would get that user ID from, but apparently it has some idea about how to get to it. And just like it made up this user ID that doesn't exist, it also made up my destination and the travel dates. So subsequently, the packing list recommendation is somewhat generic and doesn't really help me forward. Well, that doesn't mean that Llama is not capable. Llama is very capable. And what you can see here is that Llama did the right steps, right? So it's like, okay, so who are you actually? It then thought about, okay, you are looking for you're doing a trip, you're flying somewhere. Okay, you probably have a destination and you have a certain travel date. Now, this is all good. Llama created placeholders here. Just since it doesn't have that specific information about me as a customer of this, for example, airline, the advice is just not very helpful. And you can see that here with the built-in AI judge, where the verdict sort of says, yes, it's safe, there's no harmful content in here, but the result is just somewhat irrelevant. Now, I did the same thing here side by side, again using Llama, but I provided Llama with two functions. And these two functions actually get the current user and that flight number. And this is something that obviously you wouldn't want to expose on the open internet, because this is sensitive customer data that you want to control. Now, and we'll talk about that in just a second. Now, with the same prompt, you can see here how the large language model reasons. So get the current user. This is some pseudonymized user ID. And then from there, you can get to the actual booking. You see that we're flying from CLT, I think that's Charlotte, to San Francisco. And it's on May 4th. Okay, so it was in the past, anyways, with British Airways. Okay. And here I get a good a recommendation for what to wear based on the weather forecast for May 4th and the subsequent days. Now here, AI Judge that is baked into the platform says, yes, it's safe, and it also seems to be relevant. Now, this is just one example for how tools, functions, agents can be used in conjunction with large language models in order to, in this case, generate a more bespoke customer experience. Now, again, the first ones to introduce the concept of functions inside of their large language model service were OpenAI. Inside of also at Databricks, we believe that it is crucial to be able to control this, which is why those functions, so if we take, for example, this function, that function is governed by the same layer of unified governance that also takes care of my tables, my volumes, and again here my functions. Now, my function that I just showed you is it's a select statement, and that points at a table here and another table here. So while I can obviously govern permissions on that given function, the underlying data, so if we go back here, the underlying tables, they have governance as well. So this is the place where you can then also make sure that, for example, customers only get access to their respective data. And now from an internal perspective, that maybe not every analyst at this imaginary airline is able to see every transaction in every country. So this is where you can implement a row-level security, and obviously also column-level security when you have things like PII, you want to do automatic masking of data, and so on and so forth. Plus, you obviously have all the lineage and the history. So this is where we believe that when building compound AI, it is crucial to have governance and quality control. And you can only have governance and quality control if you have a unified platform that brings all of these pieces together, where you can see where that data that you infuse here and that comes back here as a result actually comes from. And that is not just relevant for the data engineer who has to debug this, or the data scientist who has to debug this when something goes wrong, but this is also super relevant when you have an auditor that comes around the corner and says, hey, your data and AI powered service suggested this or that at this point in time. Can you explain why? And this is where you then really want to make sure that you have things like inference tables, so all the prompts that go in, the results that it produced, what version of a model did you use at that point in time, and what kind of data went into it at that point in time, which may be months back in the past. All right, so this is theme number 3. And what we just saw in the platform as well is the AI agent framework, in this case at Databricks, but you can also find that within other data platforms, something similar at least. And typically what we see from an approach perspective, so you obviously want to gather the requirements, build a first proof of concept, you iterate that with test users or subject matter experts, and then you start optimizing for cost and latency. Cost and latency, once you have quality right, cost and latency are usually big headaches when working with large language models. And then you want to deploy that into production and monitor the whole thing continuously. All right, cool. We just saw that, so we can skip it. And if you want to take the data intelligence platform for a spin, do have a look at the generative AI cookbook. You can find it via this QR code. This is a great resource, actually, written by our advanced AI research team between New York and San Francisco, who over the past 2 years have obviously experimented a lot. And in this cookbook, you don't just find some demos and stuff that you can try out, but you also find a lot of useful context and takeaways and learnings over the past years. All right, until here, we talked about some of the themes that I see in the industry. We also saw some examples how to do that hands-on, how to build a very simplistic compound AI system. Now I want to talk a bit about an aspect that tends to fall short, especially when you are in an environment that is very technology enthusiastic and very technology driven. So I'm talking here from my own experience, working at companies like, for example, ABB. So that's a big energy and automation multinational, industrial multinational, or Schaeffler, which is an automotive supplier. And there's typically this thing of, hey, there's this new thing, something with, for example, data and AI. Let's buy some technology. Technology is thrown over the fence and somehow doesn't stick. Now, my personal journey is at ABB. I was building data platforms in the context of, well, it's industry, it's IoT, industrial IoT platform. That is actually where I started using Databricks back in 2018. And now I joined Databricks, where I help our customers adopt these technologies. So this obviously, in my role, includes a lot of evangelism, but it also includes a lot of hands-on advice, like this is how you can actually do it. Now, this bit of going from where we are today in many organizations to actually becoming data-forward organization, where you do data-driven decisions, where you let the data decide, where it is really something that is ingrained in the culture, is not easy and it takes time. It is not just done with throwing some technology over the fence, but it's really about transforming business and culture. And now, some of the challenges that I faced over the years in the companies I worked previously, but it's something I actually, quite honestly, also face at Databricks, is that in order to become data forward, you need to shift from a project to a product mindset. And it is something that I find myself, or sometimes I catch myself falling back into project mechanisms, because in many ways project mechanisms, bias for action, are just really good when you need some quick win. It's like, I want to get here, so I just do this and that. But when you are building a product, something that is supposed to be self-sufficient eventually, something that is reliable, stable, that can be really counterproductive, falling into these project pitfalls. Now, also a challenge that I see is this where to start and how to expand. What I actually, the problem that I had when I was at ABB, for instance, we built this really cool data platform. And well, it was actually an IoT platform, and we said, hey, the platform is there. This is awesome. Everybody used it. And the different lines of business, so our internal customers, they're like, nah, I don't really get it. Show me somebody who's already using it. And we would say, nah, nobody really yet, but you can be the first one. And they would say, nah, I'm not sure. I think I'm just gonna build or buy my own thing. Now, how to start and where to start and how to expand is something that is quite a headache. It has been quite a headache for me. And then the next thing is also that there is obviously central platforms that try to address a need, but then there's also very much business-driven initiatives. And in many, especially larger organizations, typically the central functions are cost centers that provide some general capabilities and try to enable the business to do their job well. However, the entities who hold the budget and also the decision powers is often within the business. And that can create friction, and in the best case, this friction or this heat generates change and brings the organization forward. The worst case, this friction just grinds both entities within the organization and evaporates and heat stress and bad feelings. Now, what we see, what I see in particular is that, especially in a tech-centered industry like it is data and AI, we love talking about platform, about the tools, about the features, about the technologies, and we tend to forget a little bit the process. So yes, we have a data platform, that's awesome, but what's our operating model underneath it? And we also tend to forget about the people. So training and enablement for everybody who is working on, for example, the Databricks platform, thumbs up. I think this is something that we are all well aware of, that this is needed, and this is something that is happening as well. However, if we want to make this this idea or this concept of democratizing data and AI really stick, if we want to sustainably impact culture, change culture, transform the business, then we have to think broader. We have to think about, okay, how do we enable every single individual within the organization to make the most out of data and AI, given their role and given their tools. And this is usually a framework where then really starts to get interesting for many of our customers. When you take this broader look at things, where you say, okay, what is actually our purpose and what is the portfolio that we are working on? And then it's platform, process, and people governed by a certain practice, and then obviously also protection, especially of sensitive data of the employees, of the customers, and so on and so forth. All right, cool. So maybe one more observation that I see quite often. Going back to this bit of where to start and how to start, I think many organizations first go into this hub and spoke mode, where you have a central COE that builds data and AI, and then the different domains. So business comes to them and says, hey, we would like to get this or that, and then the COE delivers that. Obviously, that makes all the domains around it dependent on this COE. There is the notion of establishing a data mesh where you have data products that are built by self-sufficient teams, and the products themselves really are self-sufficient as well, so they are able to describe themselves, and so on and so forth. So this is, while it is a great aspiration, in reality, this aspiration can really be hindering, because it is really difficult to achieve, especially if you have larger organizations. This requires a lot of change, a lot of culture to get to. So what we see is that usually there's a bit of a mix of both. Now, there may be some domains in the organization that are quite mature when it comes to data and AI, who are able to build their own data products. Then the central COE should be an enabler for them. There are other domains on the very contrast, who are not self-sufficient when it comes to data and AI, and who really don't have to be either. They will never want to be building their own data products, and they will always want to be dependent on this central COE to build data products for them. And then there are some that are maybe open to becoming data and AI self-sufficient or proficient. Those ones, then the central data platform, the central COE, can nurture and continue to develop. And now this is typically the journey that we see, where you go from, okay, you start with a couple of friendlies that are open to the topic of data and AI. You find the first couple of good use cases, and then from there you expand into the rest of the organization until there's some kind of equilibrium then, where you have a healthy mix out of independence and codependence when it comes to data and AI across the enterprise. All right, now a couple of takeaways from also my personal experience. There is, again, if you follow this QR code, there is a nice executive guide that adds a little bit more color to it. But I think it is not just enough to build a platform that works and does what it should. It is important to establish community and really a customer experience, a user experience around data and AI and the platform that enables data and AI. And what I also learned now working in pre-sales with a software vendor, when I look back at my old self from, I don't know, 2018, it is super important, whether you are selling to another company or whether you're selling internally, that you sell on value. That is before you deliver the value, and then obviously also after you delivered it. It is important to translate between business and technology, and it is super important to establish a trusted operating model that is able to deliver the capabilities that the platform principle provides. All right, if you now take these learnings, put them on the high level architecture of the Lakehouse, then again we come back to unified storage, unified governance. This is where you have a solid platform, where you then establish process around the different practices that you build on top of this platform, and then really educate the people across the entire enterprise what they can do with data and AI in their respective job with the tools that they have, in order to then really effect long-term change, sustainable culture transformation towards a data-forward company. All right, wrapping it up, I believe that when it comes to data and AI, it's crucial to control costs and privacy. I do also think that this paradigm of the data intelligence platform that infuses intelligence into a data platform is the way how to democratize data and AI, especially in large enterprises that tend to be fragmented and complex. And I also believe that it is a journey. So it is not enough to just take technology, throw it over the fence and see what sticks, but it requires process and people and the platform all together in order to make it sustainable and effective. In case you haven't used Databricks before, or you're not using it currently, I went ahead again and I asked Perplexity how to try out the data intelligence platform, and it did actually point me in the right direction. you can go for a free 14-day trial of Databricks via this QR code. And now we have 3 minutes left for questions. Tom, are there any?
I can tell you not for now. So probably it's also related to the amount of information you provided. I learned a lot. So, and because there are no questions on YouTube or in the chat, I just have to say, thank you very much, Felix. And I just learned, so please forgive me for not inspecting that much, or every now and then I am in Munich because I work for a company located in Munich, living in Hamburg. Nevertheless, I am in Munich every now and then. Maybe we can sometime meet if I will be the next time in Munich. Would like that.
Sure. Would love to. From Databricks, we're actually hosting a pretty big data and AI event. I would say it's even the biggest data and AI event in all of Bavaria this year. It takes place on November 7th. I'll put a link into the chat. And Tom, hit me up, and everybody else, I'm on LinkedIn. Find me there. And
thank you very much, Felix, for this interesting session. I will remove you from the stage and add Marcus to the stage. So because I met Marcus, I did not met Marcus, so that I have at least a couple of seconds to talk to Marcus, ask him how it goes and things like that. Felix, thank you very much. And
awesome.
Enjoy the rest of the weekend.
Bye-bye.
My friend Marcus.
My friend Tom, how are you doing?
Hi. I'm doing fine.
I'll give you a hug, right?
To everyone who is already watching, have a closer look at what's behind Marcus' right shoulder. Marcus' right shoulder, try it again. So to everyone who is interested in this data modeling thingy, I can recommend Marcus' book a lot. So with this said, I have to, how are you doing?
I'm good. I mean, looking forward to this conference. I have a little bit of throat thing, so apologies that I will take a sip of...
Then just stop speaking, yeah. Right? And start dancing. And with this said, I leave the stage and leave it all to you. Looking forward to it. Marcus, thank you very much.
So I already shared my screen, so as soon as Tom brings this forward. Welcome
I will take care of that.
Nice to meet everybody here at DataBash 2024. I'm currently not seeing my own... okay, so you should see my screen now. If there's any question, please put them into the Q&A window, and hopefully Tom can forward them to me, because I'm not sure if I will keep track of the questions, and maybe it's also a little bit of delay between what I'm doing and what you see on YouTube then. Yeah, fabricate your data model. Let's jump into the topic, right? So data modeling is very to my heart. That's why I wrote this book. This was like an urge. I had to write this book. And some things of, then if I introduce to people, right, I always tell them I work with models, and then they have different pictures in mind. Of course, all of my customers and clients, all the people I work together are beautiful, male, female, diverse. Everybody's included here, so this should not be a sexist picture here. But what I'm actually doing is not working with beautiful people. I mean, that's not what I'm paid for. I get paid for working with beautiful people. I'm getting paid for working with data modeling, working with data models, and bring the data which is already existent through a good model to its shine. And this leads me to two goals for today's session. So one goal is that you'll learn that data modeling is very, very crucial. If it is about Fabric or not, doesn't really matter. The first examples I will put forward are not with Fabric. They're purely in Power BI because it's easier for me to demonstrate all the issues you can have within your data. This will take about 20 to 30 minutes, and then the rest of the time we will jump over to Fabric and see and learn how you can achieve a good data model in Fabric. There's more tools, so this is the good thing. Fabric is nothing dangerous. Fabric is just Power BI on steroids. We get all the good stuff to about data engineering and modeling data directly to Power BI. This is what I look at Fabric. So Fabric is nothing different if you already know Power BI. So why is it so important to model your data? And the thing is, Power BI is different from other tools. It's model driven. If you previously worked with Excel, for example, Power BI report builder or reporting services, those tools, they need like one wide table. There's some outages here. Yeah, and then you put your pivot table on it. Or with report builder, you have like per data set, per thing you want to show, right? You have one data set, and this data set, like not the Power BI data set, but I'm talking about a report builder data set, is one wide table, and from there you take everything you want to visualize in the report. Power BI is different here. Power BI is optimized for a star schema. This means one big table, one wide table is not a good idea. It works, but it has like big disadvantages, which we sooner or later will discover. So you should have like relationships, you should have unidirected filters, because this is what like the Vertipack engine, which is the engine behind, like the database behind Power BI and also Fabric, is optimized for, and also the DAX language. So if people complaining about how complex DAX might be, and it's really hard to like calculate this certain KPI or measure, maybe it's because like the data model is not a star schema. It's also like better for the report authors. Star schema is very intuitive to use because you have like these folders, and within the folders you have like different attributes, and it's the whole idea. One of the reasons we build a semantic model like we do in Power BI is to make the life of report creators, of people who need to analyze the data, easier, because it's like, we could also like it make the other way around, right? Teach everybody PySpark or SQL or whatever, and then you just give them read access to your production database. Nobody would do that, right? Hopefully nobody does this, because the source system is not built for that, and like writing good queries, performing queries, and it is a complex thing, right? So not every domain user should have the task of learning the languages. So we like want to make it easier for them, and a star schema is one of the ways we can make this easier for them. And the other thing is, and there's like some danger in that, if you want to save some time and say, yeah, just put it there, right? It's just a working proof of concept, right? But as soon as people start building reports on this working project, on this proof of concept, you later cannot really change anything in the data model anymore. If you change the semantic model, you move things between tables, you remove tables, you add other tables, the reports will break. So this is, you have to make it like a good, nothing is perfect, right? But at least have a good data model to begin with. Because if you start with an ad hoc data model, as soon as start others coming and build things on it, this might like be a really, really bad situation to be in with. And most probably they will not complain about Power BI or about the report, they will complain about your data model. If something is not working, then they will point to the person who built this data model. So I will not go into details of these things here, but there's like some anti-patterns, right? A single table is not a very good idea, or like having one table per source file. And this is what also is true not only for Excel or Power BI, self-service Power BI if you load Excel files, but this is also true for Fabric. So Fabric comes with this direct lake storage mode. I will talk about this later, which offers you that you put something in the data lake, right, which is a Parquet file, a Delta Parquet file to be more specific, and you load things into there. It's really easy. You can upload anything there and convert it to a Parquet file, and then you can just take this file and make it part of your data model. And I see danger in that. This might be for very narrow use cases. This will work, that you just take the data you get, put it in the data lake, and then use this in direct lake mode to build Power BI reports on it. But in many, many use cases I can think of, this is not a good idea. So you still need to change the data. And this is why I will use some time to demonstrate why it's a bad idea to just take one example and then use it to build your reports. Also others like fully normalized schema, header detail, data vault. These are valid data modeling approaches. They have their use cases for certain things, but if you want to load it in Power BI, you should transform it to a star schema. That's the bottom line here. Enough talking about slides and so let's jump into the demo, because I want to demonstrate a lot of things. It's much easier to understand if you see the things instead of just believing me talking about something. So what I've got here is an empty Power BI report, Power BI desktop file. There's nothing in there, right? There's no data in there. And there's this use sample data. I'm not sure if anybody of you ever used this. I use this as a bad example. So on the one hand, I'm very thankful that Power BI and Microsoft put some sample data in there. You can also like use this tutorial to learn how to make use of this data, but I just load this sample data. So obviously Power BI comes with an Excel file, because the next step is that it will show us this Excel financial samples.xlsx file, which comes with a table and a table, a sheet, right, a worksheet, and a table formatted. It contains the same things. So if I just take the table, we see this is a white table, a data model for just one table. So on the one hand, I'm thankful because this is not a very good example, so I can demonstrate how you can make a better data model out of that. On the other hand, I see danger in that the people think if Power BI comes with an example like this, that maybe people start thinking, oh, I can also like put everything into one table and then use it in Power BI. No, this would be the wrong message here. And of course, I can load this. Usually, I tell everybody as soon as you see also the option of transform data, press transform data, because you usually need to transform the data if it's coming from Excel. There's never I've seen that somebody can import Excel files, and those Excel files already representing a star schema. This never happened to me. Maybe you're more lucky than me. So usually I tell everybody, don't click on the screen button, click on the white button. But just to make clear what's happening if you click on the load button here, nothing special happens. Everything is loaded into Power BI now, and on the right hand you will see that like this is the financial tables, and all the columns you have seen in this dialog will appear as columns in there. Why is this bad? There's a lot of things which are bad, and I will go through some of the steps you need to do here. This is bad for one reason. Let's take the best baseline maybe. I jump to external tools, start DAX Studio. If you're getting serious about data modeling and performance tuning, you need to install DAX Studio. So talk to your IT department if it's not available for you. It's an external tool, but it's like if you go to learn.microsoft.com, they will give you hints that you should use DAX Studio for this. So this is like more or less an official external tool. And in there we have a lot of features I will not talk about, but this is a few metrics. And if we look at few metrics, we will see that there's like, funny enough, there is more than one table, right? We only loaded this financial table, but it also shows a local date table and the date table temp, whatever it means. And this local date table is not small, right? It's not big, but it's not small, but it's adding extra data here. So to my 5 megabytes, so this is a really small model, right? 5 megabytes, 84 kilobytes and 36, so like 100 kilobytes are added to this model. And I didn't ask for it. And the reason is Microsoft does this, and it's also hidden, right? In Power BI, you will not see those tables. Microsoft does this to please very, very, very beginners. So Microsoft has this mantra to make it possible like to download and onboard you to Power BI in 5 minutes and then 5 seconds to wow. So you load your data and you can start building something. For example, if we jump back to Power BI, we get automatically, and this is the reason for this table, this date column is transferred into this date hierarchy where we have a year, quarter, month, and a day, and they can then analyze things by year, for example. This is for the very beginners. You should not use this. So what I will do, the first thing is I turn this off, and you should also do this. So I start under options and settings, under the options, and you will find under the local table, the local file, current file, data load, you can then turn off this time intelligence thing. So this will get rid of this table. You should never use it. You should always turn it off, just for very beginners. And you're not a very beginner because you now learn something about Power BI, so not a very beginner anymore. I would also recommend you that you jump under and also under the global options under data load, and then turn this off for all new files, right? I do not turn this off because I have to demonstrate the bad consequences for this. This is where I keep this turned on, but you should turn this off. This is the homework for you. If you do so, this disappears, and as you can imagine, if you turn this off later, it will maybe either break or at least like change your reports because columns are missing. So you should turn this off from the very beginning. If I again jump over to Doc Studio, make a new file here, and again view the metrics. Reconnecting. Do I need to open it here? No, it should be open here, like home, and then refresh, connect, Power BI, and then again under advanced, view metrics. Then now we got rid of these extra tables, and we don't lose any file space here. And as you also can see, which is like really curious, also the size got down to 190 kilobytes instead of previously it was 5 megabytes. So for some reason it changed something here, and it make it a real small model now, just by turning on this table. But you will tell me, but I need a date table, right? I need years and so on. This is easy to create. We can just jump here, not here, but under modeling, and then I would create a new date table, DAX expression. And you can use like Excel, you can use like maybe you have a data flow or a data warehouse where you have this table already at hand. But it's rather easy to create this calendar here. So what I will use is a date, and then I will tell it, you know, there's this calendar function where I build up, not calculate table. I want to have calendar. Wow. So, and I want to start like with the first date should be like the year of my minimum date from my fact table, the financial table, right? And it should start at the 1st of January. And it should go until, again, I copy paste more or less the same thing, but it should go like to December, the last day of December, in the maximum date, right? This is what this date table should look like. It should cover the full years because you will need this in DAX for if you want to use those time intelligence functions. And then you can, with the help of 8 columns, you can just add more columns, right? Of course, you could also use coming here and add columns in here, but I want to have like just one single expression to build the whole table. So this gives me a list of all the dates, and then maybe I add a year, which is the year. I really don't like this IntelliSense here, hiding my whatever I'm typing here, or the month. It should be like, which could be the format function, and the format function I tell again I have this date, the date column. I should put in parentheses. And the format function I can then tell, please make this the month as January or and so on, right? If I jump over to the date table, you can see this is building up in January. Maybe you're telling me, I use Power BI in English, right? But I want to have like the month name in a different language. No problem at all. This month function accepts, for example, I can pass in my German or even Austrian, like there's an Austrian version of German, which then shows Jena instead of January. So very easy to build, right? And this is what you should build. Again, then we add this date table. So now the model is again bigger. So if I jump back again to my DAX Studio to demonstrate what we're adding here, connect here, view the metrics, and then we have this date table, which is 1 megabyte, right? Which is rather big compared to what we're having here, and it will be bigger and bigger the more columns we're adding here. But there's no way around, right? Usually, this is an extreme example because like usually the dimension tables are much smaller in terms of amount of rows and also size of the table, but yeah, that's what we add here. So now we grew the data model again by adding 1 megabyte of date table there. But now we have truly flexible, so I can add like the quarter, whatever I need. There's like really good examples out there if you want to build this date table. The next issue I'm having is still we have like this one big table, like all the things like the dimensional information, like my what do we have here, the country, or the segment is together, stored together with my facts, with my sales, my cost of goods, and so on and so forth. So I want to get rid of this, or I want to split this. I want to build a star schema. Star schema means I have a filter table where all the things I want to group and filter on and a separate table, and all the things I want to aggregate on, like the sales, I want to have in a different table. And we can easily do this by using Power Query. You could use SQL. We can, as we later will see, PySpark or Spark SQL, any tool you want to use here. It's not that important which tool you're using. It's very important but it's very important that you do this. So first thing would be I would go through all my columns here. Maybe I would change the unit sold from decimal to fixed decimal because I only need 4 decimals, and then it's more precise as a data type. But I skip this here. I will disable the load of this one. So now it's in italic, and then I will not duplicate, but I will reference from it. So I will reference and I will create a filter table. This filter table will then contain all my filters, like the segment, the country, the product, the discount. Maybe I select all those. I want to keep like these. The discount band I want to keep, and the manufacturing price. I found out like there's one price per product, so I also want to keep this in the filter table. There might be discussions what you want to do here with these things, like a price if you want to store it with the facts and or with dimensions. I want to keep it with my filter table, so I remove all the other columns and then make sure that I only get distinct, remove all the duplicates, no keep, but remove the duplicates. I only have the distinct combinations of filters. That's one thing. And on the other hand, I again reference this table and make this now my KPI table or financial table or whatever you want to call it. And here I remove those columns, right? The segment, the country, the product, the discount band, the manufacturing price, I remove from here. But if I do so, I lose the connection between my filter and my KPI. So this will not really work out. On the other hand, if I keep it like this, I have troubles in the Power BI data model because I cannot I cannot have a filter relationship between 2 tables with more than 1 column. So what I add here for this filter table, I will add an index, add a column, and then you have this index column in here. I should zoom in here. So it's index column. If you start from 0 or 1, doesn't really matter because it's just an index. And I will call this index column then my filter ID. And usually I all the columns I will not expose to my end users because nobody should filter on the filter ID. I put an underscore here. That means that the column gets on top of the list, and it's easy for me to find those columns and hide them in the data model. So to get a connection between, I want to connect my KPI with my filter ID. So I have to add this filter ID. How can I do that? I can just jump under home, and then I can merge the queries. Again, let's use zoom in here. Merge the queries, not as a new, but merge the queries. And I want to merge to my new KPI query, which is the KPI. I want to merge my filter table, a filter query. Right? Use the synonymous. And I'm in Power Query. You can with control click, you can like click on more than 1 column and tell it, like I have this KPI table, I have my filter table, segment, country, and if you can, I'm sure you can see like the small numbers, right? Make sure that the numbers match, right? The segment is number 1 and product is number 3. Otherwise, this will not really work. And we're really lucky that we get this join kind, a good description about it, and left out is what we need, right? I do not want to lose any KPIs. I want to keep all of them, even if there's no matching row in the filter table, which in this case is like unthinkable because I created the filter table from the same table like the KPI table. But left outer join is the good idea here. And from this filter table, I just want to I remove everything, right? I do not want to filter as a prefix. And I do not want to have any of those columns. I just want to have the filter ID here. And if I do so, I get this filter here. And now I can remove those columns I don't need anymore in my KPI table. So jump over to the segment, the country, the product, the discount band, and the manufacturing price. And while I'm at it, I also will remove the month number, the month name, and the year because I already put this into my dates table, right? So I don't need those columns anymore. I remove those columns, close and apply, and then make sure that everything is connected in my data model. Sure if I make everything right. So I have my filter table, I have my KPI table, I have my date table. For some reason, it did not connect the date table. So, and the reason is, Did I remove the date column? No, I did not. The filter, I'm looking at the wrong table. So I have the date table over there. There's some issue in the date table, as I can see with this warning sign, and there's a date here, and there's a date here, and I want to connect those. Cannot find financials. Of course. Now it's called KPI, right? I changed or removed the financial tables. Of course, therefore I broke my date table definition. KPI, and KPI is a keyword. Always forget about this. So we need to put it under single quotes. So Power BI, now you're now happy again. Very good. If Power BI is happy, I'm happy. And I put the date filter also here. Make this an active relationship. Again, if you jump to Power BI to DAX Studio, new connection, and view at the metrics, then we should see now the date table is small again for some reason. I'm not sure why it was the big in the other use case. I have the filter and I have now KPI and filter. So together they're like 170, where previously this was 190. We saved a little bit of space, right? But like the direction is the right direction. And the last thing I would optimize here for such a data model is if I jump to my KPIs here, we can see that there's like a unit sold, sales price, there's a gross sales, and the gross sales is just a calculation where the unit solds are taken and multiplied by the sales price. So we could save the space for that. And this is what I would recommend. If you have like those KPIs, which can be a measure, remove them and replace them by a measure. I mean, if it's like going for the last milliseconds, maybe you will reintroduce some of them, but usually like the report will be maybe slower for 100 milliseconds, but your data model will be much smaller. So this is always a good idea to have a smaller data model because, again, less resources, you can use longer. You can use your Fabric capacity longer. You can still use Power BI Pro maybe because your model is still small enough. So what I would do here is, let's call it, because it's in the same table, maybe I would create something else. Yeah, let's have like, name it blank gross sales. And this would be nothing else like a sum X over my KPI table, where I then take the units sold, and multiply it with the sale price. Go away. Sale price, right? Sale price. Rename measures. I cannot because, okay, the blank was removed, right? Okay, it's already used, so I name it, whatever. Gross sales underscore, as this is measure. And then I will also do the same for the sales. The sales, nothing else than the gross sales minus the discount, right? So again, create a new measure here, which is my sales, which is then the gross sales minus the discounts, the sum of the discounts. And to be clear, of course, I would also like introduce measures for the discounts. I would like keep, of course, the discount, but would hide it and replace it by a measure called the sum of the discounts. And the last one I want to create here is the cost of goods. Cost of goods, again, which is like the sales, no, not the cost of goods. I want to replace the profit. The profit is the cost of the sales minus the sum of the cost of goods. So, and it's not called profit, but have to be profit underscore. Just want to keep save some time and not create this measure table here. And with that, we have the same results, right? We could, of course, you should always double check here. I already double checked. I'm very confident that I can now remove the gross sales from here, delete from the model. I can also remove this. What do we have here? The profit column from the table, and I can also remove the sales column from the table from the model. And then again, we double check in DAX Studio, new connection to the same data model. View the metrics, and now the KPI column table is only like 40 K, right? So we went down from 190, whatever it was like in the beginning. For some reason, it was like 5 megabytes. At the end, we end up with what's the model size here? I think there's a summary here. Now we're down to 137 kilobytes. Of course, this is very small, right? Whatever you do to this specific model, everything will be fast. Even 5 megabytes is really, really easy to help with all your machines, right? With Power BI Service and your laptops. But I hope you get this idea that it's very important to make a good data model. And this does not change with Fabric. I see the danger that now Microsoft like sells Fabric, and Fabric is a cool thing. No worries, yeah. I will not discuss this. It is a very cool thing, and the direct lake mode is also very cool. But like Microsoft will demonstrate it, like we should always like just put files into the data lake, and then connect your data model, your Power BI data model on it, and you're done. And this is like just half of the story. Yeah, very very small use cases, very edge cases, right? They might profit, and you can then build your reports on that. But for everything else, you still should use all the technologies you have available. And with Fabric, we have more available to our hands, at least from my perspective as a Power BI and SQL engineer, which we can make use of. And this leads me back to the slides. Yeah, and maybe you believe me, this was a good idea, what I did to the financials model. Maybe you don't, yeah. If you have doubts, and I had doubts when I started my career into data warehousing back in 2006, I was really wondering why would there be dim and fact tables, and why would there be redundant data in the dimension tables? They should be normalized, right? This is what I learned back at school, and I had to learn it the hard way, right? I really had to see, and from the results I had to see that it's much better to have the star scheme available. So if you have fear, if you have doubt, if you have disbelief, then you need to free your mind, as Morpheus said in this famous quote, right? So in Fabric, the good thing is we have more tools available. If you use Power Query in Fabric, it's called Dataflow Generation 2, which is a Power Query online. You can do all the things I just demonstrated within Power BI Desktop. You can also do in Fabric. There's PySpark available. If you never use PySpark, I will demonstrate a little bit so you can get an idea how this works. If you're coming like from the AI and machine learning world, PySpark is very close to your heart. Use whatever you know, right? That's the idea. Like instead of the need of teaching people new tools, the idea in Fabric is to have a lot of tools available to make it everybody easy to grab one of the tools they're familiar with or they fell in love easily with to use these tools. So don't be overwhelmed by everything available in Fabric that you now must learn PySpark. There's no need to learn PySpark. If you use SQL and you have a SQL database and everything works with that, use whatever you previously worked. But it's opening up new opportunities. Look at it like this. See it like this. And there's Spark SQL available, and you can also use T-SQL in Fabric with these interfaces. And there's much more to come, I guess. I mean, there's also KQL, there's also other tools. Yeah, I don't have examples prepared, but for all those we can see on the screen, we jump into the demonstration again. So what I've got here is I close the DAX Studio. I don't need Power BI here. So what I'm using here is I'm coming from Power BI, right? So I still use app.powerbi.com. I don't use the Fabric URL to open up Fabric. And I have this workspace here, which I called Fabric. This is running on a Fabric trial where I get 28 days left before everything is deleted from a trial here, and it's called Fabric. So the name of this is Fabric. And as you can see, there's a lot of artifacts available, different types. We have this, we have semantic models. This is what we'll talk about. We have Power BI reports. We have semantic, semantic model, which we had in Power BI already, but this is a different semantic model here. As you can see, this is uncommitted, this is synced. We have, for example, data pipelines, we have data flow, we have notebooks, we have event stream, we have dashboards. We already had dashboards, right? There's this event house, there's new artifacts. Don't get too overwhelmed with all those things. Learn them step by step, assume there's a use case for you, and then you embrace the new things here. So talking about the danger I see, right? If we have something like my, where's my lakehouse here? Pipeline demo, there is my lakehouse here. And in this lakehouse, and just jump to the lakehouse, right? Called my lakehouse. Again, all the exercises I do for my demonstrations, they have really bad naming, right? It's called my lakehouse. Of course, it's a lakehouse. Don't put this in the name. Name it whatever the content of it is. But like for demonstration or for my courses, I use these terms so people get familiar. This is a lakehouse, right? My lakehouse is a lakehouse. And it's looked like this. In the lakehouse, you have these tables. And as you can see, it is like, should the icon looks like a table, and there's this little triangle here which tells me this is a delta Parquet file. So delta Parquet file is a special way of storing data. Parquet files, to be honest, is like a CSV on steroids. So it's an open format, the Parquet file, but the good thing is compressed, and it's compressing the data by like storing data column by column. So every column gets its own like storage within this file, right? And then it's compressed, which is very, very smart, because then we can compress it very good. And by more or less random, the Vertipack engine in Power BI is doing the same thing. So Vertipack, the name comes from Vertipack. Verti is vertical. So we're storing vertical things and we're packing them. So they are compressed. So Parquet and Vertipack, they are some kind the same idea of storing things. And this is what led Microsoft to open up this direct lake mode. The direct lake mode means that I can have a semantic model in direct lake mode, where the tables are in direct lake mode. This means that the data is not imported to Power BI, and it's not direct query. It's direct lake, something in between. So instead of importing it, it can directly access the Parquet file. And it's not really direct querying because it's not using the SQL engine, but it can directly understand the content of the Parquet file while accessing it. So this means that Power BI can natively read those Parquet files, which means that they don't have to be loaded. I don't have to schedule a refresh. As soon as I change something in the Parquet file, within a very short period of time, it will show up in my Power BI report. The first access to this Parquet files will be a little bit slower, because Power BI will then enrich it with information the Vertipack engine needs, or like can enables it to query the data faster, which is not available in the Parquet file. And if it's not used anymore, then like this information will get rid of the memory again, and the next time you access it, maybe it has to reload it again. But as soon as it's like cached, so to speak, the access is really, really fast. So it's way faster than direct query. Microsoft tells of some use cases where direct lake was even faster than Vertipack, but I think this is like narrow use cases. The expectation is that it's way faster than direct query, and it's not as fast as import mode. So this might be a good compromise between these two. There are some like limitations currently, and maybe they are lifted, maybe they will be never lifted, where it could happen then while you're accessing something in direct lake mode, it cannot use the direct lake mode, and then it will fall back to direct query mode. So it will use the SQL engine. So this is the funny thing here. I'm in a direct lake here, right? But I can change this from the lakehouse to the SQL endpoints. Then I can look at my Parquet files. It's still, as you can see, it's the same tables, right? Same tables. And I can then access those tables. My lakehouse, right? It's still tables here, right? And I can access those files. I mean, it's tables. They're exposed as tables, but underneath it's just a Parquet file. And I can then like run a SQL query on that. Select top 100, right? So this is select top 100. So this is T-SQL, which I can use to query those Parquet files. So Team Customer is indeed a table, something created as an external table in my lakehouse, and the data was not copied or whatever. I'm directly querying this Delta Lake file. And the Delta thing, so to finish up what the Parquet file means and the Delta means that this Parquet file is then enriched with a JSON information which keeps track of changes. So while it's really, really hard to change something directly in the Parquet file, and that's the reason why we cannot update a single row in Vertipack engine, right? Like open up one, because it's packed, it's compressed, and changing something directly there does not really work. Maybe some of you can remember those days in SQL Server 2012 when they introduced the column store index. And the column store index, like if you put a column store index on the table was read only. You could not change, you could not update, insert, delete any row, because it's really, really hard to impossible to change a single row. With 2016, they lifted this limitation, and what they do is like they have like the compressed portion, and everything. Every time you change something, it's actually deleting the row and then adding a row group, so not a compressed, adding the row in a not compressed form to the table. And similar is this like delta thing. Like we have this compressed thing and the delta addition to the Parquet file. Again, this is open source, so a lot of tools can read this and can write this. You can then keep track of those changes. So this is my lakehouse, right? And this lakehouse, part of the lakehouse, again, for some reason not in the Lakehouse Explorer, but I have to jump over to the SQL endpoint, to the SQL endpoint of this lakehouse. I can see that there's like this schema, I have my tables here, and there's also queries, yes, and there's this model layouts, right? So I can store queries in Fabric, and the model layout means I can make parts of my table. So I chose 3 of my tables. And again, the naming is really, really bad. I would never, ever something in production called PySpark _ something. But this is like the financial to date table, as you can see here. So this, I rebuilt the same thing in PySpark, and I will show you in a second how I built this. So I have my date table, I have my filter table, and I have my KPI table. So I apply the same transformations. The name gives me the hint. I didn't do this in Power Query. I did not do this in DAX. I built this with PySpark and built a layout here. So I can have like a Power BI connection to the semantic model, querying whatever is happening inside my PySpark files, Parquet files. And this blue line, this dashed line, gives us the hint. Under advanced, we can see it. Like the storage mode of these 3 is direct lake. And it told you there's some limitations. One of the limitations is that currently there's no composite model possible. So you can only have, if you have one table in direct lake, everybody else, every other table also has to be in direct lake mode. We cannot import or have direct query tables in there. Up to this week, I can't remember which day it was, like a couple of days ago, they announced that you can also now change or work with this schema not only in the cloud, in the Power BI service, but now you can also have in Power BI again. Let's have a new file here, Black Report. You can also connect from Power BI Desktop. So all the voices who fear that Power BI Desktop will die as the data modeling experience in the web gets better and better. No, they added something to Power BI Desktop as a clear sign. Power BI Desktop will still be around. So I can click Get Data, look for my Power BI semantic models. And as soon as this dialog appears, I get this dialog here, right? And I can then have like my PySpark financials example, the example I just have seen, and instead of just connecting, I can now choose to edit. So I cannot directly add from whatever I do in Power BI Desktop in the web service. This means it's the same experience. As soon as I change something, it's directly saved there. So there's no save button available. So whatever you're doing here, it's directly written to the model in Fabric. Other limitations we're having here, for example, we cannot create a table, right? We cannot add calculated tables. We cannot have calculated columns, which I don't miss that much, but there's some limitations here. So currently, if you want to like combine information from your direct lake mode with other information, what you could do is that you create another Power BI data model, right? And then connect to in direct query mode to this model, which is in direct lake mode, right? And the other model, which is in direct query mode, there we can like build a composite model by loading things or having other accesses. So this is the only way currently to mix up information from a direct lake mode with tables in other modes. So how did I build this in Fabric, right? And I think I already opened up the things here, right? What you can do, you can have, for example, data flows, right? So I can have my data flows here, and then I can edit this data flow, and I think I just picked the filter table, right? I edit this filter table. I have then my data flow where I change things there. So I did the same transformations, right? I have my source, sorry, this was in German language, then I removed my columns, added an index, right? So this is what I got here, and I think I forgot to change that I also want to have my only distinct columns, right? As I see here. So I want to remove the remove duplicates. That's a very important step here. Save and close. So this is one way, right? If you feel familiar with data flows, if you're familiar with Power Query, then still use this in Power BI, in Fabric, right? The other thing is maybe you're similar to myself. I'm coming from the SQL side, right? So the first projects I implemented BI solutions with Microsoft was SQL Server. I built views, I built tables, I built queries, I built transformations as procedures, maybe in integration services, but also in procedures, writing SQL. So SQL is like my home game. I feel very familiar with SQL. And the cool thing is, also in Spark, there's a SQL available. For some reason, like this is a little bit, the dialect is a little bit different, but I'm sure you will learn this very easy. So we can have like a select statement. And what I'm having here is a notebook. And when I first saw notebooks, I was not really sure what to make with them, because I mean, I can do the same thing in my SQL file, right? I can like comment things. I can have my comments here. I would have my statement, and then, okay, I could run the result, right? And then copy and paste the result into, again, as a comment. But this notebook is really cool because it can be, it's like much easier to read, right? You can format things. So if I double click in here, you'll see that like this, I can have a headline and a sub-headline. There's a small markup language behind that. I have my SQL statements here, and to make sure that this is really interpreted as SQL, this magic command, so %%, and then you tell it which language you want to have. You could also change it from here, change different languages you want this cell to run in, right? And then you can run the cell, and the result is then part of everything in here, and you can show this as a table, but I can also jump over like analyze things here. It doesn't show how many segments are there, similar to what we have in Power Query, right? With these profiles. We can have a chart if you want. You can download this. So this is really cool. Very easy to work with. Don't have to add anything. There's a lot of features automatically available here. And then, of course, I need to analyze, right? If I only work in Spark SQL, I need to find out what kind of data is there. And this describe extended command allows me to find out, okay, the segment is a string. But to be honest, everything is a string, right? Even the sales is a string. The reason is because this was imported from a CSV file, and the CSV file contained like the $ or a decimal point and something like this. So this is not really what we can work with. So just make sure that the Vertipaq V order is turned on, which is by default, so it's not very important at this point in time. And then I can create a table, right? So I create a table where I only use the segment, the country, the product, and then I do some magic here, right? So I take the manufacturing price, and I only need like the first, what do I do here? I only need everything from the third letter, because the content of this column, let's jump back here to the table. As you can see here, no, jump back to the table. If we have the manufacturing price, there's like this $ in there, right? I have to remove the $. I also need to change the comma. There's a decimal comma instead of a decimal point. And this is what I do with this little big thing here. So I replace the comma with a dot. I replace blanks with nothing. And I make sure that I get rid of this $, right? And then I can cast this as a decimal. So now I have like whatever this table contains. This table contains then a manufacturing price column of data type decimal 19.2. And this, so if I do this, you can see now the manufacturing price is actually a number, a decimal number. You can do similar things then to the financials KPI table, right? Most of the columns I need to apply the same magic, right? I have to remove the $. I make sure that like the unit sold is an integer, anything else, and then I do the lookup, right? I join my filter table I already created to the financials. By segment, country, product, I left out the manufacturing price and this band to create my KPI table with the help of Spark SQL. And this is what I get in the end. And the date table I created from scratch. So there's like this very cool thing in Spark SQL. I just learned 2 weeks ago that is generate series function in SQL, so I have to try this out also in T-SQL. But what you can do is I can create a sequence where I gave from one date, which is again, it's very similar to what I did in if you look just at this portion, this is like DAX, right? The date of the minimum year, the 1st of January, then I make another date with the end of December. I create a sequence out of that. So this helps me now to create like every between those 2 days, I get every date in between, and then I explode it. And explode means that instead of like having this list, it makes rows out of that. So I get this date table, and then again with date format, I played around here. There's other functions you can use to get all the columns you need in your date table. So this is what you can do in Spark. Very, very cool, if you ask me. If you want to learn PySpark, which is like Python, not Spark SQL, but Python, there is this data wrangler available. So if you need first, you need to run a cell, one cell here to create this data frame, right? So data frame is more or less a table. If you're coming from the SQL side or Power BI side, it's not 100% right to call a data frame a table, but more or less it is, right? We have the columns have names, every column has a data type, and we have rows in there. So it very looks like a table, what we use as a table in Power Query or in Power BI or in SQL. And as soon as I have this data frame launched, you can use this, not the pipeline, but the data wrangler. Currently it's hidden here because there's no data frame available, and then you can build up things. It helps you to create some of the transformations. Currently it's rather limited, so I could not create everything I wanted to create with this data wrangler, but only portions of that. But just a reminder, there's this tool available, UI, more or less like very similar to what we have like in Power Query, where you click in the UI and get this M script, because not very many people are writing actually an M script. Most of the people are using the UI to create the M script and maybe then tweak the M script afterwards. And very, very powerful is this notebook for PySpark. So that's a totally new language. As you can see, again, I create this data frame, and there's the Spark read format delta, and then I have to specify under the table section, I have this financial table. So this is what I already uploaded upfront from the Excel file, right? I get the same result here as we have seen in Spark SQL because it's the same thing. So other ways to treat it. Let's jump a little bit forward in the sense of time. And then inside of PySpark, you can also run Spark SQL. So some of the features are just not available or I could not find them as a native PySpark thing. So you can write a SQL statement, describe history. It's the same thing we did in the other statement. No, this is not, this is the history, right? This is how often it was updated, right? So we can see here that this table, I created it like back in September, and then I applied some operations, which I can see here, which I applied. What I wanted to show was like this with the data types. Very cool also is that we can have a quick visualize, which is an extension within Fabric where we can build a Power BI report. So I'm not sure how much time do I have left, 10 minutes. So let's start this again also here to have this data frame available. And as soon as this is finished, I can also run the statement down there. So you can start from this PySpark notebook, you can start to automatically generate a Power BI report and then show the result in this notebook, which is a brilliant idea, I would say, because you can like combine commands. People maybe might not understand what this means, right? But they can run the play command and then see the results. And if they are then brave, they can tweak some of those things, right, to adjust if they want. Then with the schema, we have the same problem, right? With the original data frame, that everything is a string, except for the month number. This was discovered as an integer. Everything was discovered as a string. And then I, again, have different ways of, again, replacing and substringing a thing. So I get only the price as a decimal number. So I cast it as a decimal type 19.4, right? This is what also Power BI stores later. So 19.4, that's what I chose here. Or I change the data type of my date column, which is also a string with the toDate function, and then provide a description how the string looks like. So this is not what I want to have. I don't write dates in this way, but the CSV file I used, so the Parquet files I created from it, contained the date as a day.monthNumber.year. And if I change this, again, I get like real data types. So as we can see here, now the unit sold is an integer, or the manufacturing price is a decimal number, or the date is a date. In the next steps, I then try to like find a little bit out of what kind of information we've got, right? Describe, because for the financial examples, I already know that the segment is a filter, and the sales is like the KPIs I want to have, the measures I want to have. But for an unknown dataset or Parquet file, you need some tools to find out what's in there. So there's this describe function here, which tells me that like the segment has 700 different rows. There's no mean to calculate because it's a number. It's a text, right? What's the smallest and the biggest number? Or I can also like count the distinct values in there. So I find out, oh, there's only 5 segments, right? Only 5 countries, only 6 products. And there's also 6 manufacturing prices. And this like led me to the to like look up, is there a connection between those products and the prices, for example. While, for example, the gross sales is 550 or 500, they're over 500 different numbers. So obviously this is like a sign that maybe these things are filters, while the other ones are values which are very different per row. So maybe this is something I want to add up. So this gives me hints to understand the data. Of course, I can only build a perfect data model or a good data model if I understand the data, if I understand the business. And this is exactly what when I go to come to a new client, a new customer, right? I need to talk to those people, because I have a little bit of clue how businesses work, right? But I don't have any clue about the specifics of this business. Before I decide on what's a good or bad data model, I need to learn how this data is connected, what's the business cases, what's the use cases, what's the actions they can derive from the data, what's the things they want to learn from the data. So it's something I have to like be onboarded in the project to assist to build a good data model. And with the select statement, so the data frame, and then there's the select, not statement, but it's a method applied to this data frame. At distinct values, I get like this distinct products and manufacturing prices, and therefore I found out, right, there's a one-to-one relationship, right? Every product has only one manufacturing price, and this I can directly find out before I even load this to Power BI with the help of the script. And also, like, if I multiply things, then I see 600 possible combinations available from those different filters. So I would expect that my filter table has 600 rows, not 700 rows, because there's only as a maximum, right? Maybe it's less because not all combinations are there. This could be happen, but I would expect that this table contains 600 rows or less. And then again, I use the Spark SQL here to create this filter data frame to create this table. And adding the index, let's see how I did this here. Adding the surrogate key as an index was a little bit more involved, and I had a very, very good intern over the summer. My son assisted me in building these PySpark scripts. So I learned a lot about PySpark, he learned a lot about PySpark, so I think this was a good internship. And in there we can see like this Windows window order by, where I order things, and I think there's only this is commented out, but what I in the end used was this monotonically increase ID, right? This gives me an ID. I'm not interested in which row gets which ID, like the index function, right? And this is what I add as a filter ID column to my existing data frame DF filters. And then in the end, I write this as I overwrite if it's already existing. I trunc it if already something is there as my PySpark financial filters. And just to make sure that I understand what this does, right? I explicitly also ask to create a CSV file, a Parquet file, and Delta file. And this is like the proof that if you just specify, not specifying a format, the default is a Delta file. This is what's coming out of this operation. And similar, I then joined my filters and the filter columns. Let me see here what I did do here. Yeah, then I defined, where's my filters? Here. This is very cool. This is something I would also love to have like in SQL, in PySpark. So I have this variable defined filter columns, which is a list of column names in this case, right? So instead of specifying the filter columns I already identified explicitly with all of my commands, I can just use this one. So for example, to create the filters, I just referred to these filter columns. If I later remove, like I wanna join my filters with the financials, I also tell it please on these filter columns. This is really, really cool, right? I really like this. Like this, there's a mixture of dynamical SQL and static SQL. So I join then those two data frames. So I get my previous data frame, right? Plus I then drop the filter tables afterwards because I don't need them anymore, right? So at the very end, I get then no filter columns, but I have this filter ID here, similar to what we did in the join operation in Power Query. And then again, I make sure that I remove those functions, those columns I don't need. Again, to prove that the gross sales is indeed the sales price times the units sold. I just make sure that I double check, right? The gross sales. This is what was already stored in the data, and then I calculated the thing, and the number was the very same. So make sure if you replace something with a measure, that the numbers are right. So I drop those columns because I don't need them anymore. I drop also the date columns because I have them already in the date table, and then again overwrite my data frame with that. And the date table, again, something I had to learn in PySpark because PySpark was not my hometown or my home game, so to speak. I first get the minimum and the maximum date of my KPI table, right, of my facts, convert them to a variable, min year, max year, then change to make sure that I only really start at the first day, because it could be that the KPI starts like at the 2nd of January or doesn't have anything on the last of December. So I only grab the years and then make sure that I go from the first of the day to the last of the day. And then again, similar to what we already have seen, the date format or day of month, this can be then applied to the actual dates. So I create this date table and then apply more columns there and write this as the div. Show it there, and I write this as my PySpark financials date table. So very exciting that what you can do in PySpark. If you're interested, there's new opportunities to learn new stuff, but don't be afraid of those things. There's no need to change your business logic if you're running. Everything is SQL procedures. If you're using Power Query, then stick with that. My only ask is here, as I ask everybody, take your data model seriously. So don't just load what you get, right? Data modeling is very important in Power BI. It is important if you load something from Excel, if you load something from your application database, and this does not change with a direct lake mode in Fabric. So my fear is that like Microsoft tells you direct lake is so cool that people stop modeling their data and loading everything as it is to the model, which is not a very good idea. And the other thing is that with Fabric, we have not tons, but like I demonstrated 4 or 5 of those tools available, new tools available, which can like make onboarding of new employees easier because maybe they're familiar with one of those languages, with one of those tools, or there's special use cases where you fall in love with, where you say, hey, this is a very cool solution I can do in PySpark, which I could not do as performant or easy to write or easy to maintain in other languages. So that's the idea here. So again, star schema is very, very important, and your visuals and your DAX code will thank you. Yes, the ad hoc model will be sort of envy, but the ad hoc model is not here to, I mean, it's ad hoc model, right? I also build ad hoc models to find out things, but I will not share a model like this. I will not publish it to the Power BI service. I will not put this into production. If you want to put something into production, please make sure to make everything a star schema. And this leads me to the top of the hour and the start of your lunch break. If there's any questions, I can stay. If you want to stay, I can stay. Otherwise, then send me an email to markus@severidata.com. And by the way, if you're interested in the book, the first 5 people sending me an email with a book in the headline and database, I can share an ebook version of the book with you.
So this is amazing. Thank you very much, Markus, for your presentation, for doing this unsurprising ebook stuff. Thank you so much. it was a pleasure listening what you taught us. So this is great. So then everyone enjoy lunch break. Markus, thank you very much. Cool. And see you in 90 minutes, everyone.
Yeah. Thank you for having me.
Bye.
Yeah. Bye-bye.
Bye. See you soon. See you soon. Hey Zazi, how are you doing?
Hey Tom, I'm doing good. How are you?
I'm fine. And in the meantime, I managed to get awake. I was oversleeping today, so I was getting awake 24 minutes before our conference started. So it got me a little bit heated. But I managed it somehow.
Awesome. Awesome. Where are you based out of, Tom?
Pardon what?
Where are you based out of?
So I'm living in Germany in
Mm-hmm.
the wonderful northern city called Hamburg.
Ah,
So, and currently I see we are in the autumn season. So it's cloudy, a little bit rainy, but
yeah.
this is how
Awesome.
it goes. Where are you located?
So I'm located in India, down south. It's actually a city called Vizag or Vishakhapatnam. So it's nearby the coast here. So the beach is like 25 minutes from my home. So that's
This
interesting. Yeah.
this sounds super duper cool.
Yes, it is.
And why you a little bit. So, and I'm also adding your presentation to the stage, and I'm really excited about uh, what you tell us about how to navigate the modern data stack. And
Yeah.
so I'm really looking for. So I've been to, please forgive me, I've been to Bangalore
Mm-hmm.
quite 4 to 5
Yeah.
times, but I do not actually remember. I did not have the idea it was close to the coast. So
So no, right. Bangalore is a different city. I used to be in Bangalore, but
yeah,
right now I'm in a different city, which is
yeah, understand.
down south. Yeah,
Okay,
but Bangalore is not close to the coast. I mean, the coast
okay,
is like
okay,
really far from Bangalore. Yeah.
okay. But with this said, I'm in autumn. You are at the coast, close to the coast. Probably it's not autumn on your side of the world. Happy you will present us how to navigate the modern data stack. I leave the stage and then it's up to you.
Sure. Hey, hello everyone, and let me start with a brief introduction about myself. So, I'm Shashi Teja, and I've had the privilege of working with different industry leaders across various domains that include cloud, networking, data streaming, data engineering, data cataloging, governance, essentially all things data. And in today's session, we'll dive into navigating the modern data stack, like what it truly means and why is it even critical in today's data-driven world. And we'll explore the key components that make up the modern data stack with real-world examples, so that we can go ahead and bring these concepts to life. So yeah, let's get started. So I hope that you're able to see my slides. So just a second. Yes. So, what exactly is modern data stack, or as it is called, MDS? Right. So, so the modern data stack is more like an ecosystem, I'd say, of cloud-based tools. Um, you know, Designed to streamline the collection, storage, processing, and analysis of data. And there's a reason why it's actually called the modern data stack, because there used to be traditional data stacks that were mostly on-prem, but now coming onto the modern data stack, we are looking at a lot of cloud-based technologies and a lot of open source when we talk about modern data stack, mostly cloud native stuff when we talk about modern data stack. So it typically includes components such as ingestion, storage, transformation, orchestration, visualization, and I'll be talking about all of these in the slides following these slides. And yeah, so why do we even need a modern data stack, right? So unlike the traditional data architectures, like I was telling you, that often used to rely on on-prem solutions, the MDS or the modern data stack is built for scalability and flexibility. and mostly for real-time data processing, data streaming, or however you want to put it out. So this enables businesses to derive real-time insights and make informed decisions way faster than how it used to be in the previous times when the data stacks used to be traditional on-prem. So as I said, the key characteristics of the modern data stack are, they are cloud native. There's a lot of real-time processing there, and it's an open ecosystem, wherein the ecosystem is very flexible and tools can be seamlessly integrated. Moving on to the next slide. So I believe that the modern data stack typically consists of, two layers. Uh, Sorry. Yeah. So I think I'm presenting, right? Is there any issue? All good? I think everything's good. So awesome. The MDAs typically consists of several key components, but as I said, two main layers. So one layer is the data plane, wherein this is the plane that is responsible for data movement or data processing, everything that has the real data inside it. And control plane is where the orchestration is managed, the governance policies are managed, the metadata is managed, or let's say the observability or the access control or lineage. Where is the data even coming from? Where is it even going? Who's the owner of this data? Where is the data pipeline failing? All of these can be managed using the control plane. So moving ahead, let's talk about the different components in the data plane first. And data ingestion, speaking about data ingestion. So it's a process of collecting and moving data from multiple sources to a centralized location for storage and processing and analysis. So the data is typically moved to, it can be from a source, which can be something like, a random SaaS application or something like a CRM or whatever, to typically a database or a data warehouse or a data lake, or as you hear the terms today called data lake house as well. That's a mixture of good things of a data warehouse and a data lake. So going ahead with some examples. So there are a lot of tools that are out there, but I'm just using certain examples here. So as you can see, Fivetran, Stitch, Airbyte, Apache Kafka, mainly the Kafka Connect piece of it. So all of these are different examples for data ingestion or data integration from different sources to, let's say, a sink, which is again a database, a data lake, or a data warehouse. So yeah, Fivetran is something that is available out there. It can connect you with different source systems. Airbyte is more like a open source alternative that allows you to customize your connectors. When I say connectors, I mean the integrations that are available with your sources. And for Kafka, you have something called Kafka Connect, wherein there are different connectors that are available that let you integrate your data from a source to Kafka and from Kafka to a sink. So this is about integration. The next part is data storage. So solutions that handle both structured and unstructured data. Here is where we can go ahead and store raw and process data, in a scalable manner. So speaking about some examples here, we have something called, of course, everyone knows about this. We have Snowflake, which handles structured and semi-structured data with automatic scaling. So Snowflake is available mostly as a warehouse, but there's a lakehouse flavor of it that is also available. We have Amazon S3, which is again considered to be a data lake. Along with that, we also have something called AWS Lake Formation, and we also have Amazon Athena, which can help you run your SQL queries over the data lakes that are present in AWS. We have something called Google BigQuery, which is again a data warehouse that is provided by Google. We have Amazon Redshift, which can be considered as a data warehouse for AWS. We have the Azure Data Lake storage, the data lake for Azure, and we also have Databricks, which combines data warehousing and lake capabilities in like a single platform. So yeah, I mean, that's about the storage side of it. Now let's go on talk about data transformation. So whenever I'm talking about, let's say, modern data architectures, or let's say the modern data stack, the modern data stack has moved more towards ELT, which is, extract, load, and transform. Uh, Earlier, it used to be ETL. Yes, of course. I mean, there are pros and cons of both. But as of now, considering the market moving towards time-based stuff, looking for insights like real quick. So ELT is something that is being famous as of now. So as you just saw, we talked about data ingestion and data storage, and so that means we covered the EL part of it. Now we are touching the T part of it, which is data transformation. So this is where these are like tools that clean and reshape your data for analysis. So these are some major, transformation tools that are available, that you can run over your, let's say, data warehouse that is available. Let's say if you have Snowflake as a data warehouse, you can use like something like DBT to, write SQL-based transformations directly on your warehouse. We have something called Matillion that is also available, which is more like a graphical interface for building transformation workflows. So, yeah, I mean, you can go ahead and leverage DBT when your team is comfortable with SQL, or if your team is just starting with all coding, or let's say does not have a deep coding knowledge kind of a thing, and you need something more like low code or a visual transformation that is available, then you can go with Matillion. So moving ahead, so we touched the ELT piece of things, and now we are looking at the BI part, the business intelligence part. So this is where people can go ahead and create dashboards, reports that help stakeholders to make informed decisions. These are some examples that everyone uses today. We have Tableau, Power BI. I think there were some sessions earlier scheduled. Um and would speak about I think there were some Power BI sessions that happened before my session as well. So these are some BI tools that are available, and this is also something that is there in the market. It's called reverse ETL. So let's say you have done the ELT piece of it, you have your data on your data warehouse, which is transformed and ready for consumption. This reverse ETL, what it does is it syncs back the data that is, let's say, already transformed to an operational system, which can be a CRM or a marketing platform or something of that sort. So for this, we have something called high touch and census. So high touch like syncs from warehouses back to the applications, like let's say Salesforce or HubSpot, or you can have census, which is again it focuses on operationalizing the analytics by syncing insights into SaaS applications like Zendesk, you can say. So yeah, that's about the BI pieces and the reverse ETL pieces of it. Now getting on to the control plane side of things, we just talked about data plane till now. So getting on to the control plane, we have something called data orchestration. So this is where you manage workflows, dependencies between different, processes, or let's say tasks in a stack. So if you're, I mean, of course, everyone has heard about Apache Airflow, wherein you write Python code to, ideally design DAGs, and create links between different tasks in your data pipeline. We also have something called Dagster, which is again, a data pipeline orchestration tool that is available. Now, moving on to the most important pieces, there's something called data governance that you need in your modern data stack. There's data cataloging. Of course, every data has its data, which is called the metadata. And how are you even managing that metadata? And how is the data quality looking like? All of these pieces, like to ensure the data quality and compliance with regulations while integrating metadata from various tools across the stack, right? This is what you need. And yeah, so let's go ahead and understand some examples here. So yeah, you might have heard about Atlin, Monte Carlo, Emerson. So speaking about Atlin, it's an active metadata platform, and it's a third gen data catalog. Like it helps achieve everything from governance, data discovery, impact analysis, and it manages the metadata of all the tools in your data plane with features like, let's say, access control, glossary, lineage, contracts, query interfaces, and exploration. So let's say if you have a situation wherein you want to understand, hey, where is this data even coming from? What is the lineage looking like? Where is this data even going to? Where is the data pipeline actually failing? Who owns this data? What is the description of this data? Right? Whom should I be asking if the data pipeline is failing? Right? So solving the whole data chaos problem and the data governance problem, that's where, and having an active metadata wherein you can actually go ahead and discuss about the metadata directly on Slack, Teams, or it of course offers a different various set of integrations that are available. Now then there's something called Amundsen, which is a data catalog, and again it's open source. uh, Monte Carlo, it's a data observability tool that tracks your data stack end to end and alerts for any data issues in your data stack. So yeah, we talked about different things in the data plane. We talked about different things in the control plane, and this is how the summary of it actually looks. So yeah, we talked about data sources. We talked about different things like storage, integration, data governance, monitoring, activation, and all these pieces. So here are some sample data stacks that are, these are just to show you some examples wherein, let's say, there are different sources present and you're using something called Fivetran to ingest the sources into Snowflake. And this is the EL part of it, and the T part, the transformation part, is done by DBT. And then you're creating reports or doing some BI and analytics using Sigma. And the next thing is, yeah, this is one more sample data stack wherein we have Fivetran and AWS Glue, wherein data is flowing into Snowflake, and then there's DBT, and then the other, we have Looker as a tool wherein you can go ahead and do some dashboards, and as I spoke to you about Atlin for governance and active metadata. So yeah, do I still have time, Tom?
No. So
I'm so
this is the reason why I entered your stage.
sure.
So it was a whirlwind tour. And because our next speaker for this, let's say, lightning talk is already waiting, thank you so much, Sasi. I will remove you from the stage and your presentation first. And now it's just us. Now you are gone. You will go. Thank you very much, Sasi, once again.
Thank you.
And now Lisa will enter the stage.
Hi.
And now you are live, Lisa. And because I will also have your presentation, and now I will leave the stage, and it's up to you. Thank you very much for speaking, DataBash.
Can you see my presentation, Tom?
Yes, I can.
Okay, that's good, because I just have one screen today, so if there's anything wrong, just verbally let me know, and then, yeah, we can arrange it like that. So, okay, I'll be mindful of the time. I just have 15 minutes. So this is what my pet Python told me about building data lakes on Azure. All right. My name is Lisa Hoving, and I'm a big data engineer at a large Dutch bank. It's called the Rabobank. If you wanted to speak to me today but didn't get the chance to do so, you can find me basically all over the social media, LinkedIn, Twitter, at Lizardo8. Well, you might be thinking to yourself, Lisa, data lake, sure, but why on earth the pet Python? Well, to be honest, I thought about it quite some time and I really don't have a solid answer for you. I just like snakes. So in 2019, I kind of figured out, hey, I'm an adult, so I can go ahead and actually buy myself a pet Python. And this is what we did. So I basically bought myself that Python and I gave him the name, the only name that I deemed applicable, which was Fluffy. Well, this is Fluffy in his big terrarium. But as you kind of find out, which I guess is the same with any kind of, pet, buying it, that's the easy part. But taking good care of an animal, especially reptiles, that's quite complicated. So basically, what I found out is reptiles have very specific heat and humidity requirements. So what we did for Fluffy was we took 3 ceramic heat emitters for the ambient temperature and 1 heat mat to help with digestion. Of course, you don't want anything in your terrarium to over or underheat, which can be disastrous. So we put up these thermostats for Fluffy to ensure that the temperature would always be right for him. But again, that kind of got me thinking, right? So if I take good care of my pet reptile, he can live up to 20, maybe even 30 years. And that's a very long time. And you see, the chance of my equipment breaking today, yeah, that's quite slim. But the chance of my equipment breaking over the course of 20, maybe even 30 years, oh, that's huge, right? That chance might just happen. So I started to think about something that no developer really wants to think about: monitoring. What if my technology were to fail someday? So I went ahead and bought myself a Raspberry Pi and hooked up some temperature sensors to it, and I wrote some code. Well, what code more applicable to write this in than Python? So we wrote that in Python. And combining that with Twilio, I basically created some code saying, hey, just give me a call whenever the temperature is off. And that worked quite well for some time. I even got a call once when my central heating went out, so that was great, except for the fact that it was at night, which was less nice, but still. Again, I started to think, right? Because I'm a data engineer, I just told you that, and I'm kind of in the business of keeping data, not throwing it away. And when I thought about it, if I have 3 sensors and I send data every 15 minutes, then that kind of means that I'm throwing out about 100,000 records per year. What if I could do more with that? What if I, for example, could check trends using charts or Power BI? And what if I were to see something that I wasn't getting notified on, but still, you had a trend over time or over seasons that can still help me to take better care of Fluffy? And if I'm going to make such a platform, why not make it flexible? Because if I want to have a bigger terrarium, I mean, it's already quite big, but you never know, then maybe I want to hook up more sensors to it. And if I'm going to go ahead and build something like this, why not make it scalable? I mean, we might be moving house in a few months, and then if we have a bigger house, maybe I can have more terraria. I'm not sure if my boyfriend would agree with that, but it is what it is. So I started thinking about data lakes. And well, I'm going to assume that everybody kind of knows what a data lake is, but maybe you need a reminder. So I always like to think of Shakira. Whatever, whenever, data and lakes are meant to be together. Yeah, let's just get back to the snakes. So the idea behind a data lake is basically that you can store any type of data at any size in your data lake. So it doesn't matter if it's structured, unstructured, or semi-structured of nature. It doesn't matter if it's a small amount or a large amount of data. And it doesn't really matter what type. It can even be pictures or music if you like. But the more data you store there, the more you pay. And that's just how it goes. So, okay, I decided to buy myself, or well, build myself a data lake. Then we start with the architecture, right? What did we learn? I know that I have my Raspberry Pi that is sending data to a data lake. That is that Azure Data Lake Storage Gen 2 that you're seeing in the middle. I wanted to check trends, so maybe visualizations in Power BI would be nice. But maybe I will need something in between. So I'm starting to think about Databricks because Databricks is a great platform. And I started out on Azure on Databricks, so I'm kind of good with that. So for the pre-processing, not good in Power BI, so I might need Databricks. But then I think about the SQL Server. That's great for the structured data. It doesn't necessarily have to be very expensive, so I can deploy that, love it. Then I think about Azure Data Factory because Azure Data Factory has a graphical user interface, right? So that's nice if you don't really know how to code, but yeah. Then you think about Synapse. Synapse has the dedicated and serverless SQL pools. Love that, need to try it. And then you think, Fabric is also new, right? Isn't that great? Maybe I want to try it out. And then you think about, well, what about the IoT hubs? I mean, we have an IoT solution, technically speaking, don't you think? Wouldn't you like to try it out? But then you have the event hubs. Do you really know what's the difference between event hubs and IoT hubs anyways? I'm not sure. But what about stream analytics? I mean, if I want to do real-time analytics on Azure, then I need to do that for sure, right? Well, there you have it. I just bought everything. And if you don't believe me, I'll just show you a video of me while I'm talking what my research group used to look like before I clean it up. And there you can see that indeed I tried out everything. Well, that's not a great way to start. So in the end, try to keep it to a minimum. And don't trust the Microsoft documentation there, because if you go to the architecture website and you type in data lakes, then you will kind of find that this kind of solution that you're being shown here on the screen isn't all that far-fetched. So make sure to keep that architecture to a minimum. In the end, think about your knowledge base. You know, if you're really good with Synapse Analytics, but just saw that amazing workshop on Fabric, well, maybe it might not be a good idea to immediately switch. And then also try and think about costs, because cost can be an edge case here, right? Especially when it comes to streaming solutions. Sometimes streaming tools might be a lot cheaper than, for example, running a Databricks cluster 24/7. So think about that. Okay, so what did I end up with? So I have my Raspberry Pi sending data to my data lake. In between, I put IoT Hub. This has two reasons. First of all, this IoT Hub, you have one free IoT Hub per subscription. That's pretty cheap. And using that, I can directly sync the data to the data lake storage. I could have done that directly using Python, but what I can do with that IoT Hub is basically monitor the Raspberry Pi. So if the IoT Hub is seeing that the Raspberry Pi is not sending out messages, it can send me an alert. So I'm monitoring my Raspberry Pi, so to speak. Then, in between the data lake and Power BI, I'm going to use Databricks. I'll tell you why. Honestly, I could have just done that in Power BI, but I'm really bad at it, and I'm good with Databricks, so I'll stick with that. Then we get into a question, right? Data lakes, more data, should be more better. But honestly, not always. So it's easy to run in a scenario where you put data that is maybe raw data into your data lake. And then after some time, you find that there's a schema change and you need to put everything in a backup folder. Or you try to implement the data lake layers, bronze, silver, gold, but you stopped right in between. Or maybe after some time you started it, but still had some old folders. Then maybe you try to clean and transform some data and you put it somewhere else. And well, after some time, you kind of know what you're doing. You're not creating a data lake, right? We're creating a data swamp. So it's very important to think about storage paths. But I guess the most important thing is that you really communicate this well with your producers and your consumers. What I would say you would need at the least is a source and a table. So if you think about SQL Server, then you could say the SQL Server is the source, and then the tables in your database can be different table folders. Then for my terrarium, it could be the source is my Raspberry Pi, and then the tables are different terraria if I have multiple snakes. A processing type can be nice, streaming or batch. Some people really like that. One thing that you always need is a version. I mean, sometimes data engineers will tell me, Lisa, this data is never ever going to change. But you know what? I'm here to tell you, yes, your data definitely will. I always like to use something like a load date equals load date partitioning. And that also helps with my compute later on. So think critically about the compute that is using your data on a later stage. So if you're using Spark, for example, then in order for it to understand your partitioning, it would need something like load date equals load date, or a partition that is more applicable to your use case. But if you're using Delta Lake with liquid clustering, for example, then something else might be necessary. If you want to go one step further, you can look into data lake layering, bronze, silver, gold, role-defined derived, etc. In the end, I thought I really knew my data, right? I had bought the Raspberry Pi, I had hooked up the sensors, I created the program, I deployed all of that infrastructure, and now I'm ready to visualize my data. And this is what I found. An ambient temperature of about 3000 degrees Celsius. I mean, I know for sure my snake hasn't fried yet, so what is going on? In the end, I kind of found out that even though I created everything, I honestly still didn't know my data because I had missed the fact that my Raspberry Pi was sending out a lot of duplicates. So I'm here to tell you to plan accordingly in your data projects, because even when you really think that you have everything figured out, you will find that perhaps something unexpected will happen. And then lastly, I want to leave you with one more thought. When it comes to data applications, it's incredibly important to monitor your spend, because data applications in general are pay as you go. So the more data that goes through it, the more you will pay. So make sure to set that budget and an alert. An alert can be on 75% of the budget, or exceeding the budget, or expecting to exceed that budget. But whatever you do, make sure to send out that alert so that you're notified accordingly. And do be aware that a budget doesn't necessarily mean that your subscription is going to be shut off after that alert has been sent. So be mindful of that. You actually need to do something before you hit that budget. Okay. Being mindful of the time, I think it's time to reach our conclusion. In the beginning, when you design your data lake, make sure that you don't buy everything like I did. But do make sure that you monitor everything so that you know you're not exceeding that spend and that your application is working as you thought it should be. It's critically important to think about storage, but more important, to also agree on these storage paths with your consumers and your producers. Because if they don't know what to expect from the data, then nobody can use it. When you think about those paths, always make sure to also think about the compute that's going to use it later on, because that might mean a difference in your agreements there. If you want to go one step further, look into data lake layers. In the end, make sure to really plan for the unexpected, because even when you think you know your data, honestly, I'm sorry, but you really don't. And in the end, if you are in doubt and want to learn more about data lakes, just buy yourself a pet Python. Thank you very much. My name is Lisa Hoving, and as I said, I'm a big data engineer at the Rabobank. And if you want to speak to me and didn't get the chance to do so today, it's at Lizardo8 on LinkedIn and on Twitter. Thank you.
Thank you very much, Lisa. This was super duper cool.
Thank you.
And because our next speaker is already waiting, I will remove your screen from the stage and add David to the stage. Thank you again. It was a pleasure listening to you. Hey, David.
Hi. Hello, everybody.
Looking forward to your presentation. I will
I have a lot of material, so let's start.
Yes, and now I'm gone. It's up to you. Be excellent. Thank you very much.
You can see my screen?
Yes.
You can see my screen?
Yes, sir, I can.
Okay. So let's start. Power BI, machine learning, and OpenAI, fast track, the complete guy. This is David Itzhak. I'm about 24 years DBA of SQL Server Oracle Sybase Postgres. I have 3 degrees, BSc, MBA, ME, also specialist in NoSQL solutions. I'm research associates in a big enterprise organization, and also a team leader of DBA and data engineers. So what is our agenda? We'll do a full demo of how to handle data from the beginning on real data. Assumption, we not use Biopower Copilot data flow, which require premium editions. So the first section is requirement, data model, load, and explore. This is the section. We'll see it next. How do we prepare the data with the Power Query for the ML queries? Okay. Build the semantic models and find feature with R and Python visuals for the ML queries. So this is, by the way, this is my previous lecture, a lot of lectures. One which was world hit is OpenAI, ChatGPT, and GPT for Power Desktop, SelfNI, NLP, R, and Python, SQL Server, SQL Server 2090-22 container Kubernetes, TSQL will function in SQL Server 29-22, adaptive query plane in SQL Server, query storing in SQL Server, and a lot of lectures. You can see it here. So these are my previous lectures. This is me. This is the previous lectures. Okay. I use for my lecture a lot of materials. I read a lot of books. Most of them come from A-Press. This is A-Press, a lot of good books. This is the writers. They're very, very good writers. I learned a lot from them. backup publisher, and also Pluralsight. So this is the books and the video I used for the lecture. You can see it here. Pro DAX, Pro Power BI, Expert Data Modeling, Extending Power BI with Python and R, Power BI Machine. By the way, these books are not indexed by ChatGPT, so we're not finding in ChatGPT. And also these books for R and Pythons, you can see it here. Books and videos for ChatGPT. And also this course from the Israel Institute of Technology, Electrical Computer Engineering faculty, Anthropomorphic Learning, Data Analysis, Machine Learning, and Deep Learning. And let's start. So the demo, you can see it here, is built from 4 parts. Part 1, Part 2, Part 3, Part 4. In each part, you have the PBIT template Power BI and PBIX, which include the data. Okay, so let's start with session 1, require data modeling, load, and explore. So we will build real data from Federal Activation Administration, FFA Wildstrike database. I will use it for our demo. And we the demo file, we'll start with the demo file in part 1. So when you load the template file, you have to give him the path to the data. So in this case, in the data, and then upload. So our technical requirement that we use Power BI Desktop, which is my 24 or later, no license is required. And you have to run the PBID desktop setup 64 bits. And you can run it as follows. You install Power BI Desktop. No Azure, nothing. You can do all in your Power BI Desktop. You install it. And after I install it, I have to download FFA Wildstrike data. So if you go to these links, you can see it here. You can see it here. This is the database of all the accident with birds and airplanes. So you can download the material. I will not do it now because we don't have too much time. You can download the material. The material includes Excel access file and Excel file. This is the download. You can see it here. Sorry. You can see it here. This is NWSD zip. NWSD zip include the access file, which include all the data, and Excel file, which describe what's in these access files. So you can see it here. This is the source data. We download it. You can see it here. What I do, I will not do it now. We will. This is the Wildfire Access DB. We will upload it to our PI desktop, get data from other source, and we'll upload the access data file. You can see it here. And after you upload it, Strike reports, you can see. You can preview the data and upload it. So if you go to our demo, part 1, requirement, load, explore, this is part 1 demo, you can see it here. The Strike reports, which is the data which was uploaded from the access file. You can see it here. So index star, insert date, insert months, insert years, etc., etc. You can see the airport, latitude, longitude, runaway. And also you can see remarks. You can see also the remarks that will enter manually to the access file. You can see it here. You can see the species. Okay. So we upload it. And this is the Strike reports. Now know that if I want to see statistics about the quality of columns, for example, index HR, we can go here, if we are here, okay, home, then transform data, and again, and can I go transform data, transform, this is index HR, and you can see immediately the statistics about the columns. So for example, you can see it here. You can see that if you go to formula bar, column distribution, column profile, which show white space, etc., you can see that indexes in R, for example, have zero error, zero empty values, and this is the index in R. So no empty values, none error. You can see this in column statistics. Sorry, this is here. You can see it here. So if you go to view, you can see all the data here, and it's very, very fast. So this is indexes R. We also time of the date. So if you go to time of the date, you see that we have 5 distinct values and about 1, 2 which are blank. So if you go here, you can see it here. Thus, you can know what is the quality of your data, and you can see the column statistics. You have 5 distinct values. You can see the value distribution with the value day, night, dusk, dawn. Okay. We have more than 100 columns in FFLY striped report data. You can see it here. So if you go here, you can see, if you go here, you can see that we have more than 100 columns here in striped reports. You can see it here. These are the columns. This is the data which came from the site. So the column categories is date and time fields, event, where the event have date, time, and year for the different event related to each report, event, age, latitude, longitude, aircraft ownership, aircraft type, estimate of the damage to the strike, wildfire struck by aircraft, species and size. So this is the columns. Note that in the Excel file, there is a tab which is called column name, describe each column in the Access file. Okay. And now we upload the Excel. So you go to Excel work and we upload the Excel. I did it before, readme XLS. And now we'll select aircraft type, engine code, engine position. And we click OK, and we'll see all these columns here. This is what came from the Excel, aircraft type, engine code, engine position. If you go to Excel, you can see it here, engine code, aircraft type, engine position. We'll close the Excel. And aircraft type, it's map. This is the aircraft code. The description we describe, which is airplane, helicopter, or glider. So if you go here, you can see it here. Sorry, we go here. So aircraft type, you can see this is the code which describes the aircraft code and the which aircraft is it. Engine code, this is the code of the engine and the engine itself. Engine position, the position of the engine. Note that the first row contains the description of the column name. We'll add it later. So you can see it here. So this is how it looks. So after we do it, we do close and apply. So we have 3 tables. Note that we have some unnecessary and blank value. This is the raw material. Okay, this is the raw material. So you can see it here. So what is the goal of our project? To do interactive analysis of wildfire data, to find insight about the factor that influence the incident, make prediction about future wildlife strike incident, which will cause an incident. So what is the output? It's an analytic report, of course, to view the trend over the time. Predict the damage. You want to predict the damage. When the strike is reported, make a prediction whether there will be a cost associated with the damage. Sometimes there is no cost. Predict the size. When the strike is reported and a bird clash with the airplane, make a prediction about the size of wildfire that stuck to the aircraft. Predict the height. For wildfire strike, predict the height of the incident. Okay. So this is the FA wildfire database, wildfire access DDB, and the access file. So we have 2 simple assumptions about the modeling. Star schema is the design. It's usually efficient for most BI solutions. in the aspect of storage and query performance. But basic ML models are not doing well, cannot operate with star schema. They need flat table. So again, we have the struct report. Each row represents a report that describes incident. Engine code, aircraft engine, that can be tied to the struct report. Aircraft type, information about the aircraft tied to struct report. Engine position, the aircraft engine position can tie to struct report. So if we go here, okay, and you go here, you can see the 4 table. You can see it here. You can see it here. Aircraft type, engine code, engine position, and struct report. Currently, there is no connection between the table. Okay, so what 3 basic approach we can do in Power BI for ML solution to analyze the data? We can flatten all the data into one big table. We will join engine code, aircraft type, engine position, struct report. We can do a star schema, and we build a true star schema, which struct report, which is the fact table, and engine code, aircraft type, engine position as dimension table. We can do another additional dimension table like date. We can use also another dimension, for example, airport ID, airport, state, region, etc., etc. We can do hybrid design, which use star schema, but flatten attitude. So build out hybrid design. So what is the best? So how do you flatten the data? So we take engine code, aircraft type, engine position, and struct report, and we do one big table. Pro and cons, its simplicity, no join, commonly used by data scientists. We can use columnar database to compress the data. No relation data model, but const, insufficient storage, limitation with queries, less flexibility, complex logic. Queries are not efficient on flat table. Star schema. So in star schema, we can take the 4 table, take struct report, aircraft type, engine code, engine position, and create another dimension table like location and species. So pro and cons, it's often aligned with business logics, balance between minimal data duplication and efficient queries, extendable, and this is the recommended standard for BI. Const, with modern tool, we don't have to use star schema. The benefit of data duplication are less impactful. Complicated ETL for star schema. Machine learning and model learning are usually trained with flat table and then don't always scale up. So what we'll do hybrid design. Why? Because struct report contain only 3,000 rows and 100 columns. There are only 2 columns, remarks, comment. You can see it there. Only 2 columns. Sorry. If you go here, struct reports. So remarks and comments, which are free text. So we don't talk about a lot of storage. So the difference between data storage between flatten and star schema are minimal because the data is not so big. So in our case, we will use the hybrid design. So what is the hybrid design? The hybrid design means struct report is here, and we'll build only 3-dimension table: aircraft type, engine code, engine position. Later we'll build a date table. So pros, rapid prototype, less lodging in data, flexible design. Cons, less performance than star schema, of course, because it's hybrid design. Additional logical complexity. still need to be flattened, data or machine learning. No perfect for BI or ML, but this is a compromise between the two approach. So note that we have to do another additional sources. So what is additional data sources? For example, date-based aggregation like month, quarter, season, time-based aggregation, which are very easy, and another sources like data for the flight that didn't flight wildfire track. This is difficult. Weather map to date time of wildfire track. This is difficult. And about the species, difficult. So, so let's explore the data. So we want to find time column. So if you look here, we see that we have a column which is named time, the time column. But if you look at the time column here, you can see it here, strike reports, go here. Okay, so let's go here because I don't have too much time. If you go to the time, we go to transform data and look at the time, you see that we have more than 90% empty values. So this is not the right column for date column. So, by the way, if you do, and we have another optional column, which is the incident date. If you look at the incident name, we see that incident name we have 100 valid values, 0 error, and empty values. Okay, so if you go also for here and go for the DAX, this is a new feature of Power BI, and you go to start reports and you go to incident date, right click here and quick query, show column statistic. Immediately it will create the query in MDX. You can see it here. You can run it, and this is the result. This is the incident date. This is the number of rows, distinct value, null count 0. So mean value and max value. So this is a perfect column for our date column for our Hebrew design. So you can see it here. You can see the query. Okay, so this will be our Hebrew design: start report, engine code, fact table, and the dimension table: aircraft type, engine code, engine position, and date. So we finished part 1. So what is our flow? We will take the raw data. This is our step down. And then we make analytic data which is not cache. Then this is second. This is the step 2. So data exploration initial load data. We have done it now. Analytic report in Power BI. We will create a training data. Move training data to Power BI data flow. Train, test, and deploy like in ML models. So we have finished this stage, and now we're moving to this stage for the analytic data, which is not cache. So Power BI ML offers 3 different types of predictive model types: binary predictions, which say prediction of yes or no; general classification, which predict more than 2 possible columns, such A, B, C; and regression. Regression predict a numeric value based on past value. So this is so we want the output of the stakeholder is analytic report, predict damage, predict whether damage will be result from a wildfire, binary prediction, yes or no, predict size, predict the size of the wildfire, the bird that struck the aircraft based upon factor like damage cause, damage location, age, time, year, airport, location, output, and predict 8. Predict the 8 of which wildfire strike will be happen. A numeric value presenting the 8 above ground level in feet. We'll use for this regression. So this is binary, this is multi-classification, and this is regression. So we have 3 options. So let's close it. Close this. Close this. And open part 2 of the demo, which talking about how do we prepare the data with Power BI queries. Just a minute. So this is our demo file. Okay, we'll talk about it. We open it. Okay. And now we are going to this step 1. In this step, we take the raw data and build the analytic data, which is track report with the state table and the dimension table. So first, we want to group all the raw data. How do we group all the raw data? A minute, where is the Power BI? Till it goes up, say, we go to the queries panel and create raw data group and call it raw data. And in this raw data, we will put our stack reports, aircraft type, engine codes, engine position table which we have uploaded. This is data without changes. On this data, raw data will not enable load. Why? Because this is the raw data. Just a minute. Just a minute. I didn't open the right one. Just a minute. Demo 2, part 2, and this is the PBIX. Why? Because we want this raw data to consume storage in Power BI service. This is only raw data. So this is track report, aircraft type, etc., etc. So now we want to evaluate the dimension table, evaluate data time columns, evaluate geographical, aircraft operator description, species and animal columns, weather flight details. So how do we do it? First, we can know that AC class column with track report is mapped to aircraft code in aircraft type table. So this is the connection you can see. So this is the fact table, and this is the dimension table. So AC class is connected to aircraft code. You can see it here. Let's go. Step into the Power BI. Just a minute. What? Just a minute, let's close. Let's close. Okay. So this is part 2. Okay. Now you can see. The table. Home. So here, transform data. So you can see the raw data here, and this is the raw data here. You can see it here. So engine position code is mapped to H1 pose, H2 pose, and in strike reports. Okay. So what I have to do now is pass all of the column and say column name. The name of the column is strike report. Initial data type. What is the data type? Either detected in Microsoft Access file, or I have to change it. Note, you note about each column. Keep, whether to keep the column or not. A new data type. What should I do? Should I have to change the data type? Key, this is a 14 column. So you can see that here we make a table about the strike reports and see incident date, it's daytime. No, this is a date. What? Keep, yes. New data, date. Key, yes, it's the table, incident date, etc., about all the columns. You can do. We also run on strike reports about all the geographical and location columns, the same. And we go about the operator of the aircraft in strike report, each column, whether to keep or not. You can see you can see here. We run the species in strike reports. We run about the weather and the flight detail in strike reports, column. Okay. And we have an additional columns. So now we have to build a primary strike report in quoted group. So here, so what we do here, you can see it here. Here we create a quoted reported queries. Then I will take a reference to each table here. For example, I go here and make reference. You can see it here. So this is a reference to the regional strike reports and move it to quoted reporting queries. In quoted reported queries, I will take the strike reports and do all the change I need. This step should be done for aircraft type, engine codes, engine positions. I've already done it. You can see it here. So what I did here, create quoted reporting queries, and then reference to the original raw data. And you can see it, I copy it here. And what I do here, I pass on each table and keep only the columns that we need and get rid of the column that we don't need. You can see it here. So this is the column we don't need. So we unselect them here, strike reports. We also do a change to the name of the column. For example, in the original, it was incident underscore date. Here, in strike report, it's incident date. So we unselect undesired column, and also we change the name of the column. Okay, we also change the data type. Okay, so example, incident date was daytime, and we change it to date. Why? Because there is no time reportion in incident date, so we can save it as date. So if we go here, strike report incident date, transform incident date. So incident date is a data type which is date. But if you go to strike report here and you go to incident date, you can see that it is daytime. So again, we took all the raw data, unselect desired column, and check the data, change the data type. So this is one example. Okay, and this is all the phases we did. This is the description about what we did here. And now I have to build a group of dimension table, aircraft type, engine code, engine position, and date table. So again, we take aircraft type, engine code, engine position, make a reference, okay, copy it here, change the name to strike aircraft type info, engine code info, engine position info. And, and you can see it here. But what is interesting, you can see that if you go at the original data here, you go here, for example, you can see that the column name here is column now. So in order to make it column name, we go to aircraft type, and here, Shelin, use first row as header. Also for engine code, you can see it here. Also for engine position. And if you go here, you see that aircraft type info, this is the column name. Engine code info, this is the column name. Engine position info, this is the column name. Okay. And first as column. And we also move null value. Simply, we did not select null value in the quoted reporting queries. Okay, let's run fast. And this is the engine position info query. We did all the same step for all of them. Copy the table. You can see it here. Copy the table. We unselect nulls and make the first row as column name. So this is what it did here. I will run fast because I have two more. So now I want to build a date table. I can build a date table from Excel file. So if you go to here, you have Excel file of datetime. You can see it here. But I'm a DBA, and it's very hard, and I don't have MDX. And the simple play is to go to Power Query to ChatGPT and tell him, act as a Power Query expert and help me to write the M code. And ChatGPT say you, sure, I help you. Then I will upload, you can see it here. I will upload the Excel file and tell him, in my Power Report, create a calendar table starting from blah, 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 and running to datetime, and give him all the column in the Excel file, and give him guidelines. Add a blank line after each step. And it run and give me all the code I need to create date table. So if you go here, you can see it here, ChatGPT date info table. You can see it here. So after I create the query, I will ask him also how do you upload him, and he will tell you how to upload him. So how do you upload him? Simply, you go to Home, Blank Query, okay, Advanced Editor, Query 1, and you can see the code which ChatGPT give me. I don't have time, so I will not run it now, but if you go here, you can see it here. This is the table which ChatGPT create for me. Transform, just a minute. Advanced Editor. And if you look here, this is the code ChatGPT create for me for the table. He also give me remarks. He also give me the code and documentation. Look, and this is the result. You can see it here. So I can use the Excel file, and I can use ChatGPT. So this is our build, our date dimension table. Please clock and apply, and that's all. This is a summary. So now let's build a semantic model very, very fast. Now I'll close. Now close here. Don't save. Just a minute. And I will go to part 3, which tell us how to build our semantic model. So go to part 3. To make it more convenient, I go to part 4. Therefore, we don't have to open part 3 and part 4. And I will open part 4. Part 4 also included part 3. So go to part 4. To make it short. Okay, we are in part 4, which contain also part 3. In part 4, we'll build our semantic model. Okay, so let's run. So blah, 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 blah. This is how you upload the data. That we have date table, the date column match incident column name on strike report, where aircraft type, which is aircraft car code, which match the aircraft class code on strike report table, engine code info, which code and model code, which are compound key, which matching the key with the column AMA and AMO in strike report, engine position, which is engine position 1, 2, 3, 4 in strike report, which match engine code in engine position info. So this is the date table. We can see that in date table, we have 100 values, 0 error, 0 empty. So this is a good candidate to be as a key table. And we can see that if you go to incident date, it's also, this is the foreign key table on strike report, which has 100 values, error and empty. So if you go here, home, some data, then you go to strike report. Go to strike reports. You can see fresh, valid 100%, and you go to date info table. Go here, fresh. You can see also valid 100%, error where 0 error, 0 empty values. So this could be two matching columns. Aircraft type info. So you go to aircraft type info. We have aircraft code and aircraft classification, which have one distinct value and one unique value. So this could be also a key table, a key to the strike report fake table. We can use the aircraft classification because we are talking about only one distinct value. So it's okay. And know that if you are using with LMS solution with problem with null. So how do we move null? We go to aircraft class column in aircraft class code, and we write here null, replace it with blank. Okay, so every time we have null, this is an empty field. Now in this null value, it will be written black. So right-click the aircraft class column and select a place value with null. So all empty value will contain the black. Now we'll create another table which contain black, null, null. And now what we'll do, we'll append this table. We take this table and append this table to aircraft type info. Why? Because ML model have problem with null. So we go to check. We have to go to the null value, change it to blank in the fake table, and if in the and if there is black column, we change it to black. So if you go here, okay, you can see that you can see this is the table we have created, and now this was headed to aircraft type info. You can see it here, black, null, null. The same for sorry. So this is for aircraft type info. Let's go fast because I don't have too much time. Now we'll create the relationship. How do we create the relationships? Okay, so if you go here, how do we create the relationships? Show you. We have to build our data set with the relationships. So how do we build the relationships? Just a minute. We go to our we go to our data here. This is the sorry. Before we do it, we know that this is the data that will load into the Power BI data set. So we go here and enable load, and including report refresh for this table. So again, you are going to create a dataset table and then enable load. Why? Because this is the actual data that will be uploaded to Power BI after we have transformed it. So this is data. And we do close and apply. And now we have to build the relationships. For if we go here to the relationships, we draw a link between incident date, you can see it here, and strike report and the DIMP on the column. Strike report fact incident dates, the column date in the DIMP table which we have created. Cardinality is many to one. It's obvious because we have a lot of dates, and in the table there is only one date, and we must make this relationship active. And the cardinality is many to one, single. Cross filter means that the table cross filter single. So this is how we create the relationship. In the same way, we build a relationship between the artifact table, aircraft type DIM, and in this example, we take engine code DIM, engine positions, and if you go here, for example, you see that engine strike report fact, engine position DIM, and here we mapped and engine position 1 to engine position in engine position DIM. The same for all these engine positions. And here we mapped engine code to engine code strike report and engine code DIM. So this is all the process we did in order to build our semantic model with the connections. You can see it here. Strike report, fact, engine position code, engine position, engine code, etc., etc. And you can see the semantic model we have built. And this is the complete relationship we have. And you can see it here. For example, engine position code 123 is mapped to one column in engine position info table. You can see it here. Okay, so let's fast. Now we can hide unnecessary columns which don't need in the dimension table and fact table. For example, engine code info key, incident date, aircraft class code. Why? Because they are not needed in the report. You do it here, and that's all. And then you can adjust the column. For example, in strike report fact, latitude should be format in decimal number with 7 places. Don't summarize. This is the last finishes of the data. You can see it here. Okay, I'm faster because I want to go to the Python. I can also adjust the date for the DIM table. But what is more important, I go to the date table here. You can see it here. Go here. It's very, very important. Day DIM, and tell him mark as the date table for day DIM here. Why? See it here. And then I can make several measures on with that expression on our strike report facts. For example, incidents. So count on strike report facts, average speed, average age. It's very, very simple. How do I do it? I go here, you can see it here, strike report, and here I can do a new measure. You can see it here, but I've already created the measure here, and you can see the measure here. For example, average 8. You can see it here. Cost strike by average. So this is the measure I've created. They are computed at runtime. So this is the measure I made. So we're now ready with our data for our ML model. Now This is the last section because I only want 10 minutes. I want to find feature with R and Python visuals. What is technical requirement? If you look at this guide, it will tell you how to install R on your local computer and Python on your local computer. So you can use R Visual or Python visuals. How to install Python? Very, very easy. You go to the Python and write Python installations. Yeah. I put my Python tutorial and see Python, and the versions. After I install Python, I install the required packages. So I go to CPython script pip and the version, install Panda, Matplotlib. In this example, I also install COVID package, Panda, NumPy, Matplotlib. This is the package Power BI needs. COVID is an extra package. So this is how I install the and after that, you go to option, setting, and tell him what is the path of your Python on my computer. So this is the path of Python on my computer. You can see it here. Okay. The same with R. You install R. You have also R console from which you can install other packages. You could, of course, install ID, but it's very simple to go R console and install the packages. And tell him where is R installed on our computer. C program R and what is my favorite IDE. Okay. So let's talk about our visuals. R is a very powerful language, but I think Python is now taking over R. But also R is very powerful because it's for statisticians. It's very simple, and it's have a great visuals. I have a lot of lecture about R. So there are numerous R visuals. A model, but how do you use R? So I have to prepare data for R correlation plot. We will use correlation plot, which will tell you what is the correlation between the parameter. We build R correlation plot visualization and add it to our report, identify new feature for our API. So first, what we have to do, if we drag our visual and try to drag into the damages or into the damage, for example, here, let's go here, will tell us, there is a problem. So what you have to do is to convert all the true following column to an integer column where 1 represents true and 0 represents false, because R cannot eat, which is not a integer value. So if you go here, okay, if you go here, home, home, and if you go to advanced editor, just a minute, transform data, and we go to, we can see that what we did is take all this column, copy it, and change to, the column will be used as stack report query for the report queries groups. This is true false column. We copy it, change it, the name with to, for example, indicate damage E, and select the whole number. So if we go here, let's see, strike reports. You can see that, just a minute. We can see that we take all this column and change, we take all the column and change them to copied and change into. So if you go here, reports, just a minute. You can see it here. There is struck knows it, damage knows it, which is a copy of struck with it. This is a copy of the true false column, and we change them. If you look here, you can see that this is a whole number. Okay, we copy the regular column, change it to 0, 1, and a whole number. So this is what it did here. You can see it here. And now we can build our R correlation. So we drag R script in Visual to Visual R Visual. And for the whole page, we build a filter on the page which predict damage with extra drive and airplane filter to greater than or equal to. It means that if we go here, sorry. If you go here, okay, and we go to and we go to our, just a minute. Go to our, just a minute. And we go to our visualizations. This is the filter we do for you. And now what we have to do, you can see it here. This is the filter we do. Okay, aircraft type predict damage. And we put these filters. And now what is more interesting, we drag R. And now it tells us drag fill into the value. So what I'm dragging here is incident date. We'll build out the skeleton code. And then we have to add the following to this column code: required core plot, library core plot, MCore dataset, and this. This is what we have to add to the visual. So if you go here, we go. Go to the R visualizations. Okay. We can see that this is the plot we have. Now I will add all the integer column I've created, indicate integer here, to the visual. You can see it here. And now I will have these graphs. Okay. But this graph doesn't tell me nothing because I can see that there is a big correlation between the parameters in themselves. So now, after I did it, I will play. What I will do, I will play with the filter here. Here is greater than or equal to 24. Airplane is airplane. Size is large. You can see it here. Aircraft mass code is 345 FCON. And now I'll see correlation between the variables. Here you can see it here is the correlations. If there is a big black, if it's black, this means there's a correlation. These correlations have no meaning because this correlation between the parameters themselves, but this correlation between other parameters. If it's more black or blue, then there is a good correlations. You can see it here. So you can see it here. If you look at our visual, we see that we have correlation between all these variables, that we can use them for our ML queries. Now I have 4 minutes. We'll run very fast about Python visuals. So this was our about our visuals. Now we're talking about Python visuals. So this is our Python visuals. We do the same. So we drop here Python visual. You can see it here. And we select the value speed. You can see it here. And now this is this is the script. And now this is the code which I have to put into Python. It's very simple. It means import metabolib pyplot. It means create an histogram about the speed, which is bait histogram about the speed, X label speed, Y label incident, and speed for incident with damage. Plot now, and this is the result. The result is histogram of the incident, speed for incident with damage. Now I can copy this code and create speed for incident without damage. How do I do it? Because if I go to the filter, and I tell him where incident is false. So now I create speed for incident without damage. And I can do, and I can play with it. For example, I can put a filter which puts speed less than 700. Now I can copy it, and I can create Instagram for the 8 and the incident. So I can create 2 incidents. Incident 8 for incident with damage, and 8 incident without damage. So if you look here, so you can see that. If I go here, for example, you can see the code for the code of the Python visuals. You can see that for which result incident damage is true. Cool. And we're talking about the speed. If you go here or here, okay, you can see that this is also the speed. 8 for incident without damage, because speed, you can see incident damage is false. Now, if you go here, you can see that this is a plot for the 8, and where incident damage is true, and if you go to this, you can see that this is a plot for 8, where incident damage is false. And again, we have filter here. You can put it filter on this. So I'm exactly on time, I think. This is the end of the lecture. I will send you a demo, a link to the demo where you can upload the code and play with yourself. So thank you. So thank you.
Hey, David, it was a pleasure.
Thank you.
It was a pleasure to meeting you, listening to you, learn from you.
I can continue and continue, but it's only 1 hour. I can continue and continue, but it's only 1 hour.
It's only 1 hour. Kevin is already waiting. So thank you very much.
My pleasure. Kevin is already waiting. So, and I'm also invited to my lecture next week about graphing, SQL, and Azure in another conference. And I'm also invited to my lecture next week about graphing, SQL, and Azure in another conference. And I'm also invited to my lecture next week about graphing, SQL, and Azure in another conference. And I'm also invited to my lecture next week about graphing, SQL, and Azure in another conference.
Hello, world.
Hey, Kevin.
Hi. Just so everybody watching is aware, I won't be keeping an eye on the comments.
So now I added the tone again to my speaker. Hey, Kevin. Regarding the time, regarding the power of 5G that you have to use for traveling today or presenting today, can you please say something, because I wasn't able to hear you?
Testing, 1, 2, 3.
I understood.
I can hear myself on your feedback.
I hear you telling testing, 1, 2, 3. It looks like this is what all of us are doing. Here's your screen. I will leave the stage. Thank you very much.
Thanks, Thomas. And for the benefit of those watching, I won't be keeping an eye on the comments because I know some people like to get a bit chatty. I'm hoping if there is a question, Thomas will kindly put it in another chat session for me so I can keep presenting to all of you today. So, hello everybody and welcome to today's session, Microsoft Fabric and Azure DevOps, the story so far. Presented kind of live and in person actually from SQL Daylight in Poland. Managing some expectations for this session, there will be demos during the session. It will all be done in a trial tenant. There won't be any NDA material. And the most important aspect here is it includes details about the new Microsoft CI/CD workflows document. Maybe I should keep an eye on the comments just to be on the safe side. Nothing coming in so far, so that's all good. Right, so here's the agenda for the session. I'll quickly go through my bio. Now I do introduction to Microsoft Fabric. Now I do introduction to Azure DevOps. And then I go through configuring Azure repos for Git integration. And then, I appear to have lost context there again. And then I'll talk about using Azure DevOps with the suggested CI/CD workflow options that were recently released by Microsoft, and a couple of my own personal views on them. And then I will round up with CI/CD for data warehouses. Now, Thomas, can you just reach out to me by chat just to make sure that you can hear me okay and there's no questions coming in the chat so I can carry on presenting for everybody? Like I said, I did try to keep an eye on the chat coming in, but there is a lot coming in so far. Doesn't look like there is, so that's all good. Right, so Thomas is keeping an eye, everybody, not to worry. I can carry on talking. So my bio. So my name is Kevin Chant. I'm a data engineering manager living in the Netherlands. However, as some of you can probably tell from the accent, I'm actually originally from the southwest of the UK. However, I live in the Netherlands due to the fact my wife is Dutch. So basically, I'm an Englishman, living in the Netherlands, working for a large international company because he met a woman in Australia. Now, if you cut that with that, you're in a good place for this session. Now, I've worked in IT for quite some time now. And over the years, I've experienced in various sectors, including the banking, oil, and health insurance industries. And in fact, thanks to that, Thomas, and I can actually see the comments now as well myself. So that's good. I'll keep an eye on questions, everybody. So yeah, so I've worked in IT for quite some time, basically. I've got quite a fair few certifications. I'm a Microsoft Data Platform MVP for Microsoft Fabric. I'm a Microsoft certified trainer. I'm an organizer of another conference. And I'm also one of the organizers for the Dutch Fabric user group. As you can see on the slide online, you can find me online in a few different places. And what I'll actually quickly do for you all now, providing I can get the links up okay, just bear with me a minute, folks. I will actually copy the links. I will send a copy of the links over now to Thomas. They will be in a set of slides I will share after the event. But hopefully, if I ask Thomas very nicely, he will put them all in the comments for you now as well. So, oh yeah, and I also have my own blog where I blog about data platform developer technologies, quite often with the two together. I have my own GitHub site where I share pages as well. Anyway, that's my very quick bio for you all. I'll share my socials later as well. Right, let's go straight into a very quick introduction of Microsoft Fabric. And I'm sure by now, the majority of you have seen a diagram similar to the one that's on the screen before, which represents an overview of the Microsoft Fabric architecture. So at the top, you have the 4 pillars that represent Microsoft Fabric. So it's a comprehensive analytics platform. In other words, everything's available by going to one website. It's lake-centric and open, so you can store everything in a unified storage solution in Fabric. These can be any file types or nicely curated Delta tables, depending on your preference. Empowers every business user so they can use tools that are familiar to them. In fact, if you watch the official digital launch videos from last year, there is a very interesting demo on there relating to Microsoft PowerPoint. And it's AI powered as well, because as you may have heard, there are a fair few Copilot instances scattered around Microsoft, well, features scattered throughout Microsoft Fabric, as well as a few other interesting things like AI skills capability. So, in addition to this, if you're going to look to work with Fabric in an enterprise environment, I do recommend 2 other groups of services as well. First one is Microsoft Purview for your compliance and governance needs. Some of you may be aware, recently there is a new Purview portal now that actually combines the 2 together. And licensing is going through some changes at this moment in time. In addition to that, I recommend using either Azure or Azure DevOps or GitHub for your CI/CD requirements. Because as you may know, you can also now use GitHub for a provider for Git integration. Now, OneLake, which you can see highlighted on the screen because I got a bit carried away and went ahead of myself there, is the unified storage solution in Microsoft Fabric. You can think of it a bit like OneDrive for Microsoft Fabric, to be honest with you. OneLake is actually an abstraction layer over most of Azure Data Lake storage accounts. So all you have to be concerned with is working with the data, how it's presented in OneLake. I'll quickly go through the different workloads for you all now as well. Very quickly, of course. So Data Factory is where you orchestrate your data movements within Microsoft Fabric, typically using either data pipelines, which is similar to pipelines you may have worked with in Azure Data Factory or Synapse, or Data Flows Gen 2, which is based on Power Query. Next, there is Power BI, which is the same as before, but only not, due to some optimizations and innovations that have been introduced. The reality is that Microsoft Fabric is based on the Power BI architecture. So if you've got background in Power BI, you will thrive in Fabric. Next is Data Activator, and this allows you to generate alerts based on metrics that have come in either through event streams when you're working with real-time intelligence, or a KQL dashboard, or Power BI reports. And when I explain about this feature, workload to people, I tend to say it's data-driven plus. Then we have industry solutions, which provides you with a set of templates that you can work with for various types of, well, industry solutions, to be honest. Related at this moment in time, there's ones available for the manufacturing, healthcare, retail, and industries, as well as sustainability. So those of you who have got to look to produce CSRD reports, for example, over the next couple of years, may want to look at the sustainability industry solutions. Next, we have data engineering, and this allows you to work with the lakehouse paradigm at scale, where you can create lakehouses, which allows you to work with either files of any type or nicely curated delta tables, which you can manipulate using, for example, notebooks, which are backed by Spark Compute, similar to how you may have worked with other services like Synapse, Spark Compute, or Databricks in the past. Then we have Data Warehouse, which allows you to use T-SQL to work with large amounts of data at scale. Then we have Real-Time Intelligence, formerly Real-Time Analytics, and this allows you to work in a GUI-based manner with streaming data, typically through creating event streams where you can either store data into KQL databases or forward onto what's called reflex action alerts and Data Activator. You can also forward the data onto a lakehouse as well. Finally, there's data science, and this allows all of your data scientists to collaborate together and share notebooks and models and experiments all within Fabric workspaces. There, it does come with a lot of interesting things included with it, so it is worth looking at. So that is your very, very quick introduction to Microsoft Fabric. So, well, kind of. So therefore, well, not therefore, but one of the main things I like about Microsoft Fabric is that it removes friction, because in the past you had to plumb all the different services together, and sometimes you'll get some networking surprises. However, now the premise is that you can do it all in Fabric. So I will give you a very, very quick demo of Fabric, and I do mean quick because I'm sure some of you have seen these online before. So this is how Microsoft Fabric looks when you first go into it. And as you can see, here's all the different workloads I mentioned just now. If I click on settings at the top and I click on, for example, admin portal, those of you with a Power BI background or have some exposure to Power BI in the past may recognize this admin portal. It's the same as how it was in Power BI, but with new features added. I can also, after I've done this, I can access the workloads by clicking on the top left if I want to. I get to work with various workspaces in Fabric, and if I click on example one here, of course I'm doing a live demo online, so it's going to be a bit slow. Eventually you'll get to see that I can create all the different items for the different types of workloads all together in different workspaces in Fabric. If I click on new item, this will give you an idea of all the different item types that you can create for your workloads. Right, so that really is now the end of my very quick introduction to Microsoft Fabric. there is lots of material online available relating to it, and if in doubt, you're more than welcome to reach out to me. So let's now cover Azure DevOps. And Azure DevOps manages your application lifecycle management, all the way from creating your initial work items to actually doing the release. In reality, Azure DevOps is a collection of services. So for example, you get Azure Repos, which manages your Git repositories, and Azure Pipelines to manage your deployment pipelines. And there's two main, and you can customize, you can add additional services and features through the marketplace, before I forget. So there's two main versions of Azure DevOps. There's Azure DevOps Services, which is the cloud-based version, and there's Azure DevOps Server, which is the server-based version. And the key point from this session to remember is that only Azure DevOps Services are supported by Microsoft Fabric Git integration at this moment in time. And I will do a very quick introduction to Azure DevOps for you now. So this is Azure DevOps. When you first go into it, you get a little icon in the top left-hand corner that represents the account you are logged into Microsoft Fabric in, as well as the tenant, because it is tenant specific as well, because your account in reality could be a guest account in other tenants. I'll make this a little bit bigger for everybody as well. So underneath your account icon, you have the organizations you have access to. Now, these can be organizations you've created for testing purposes, or it can be organizations that have been created for you within your enterprise. If you have the relevant permissions, you can look to change various settings at the organization level. I won't go through all of these here, but some settings I will, because some of these are quite intuitive, to be honest. But what I will point out here is that if you go to settings, a while ago, Microsoft introduced the option to disable classic pipelines, and they had their good reasons for doing so. I do have a blog post with my thoughts about this as well. So I've seen now and again people asking why they can't work with either the classic editor or the release features in Azure DevOps. This is why, because your enterprise may have disabled these. It means then that you will have to learn YAML and work with YAML pipelines. So if I go back to my organization, each organization contains one or more projects. And if I click on a particular project, and of course I'm doing a live demo, so it's a bit slow. But as you can see, all the default services are on the left-hand side once I actually go into it. So you have Azure Boards to manage your work items, Azure Repos to work with a GUI-based, it visualizes your Git repositories, basically. Azure Pipelines to manage your pipeline deployments, Azure Test Plans to be able to manage test plans centrally in Azure DevOps instead of working with spreadsheets, and Azure Artifacts, which allows you to store your artifacts directly in Azure DevOps if needed. And just like at the organization level, you can change various settings at the project level as well. So this is a very quick introduction to Azure DevOps, and just like with Microsoft Fabric, there is a lot of material about it available online. I have some material in alternative sessions that I've done with another presenter in the past as well. So you're more than welcome to type it if you're interested in, for example, SQL Server or Synapse. Just type in my name followed by Azure DevOps, and you'll find some videos relating to it. Doesn't mean to be a plug, it's just, yeah, that's what is available. So that's a quick introduction to the two. Now we can actually talk more about Microsoft Fabric Git integration. So it allows you to synchronize supported items into a Fabric workspace with a Git repository. And the reality is, it's not a direct link from just a connection from a workspace to your entire repository. It's a connection from your Fabric workspace to one individual branch in a Git repository. That's an important point to remember. There's a direct one-to-one connection between your workspace and a branch in a repository. So at this moment in time, it supports Azure DevOps and GitHub cloud-based offerings. And it requires either a Fabric or a Power BI premium capacity. And when I say Fabric capacity, I do mean any Fabric capacity. You can work with this, for example, on F2. So as far as configuring Azure DevOps for Microsoft Fabric Git integration is concerned, it utilizes Microsoft Entra ID authentication. And just to help here, a bit of jargon, Microsoft Entra ID is the new name for Azure Active Directory. So it uses the credentials of the person who is connected in the account that is connected into Microsoft Fabric at the time. And that account needs access to both the Fabric workspace and the repository in Azure DevOps as well. So here's an interesting fact for all of you, and it helps make things a bit clearer. The Entra user needs to be on the same tenant as Microsoft Fabric, well, to work with Git integration at least. But it can be a guest account into that tenant as well. However, the Azure DevOps organization, where the repository is stored, can actually be on another tenant. And I will show you this again in a minute, because you may have noticed I had two organizations just now. So some security considerations to bear in mind if you're going to use Microsoft Fabric Git integration with Azure DevOps. So create your repository in the relevant region. This applies mostly to those of you who have got to work with regulations where regulatory purposes say you have to be in a specific region. Make sure, I would suggest to keep your organization private, because if you inadvertently commit sensitive to your repository, then it's going to be out there for all to see. I would consider using GitHub Advanced Security for Azure DevOps, especially if you're working in an enterprise environment. As I mentioned just now, you don't want anybody to see your sensitive values if you do accidentally commit them. To give you an example, now and again, sometimes people will put things like Azure Data Lake storage account keys into notebooks when they're testing things. If you have GitHub Advanced Security enabled and you have secret scanning set up, it will actually detect those secrets in the notebook and will refuse any attempts for a pull request to be made from the branch that has got that sensitive value committed into another branch. So it can be very useful. Now, if you do look to use GitHub Advanced Security, just please bear in mind that there is a cost factor as well, and it is backdated for people who have done commits in their repositories in the past. So I have some Azure pipeline considerations as well for you all to consider. So I would consider YAML pipelines. To be honest with you personally, I could change that with recommend, because I do recommend working with YAML pipelines instead. I like it because it makes your pipelines more portable, because when you're YAML pipelines, the YAML files themselves are stored in your repository, which means if you move your repository elsewhere, all you have to do YAML pipelines is just connect it back up again to your YAML file. Whereas if you're using classic pipelines and you move it, you've got to, and especially move it to another Azure DevOps organization, you've got to recreate your pipelines again, or the click way to get everything back all set up and running. Can be a bit tedious. Now, I highly recommend you use variable groups and Azure Key Vault, and that's to avoid revealing any sensitive secrets, basically. And you can directly create variable groups that get secrets directly from Azure Key Vault if you want to, or you can create tasks in your pipelines to get the values directly from Key Vault itself. And if you're going to deploy production workloads using Azure pipelines, make sure you implement an approvals process. For using YAML pipelines, you would do this by creating different environments. If you're using the classic pipelines, you create your release gates, etc. in there. So now I'm just going to go through a quick demo of how you can configure Git integration. So I'm going to go now into Microsoft Fabric, and I have, where has my cursor gone here? So I have a workspace, which I've quite imaginatively called blank workspace. So if I click on workspace settings on the top right-hand corner, I can then have various options. I need to select Git integration. Just zoom in for you all there. Once I've done that, I get the option of either GitHub or Azure DevOps. So if I select Azure DevOps, I can select my Entra account straight away. No need for additional configuration. And here I can select organizations. Now, one point I will highlight, which I did mention earlier, you can see I've got 2 Azure DevOps organizations here. And if I go back into Azure DevOps a moment, and I have to go to syntax here. I have to close this a moment because it's not letting me the shortcut key. I do apologize, everybody. So you will see if I go back into my organization at the top here, hopefully if the F11 will get back in. So if I go back into my Azure DevOps home section, you can see I've got 2 organizations. The second organization is actually in a completely separate Entra tenant. However, my Entra account is a guest user in that Azure DevOps organization, which is why I can now see it when I go to configure Git integration. And this is going back to my point earlier. So you can indeed have Microsoft Fabric in one tenant and your Azure DevOps organization in a separate one. And I want to get that point across to you all. Anyway, I can select here the organization, and the rest of this wizard is quite intuitive. So I can select the project, the repository, and then finally I select the branch. And I'll actually quickly just go through this now whilst you're all here, just so you can see the part of this flow. So then once I've actually gone through and selected the repository, and as you can see here, it is a direct one-to-one connection then between, for example, between a branch and a repository in your workspace. Like I said, not the entire repository, just one single branch. This is quite a useful thing to remember, considering one of the release options I'll be going through shortly. So I can show you how it looks when it's fully completed. So once that's all done, and you've got, if I show you at the top here in Git integration, you can see this is how it looks when it's fully configured. So then what I can do, I can click on source control. Whenever I do an update, either in the Fabric, if I do an update in the Fabric workspace, I'll get an update appear in the changes because it say, oh, you've changed something in the workspace. If I make a change and I put it in the branch in the Git repository, it will recognize it as an update because it go, oh, there's a pending update from the Git repository, or more specifically the Git branch. A couple of nice tips for you all here. If you click on the ellipsis and click View Repository, that will take you straight to your Azure DevOps repository. In addition to that, you can use this nice new feature now called Branch out the new workspace. What this will do, this will create a duplicate of the workspace, plus it will create a new branch for me as well if I specify. So for example, if I click on it quickly now for you all, As you can see, I can just type in a new branch name, which branch it's based on, and give it a name for workspace. That will create a duplicate for me. And as you can see, I've already done that earlier, and it shows I've got a related branch. Now that is a super fast introduction, well, not fast, fast-ish introduction to creating, configuring Git integration. So recently, and this is something I do have to make sure I share a link with you all about as well, because this is very new, and I'm going to ask Thomas very nicely to share this link. So I'm just going to put it in the chat. So recently, Microsoft published a set of recommended workflow options. So I'm going to go through now and show how the Azure DevOps relates to the different options, and also give you some additional insights as well. So as I said, they literally released it last month, and this is how I'm going to show you how Azure DevOps fits into it. So here is Microsoft's recommended development process when you're working with Git integration. So they're saying, well, not necessarily Git integration actually, or if you're working locally. So what they are saying is work on your supported items in a workspace for Git integration, or work with specific items in an IDE. So for example, work with Power BI desktop projects in Power BI desktop locally, and have the folder that the project is saved is set up as a Git repository locally, so you can then synchronize it with a feature branch in Azure DevOps. And then from there, you can do a pull request to another branch. That could be a main branch or another branch name, depending on which release option you decide to work with. So taking it one step further to add some additional unit testing, I've got an example here relating to Power BI reports. So as you can see here, if you either change a Power BI report in a feature workspace, or if you change it locally in Power BI desktop, that's a Power by using the new Power BI desktop projects format, you can synchronize either with a feature branch in Azure DevOps. But then when you go to raise the pull request, what you can actually do is have it configured by a branch policy to run an Azure pipeline, and actually check the quality of your report and semantic model. So how it does it, it runs a pipeline which uses a tabular editor client to check the structure of your semantic model and if there's any issues with it, using best practices analyzer. And it will use PBI inspector just to check the quality of your report. And by default, this will use the default rules, but you can customize it. Now, to be honest with you, I'm using Power BI here as an example. This can be various different types of Fabric items. For example, this could be data warehouses that you want to test using one way or another. It could even be data pipelines, because there is a, I would say, new-ish data pipeline framework that you can use to check the quality of your data pipelines prior to deployment. And it actually works with Azure Data Factory pipelines as well, for those of you who are interested. So you could do that level of unit testing here instead for continuous integration. And apparently I hear there is the following session is about testing as well. So you could ask them about potentially other options on how to do the testing with AI. So Microsoft did publish 4 different types of released options. So first option is Git-based deployments. And this is where you deploy the multiple workspaces that are set up with this connected to the same Git repository, but they're connected to different branches. So basically you can work on, for example, items in one workspace that's configured for, like I showed you just now, the feature branch, commit that change to the Git repository, and then do a pull request from that feature branch to a development branch. And then once that's successful, you can go and update another workspace which is connected to that development branch. Just like in this diagram here. So that the next option is Git-based deployments using a build pipeline. So this is where you can deploy the different workspaces using Azure pipelines. Now, at this moment in time, the Microsoft recommended is that each workflow contains a build and release process, so a build for unit tests and a release to perform the update. So I did have a discussion about this with somebody recently, and actually what I would suggest is that you do shift left and do your unit testing as early as possible. Now, like I showed you for the development process, actually do your unit testing there right at the start, and then you only have to do it once, and then just do your releases to the different environments. So I have some things to consider if you are looking to use this method. So consider using YAML pipelines. And because, like I said, that I consider them to be more portable, and there are some preferences to using YAML pipelines. Also, I recommend using self-hosted Azure pipeline agents. Now, just to help with a bit of jargon here, when you run a deployment pipeline in Azure DevOps, it doesn't do the work itself. It forwards the work to other servers behind the scenes to do the work. And these servers are known as agents, and you can have either Microsoft hosted agents, which are basically Azure virtual machines, or self-hosted agents, which are your machines that can be either stored on premises or running somewhere in the cloud. So having your own self-hosted ones can be more secure. Going back to my point earlier, especially about regulatory rules, etc., you may find you may need to have your own self-hosted agents anyway. And something I touched on briefly earlier, I recommend using environments so that you can set up things like an approvals process. So here's a diagram of how it can potentially work. So as you can see at the start, it's very similar to what you've seen earlier. And then once you've done your pull request to your main branch or whatever naming convention you want to use, you can then use Azure DevOps to deploy to one or more workspaces. I put production here, but you can have the full DTAP environment here deployed by Azure DevOps if you want to. DTAP, by the way, development, test, acceptance, production. So release option 3. Deploy using Microsoft Fabric deployment pipelines. This is probably a more popular option for those of you with a Power BI background. So the idea is that once you've done the similar development process we've already gone through earlier, is that you merge that feature branch with a workspace that represents the development stage of a deployment pipeline. So those of you who work with deployment pipelines in Fabric or Power BI already know, you typically get 3 stages by default, but you can customize it now and add extra stages. Your first one typically tends to be the development pipeline. What Microsoft is saying, yeah, do your Git commit into that stage and then let deployment pipelines manage the rest. So an interesting alternative for you all here to consider is to orchestrate the deployment to the different Microsoft Fabric deployment pipeline stages using Azure DevOps. So using the pipelines in Azure DevOps instead. And I shall show you why shortly. So here's a diagram to help you visualize what Microsoft are explaining here. So everything up to here is similar to what we talked about already. And then once you've got your updates into this workspace that represents your development stage in a Fabric deployment pipeline, then use Microsoft Fabric deployment pipelines to orchestrate the deployments to your other stages, which are typically test and production. However, like I said, you can orchestrate this with Azure DevOps as well. So by all means, create those Microsoft Fabric deployment pipeline stages initially, but then do all of your orchestration instead in Azure DevOps. So one advantage of doing this, as you may have spotted here, is that you can implement the approval process when you look to deploy to your acceptance or production stages, for example. In addition to that, it also gives you a lot of flexibility because you can do some really interesting things here. So as you can see, what I've got in this example is that actually once I've deployed to production, I run a notebook. I call an API to run a notebook directly from Azure DevOps, and that will populate my Lakehouse for me. Now, this answers a very common question that a lot of people have been asking for a while, because some of you have been working with Git integration, probably already know that when you use Git integration of a Lakehouse, it only stores the actual Lakehouse name. It doesn't store any files. It doesn't store any schemas for your nicely curated Delta table. You literally just get an empty Lakehouse if you deploy it to another stage. So you need to think of how to populate it using something like DataOps. Now, I must admit, at this moment in time, you do have to think about whether you want to do this. Well, not think about whether to do it, but when. Because at this moment in time, serverless principles are not supported for a fair few of the APIs, which means either it has to be acceptable in your business to use another authentication method, like in an account, a regular account with multi-factor authentication disabled instead, or of course just wait until serverless principal support is available. But this is just to give you an idea of what you can do and just how flexible deploying to your different stages can be if you orchestrate it in Azure DevOps. So final option is for multiple customers and solutions. So what Microsoft are recommending is do all your work for your development and test stages in your Fabric tenant, but then use Azure pipelines to do your deployments to workspaces and other tenants for your clients or customers. And here's a quick diagram just to visualize this. And as you can see, do all the work in the workspaces that represent your development and test environments. And then from Azure pipelines, orchestrate the deployments of those updates to the workspaces hosted by either your clients, customers, etc. So now we'll go through some demos. So just opening up the Power BI report for you now. Usually I have it open up by default, but I had to very quickly do this earlier for some testing purposes. So what I'm just doing now, I'm bringing up a Power BI report, which I've already got configured, well, already got saved as a Power BI desktop project. So I do this by going to File, Options, and hopefully when this comes up, I'll be able to show you. So I will go, for example, here, File, Option and Settings. Don't need to squint here. I'm going to zoom in, select Options, and then here, if I go to, once it finally opens, because this is an online demo, so of course it's taking its time. If I go to Preview Features and I zoom in, you'll see to the right, I've got Power BI Project Save option enabled, plus dual semantic model using Timdal format. For those wondering why I've not enabled PBR yet, it's because if I enable PBR, I won't be able to show you the deployment pipeline part of the demos because it essentially doesn't work. It's not supported at this moment in time. So of course I lose context of the Power BI report. So let's go to the right one. So once I've done that, I can go to File, I can go to Save As, and then I can save it as a PBIP. What this actually saves it as is an entire folder structure. So what I'm going to do that, show this, I'm just going to change the name of this page. You don't need to focus too much on what I'm changing it to. And I'm just going to save the change. And then once that's done, I'm going to go over and we can have a look in Visual Studio Code. So as you can see, when you actually save a Power BI project, you do get a whole folder structure. So typically you get the top two folders you see here. So one subfolder for the definition of your report saved as code, so the metadata basically, and another one for your semantic model as well. And for the benefit of those of you who work with Power BI a lot, as you can see, this is how it looks when the Tyndall is enabled, when Tyndall format is enabled. And you also get this PBIP file by default, and this is just to show the structure of what's been saved. And you get this git-ignore file as well once you initialize it as a Git repository. Now, my advice for those of you who are looking to work with your Power BI desktop product as a Git repository is to ignore the git-ignore file, because if you make changes to it, you can introduce some issues. Now, as you can see, I've already got this set up to be a Git repository locally. However, if not, when you go in the folder in Visual Studio Code, it allows you to initialize. So I'm just going to commit my change, which is basically hard coding my change. And because I've already got this set up as a Git repository and I've already configured having a remote, so basically a remote is just a link basically to a repository stored in Azure DevOps, it kindly asks me if I want to synchronize the change, which I will do now. So once that's completed, it will synchronize with Azure DevOps. So I'm just going to go back into the project again. And as you can see, just now there was an update performed, which means if we go back here now to my feature branch and I press F5, what will happen once it actually finally comes back up, source control will flag up and go, well, actually, I recognize there's a change here. There's an update that's been done in GitHub. Do you want to do the update locally? So if I click on update all, that will actually update my workspace to reflect the changes, which means when I go into my report, it will have the new page name here. However, I have another workspace that represents the development environment. And if I go to the report there, it still has the old name. So in order to update so if I go back, and that's because this workspace is connected to a different branch called dev. So to update this workspace, what I have to do is create a pull request in Azure DevOps from my feature branch to my dev branch. And when I click on create, it will initiate the pull request for me. But you will notice as well that it's running a pipeline already. And that's because I've got a branch policy set up. So if we go to my branches and I go to branch policies, and if I make this a bit more bigger for you all to see, so basically I've got a branch policy set up that says every time I want to do a pull request to my dev branch, it needs to run this pipeline first to check everything's okay. So if we go in the pipelines and I go to edit it, I can show you very quickly what it does. Now, this is a YAML pipeline, by the way, folks. But I wanted to show you this format because this aligns with the Microsoft document on how to implement the continuous integration. So if we scroll down here, I'll give you a very quick overview of what it does. As you can see, I'm first downloading tabular editor and the default rules, more specifically, tabular editor CLI. And then I'm running those rules in tabular editor against the contents of the files that are in my definition subfolder of that semantic model folder I showed you earlier. And for the report, it's a similar thing conceptually. So I'm first downloading PBIX Inspector and then running it against the contents of the report folder. So that is it. And that's how you can do continuous integration checks if you're using Power BI desktop projects. So once that's completed and the pull request is done, it will allow me to do the merge. So I'm just going to approve and complete it now. So that is how you can update the contents from one branch to another. And I've also just showed you how you can implement continuous integration as well. So what you can then do from here, once the data is in the dev branch, so let's just go back in the Fabric. And now when I do F5 on here, because I need to make sure I do get this updated for the next demo for you all. So I'm just going to quickly update here, and now that means that my dev branch has got that update in there. Now I'm going to quickly show you how to do this with Fabric deployment pipelines, because now that dev branch is updated, it's actually the branch I use for my Fabric deployment pipeline. So for the benefit of anybody who is yet to see it, this is Microsoft Fabric deployment pipelines. What you do for the different stages, you basically link a workspace to these stages. So as you can see, that was the dev stage we just worked with. To do an update from one stage to another, I can click on deploy, and there's other options as well. But for the benefit of this session, I show you very quickly how to do the deploy to the different stages, because I want to show you some other things for this as well. So I'm just going to do the deploy here from test to production. So that is how you can do the updates using a GUI in Microsoft Fabric. However, you can also orchestrate this in Azure Pipelines as well. So to give you an example of this, some examples very quickly. So here you can see, if I click on edit, and hopefully that. So once this does turn up, basically all I've got is the same stages essentially set up in their classic release pipeline. And if I click on one of these, you can see here, I'm just connecting up, authenticating, and then orchestrating the deployment. At this moment in time, I'm doing it through a PowerShell script. You can do direct API calls if you want to. So you can do that from there in the pipelines if you so wish. I also skipped the demo here for you. So I just go back and show that one as well. So you can also do it for YAML pipelines as well. So as I showed you just now, if we go back into that release pipeline again, what I can also very quickly show you is if I bring it back up, there's two different ones here. So this one I just showed you, if I just go back into it again, and as you can see, I can actually populate lake houses as well directly using classic pipelines. And you can do this in YAML pipelines as well. So I just wanted to highlight that all for everybody here. Just checking the time, and we are doing good. So if there are any questions, by the way, folks, feel free to add them into the chat. So now I can wrap up by talking about CIC method, CD method for data warehouses. So when you're working with a warehouse in Microsoft Fabric, you can connect that via a connection string. And the reality is that connection string is same as the TDS endpoints you may have worked with in the past. You connect to, for example, SQL Server databases or Azure SQL databases or Azure Synapse dedicated SQL pools, which means that you can deploy to the Fabric data warehouse through traditional CI/CD methods. That includes state-based method, the popular state-based method using a database project, where you basically work with a database project. To help with some jargon, that's the structure of your database, or in this case, a data warehouse as code. And then from there, you create what's known as a DATPAC file based on that database project, or the contents of that project, which you can deploy to one or more data warehouses. You can also look to use migration-based deployment tools as well, for example, the DBUp.NET framework, if you want to work in a migration-based manner. So rather interesting as well, it supports database projects created in a number of places, including a lot of the traditional methods. Plus, you can download it directly from the data warehouse, and it can be deployed using an Azure DevOps pipeline. So this just gives you a very quick example of one way that you can work with database projects and get it deployed to another data warehouse somewhere else. So you can work on it locally, commit it to Azure repos, do the pull request. That will start an Azure pipeline that will build the DATPAC, and then that DATPAC will be deployed to another data warehouse. So I'll show you a couple of ways you can get the data warehouse quickly. So if we go to here, so I've got the workspaces, just going to go to, so open up very quickly a data warehouse. As you can see, on a side note for those, I've actually certified this data warehouse. So just so you all know, that's an option. I was waiting for data warehouse to load. So what I actually want to show you once this loads up is there's a nice button now that says download database project. If you click on there, that will download your database project as a zip file. However, if it doesn't come to life by the time I finish talking, then I will just show you some of the other methods instead, since I have 5 minutes left. And let's do that now. So I'm in Azure Data Studio, and I have the SQL Database Projects extension installed, which gives me some interesting options. So here I'm connected to the same data warehouse you just saw just now in Microsoft Fabric. And what I can do, first of all, I can right click, I can select create project from database, I can fill in this nice screen, and that will create a database project for me. And I've actually already done that earlier, and this is the definition of my data warehouse's code. So what I can do once I've done that, I can then look to work with that database project because it's stored as a repository here as well. It's synchronized. So if I go to this repository, so as you can see, I've got the same database project here, which means that I can work on it in Azure pipelines. So what I will do first is I will show you using the classic editor very quickly. So here, first of all, when you do your continuous integration part, you want to create that DATPAC file. So this is what I'm doing here. So I'm just checking the latest version of SQL packages installed, because you need an updated version of SQL package to work with Microsoft Fabric data warehouses. And then I'm building the DATPAC and then publishing it back to Azure DevOps. And then as part of my continuous deployment, my CD stage, basically, I can then orchestrate the release to one or more data warehouses. And I've just clicked on create release, and I'm not sure why, because I actually want to show you this. So as you can see here, and I just literally use a task in Azure DevOps to say, yeah, just deploy the DAP pack to a data warehouse stored somewhere else. You can also do it using YAML pipeline as well. So in this particular pipeline, you can see I'm using variable groups. I've used variable groups for all the pipeline demos, to be honest. Let's get rid of this to get some canvas back. And then while I've gone to do the deployment, you can see I'm also specifying an environment. So you would manage your variable groups in library, and you would use environments to specify your different environments. And I just thought I would show you those both here. So that is a very quick introduction to alternative CI/CD options for data warehouses. If you want to know more about doing CI/CD for data warehouses, I have some blog posts available relating to it for both Azure DevOps and GitHub, as well as some repositories that you can download as users templates as well. Be aware that there are some limitations with altering tables at the moment and looking to do CI/CD for data warehouses. And I was going to say questions. I've just seen there is a question in the chat from a Rishi Sapper. How can you see what the question is? How can you see what has changed in the Power BI report before the pull request is approved? At this moment in time, the best way to do it is either to look at what's changed in the commit history in Azure DevOps or in Visual Studio, because Visual Studio did have a nice update a while back where it actually shows all your history here. So I hope that's it. Answers that particular question for you all. And if I am going to answer questions in that I can't because I'm out of time and Thomas has appeared, Thomas is about to tell me, Kevin, we're out of time. I have to let Hamish take his turn now. So
to be honest, Kevin, I was reading the question from this Rishi guy. I have a faint memory that I know him, but you spotted it. So, Kevin, it was a pleasure learning from you. Thank you very much presenting at DataBash. If you don't mind, I will put your screen down from the stage, remove you from the stage, and add this Hamish guy, who is already waiting to the stage. Thank you very much, Kevin. Enjoy the rest of the weekend.
Thank you.
Hey, Hamish.
Okay. G'day, how are you?
I'm fine. So, asking for a friend. Do you will present something? Because then you might hit present in the studio button and share your screen. Just asking.
Yeah, mate. All good. I am going to share some stuff and things.
Good to hear that.
Yeah, hopefully it's sharing now.
It does. And now it's also on the stage. And this means I no longer have to bother you. I leave. Good luck. Thank you for sharing with the community.
Thank you so much, mate. Pleasure. Alrighty. I will just quickly swap to where I can go through stuff and things. Here it is here. Hopefully I will just quickly come back. Yeah, it's working. Nice one. All right. G'day, everyone. I'm Hamish Watson. Some of you may know me, some of you may not, but after this session, everyone will know me. I've been doing this funny old technology game thing for about 25 odd years, bringing DevOps to databases and the masses is a personal passion. Helping companies understand AI, data, and cloud is actually a company driver. I'm a DevOps and data consultant in my own company, Morphic Limited. At my core, I'm a technologist who understands business value, and that's sort of the angle that I come at when I'm working with clients, is that their whole reason for being is to deliver business value. Sure, we're all about the ones and zeros and the rows and columns and queries and indexes, but at the end of the day, they're delivering business value. And so I, as a technologist, help them come along. If you follow me on X or Twitter, what have you, you know, I've sort of came up with the Make Stuff Go hashtag because it pretty much described everything I did, you know, over the years. And in fact, I created a company called Make Stuff Go to sort of leverage, you know, what we're seeing in industry right now. Alrighty. First of all, thank you to the sponsors for helping today with DataBash. It's been brilliant, so thank you so much. What's our agenda for today? This whole intersection of data and AI. Well, I'm going to do an introduction to artificial intelligence and, you know, traditional approaches to data testing, as well as AI-driven approaches. I'll be talking about how AI enhances test data creation and also coverage optimization, as well as automating testing processes with AI. So, you know, how we can get efficiency and accuracy in our testing. Also identifying patterns and reducing bias in our testing data sets. So using AI to sort of detect our, you know, hidden patterns and ensure that our testing is unbiased. Talk about some practical insights and integration of AI in test-driven development. And this is sort of where AI is going to elevate, you know, our data engineering practices and our testing strategies. And and definitely be doing a demo of Stuff and Things. Now, here's the deal. Back in 2012, you know, I was sort of doing a whole heap of stuff with DevOps. Back in those days, it was to do with applications. I was just moving into the database layer, automating this, that, and the other. And people said to me, aren't you worried that this whole automation thing is going to do you out of a job? You know, why do we need you, Hamish, if you're going to automate everything? And I said, I want to be the guy in charge of automation. And I want you to think about this, because in the media, we have this whole hype, right? You know, AI is going to replace jobs and this, that, and the other. And true, there will be some jobs that will have to pivot or may not be around anymore because of AI. But in fact, for the majority of us, especially we technologists, it won't be AI that will replace you, but it will certainly be a person who uses AI. And that's been my approach in terms of both how I have been using artificial intelligence. And let's be honest, people, it's not truly artificial intelligence. It's just really machine learning. It's been around for a while. All that's happened is that the compute power has reached a point where instead of taking, you know, I was working with machine learning in 2017, and what used to take me weeks then, I can now do in seconds, which is scary, but also brilliant. And so at the end of the day, all that has changed is the compute power that we have at our disposal. Alrighty. So, traditional testing approaches. Very manual, traditionally data verification and validation processes involved a whole heap of manual work, right? Test engineers have to create test data, write scripts to run tests, manually check the results, all that kind of stuff. And, you know, we had rule-based automation, you know, so whilst some automation tools like, say, Selenium have helped speed up testing tasks, these tools follow predefined rules and don't adapt to dynamic changes in the data layer, right? And that's the thing, you know, testing data is hard. I've been trying to do testing with data since 2014, right? 10 years. The cool thing is that AI, or machine learning, we'll call it AI because we're going to be in with the hip cool kids. AI is a game changer in data testing, and what it brings to the table is that we're able to use learning algorithms that adapt to data, allowing for more intelligent test case generation and dynamic test case adjustments. And the really cool thing is we can do real-time decision making as we're doing the testing. And of course, artificial intelligence is adaptive in its nature. So it's not rule-based. It'll actually learn from past testing data and improve over time. The reason why AI is essential in today's data-driven development environment is that we're now dealing with massive amounts of data, right? And very complex data. And so modern applications generate vast amount of data that need really thorough testing. And so AI can handle these large data sets and also these complex testing scenarios that our traditional methods could not. And so this means that we can now do faster development cycles. It's going to improve our accuracy, and also it's going to reduce our risk. So how is AI changing testing data? So we can use AI models to automatically verify the data integrity by, again, comparing large data sets, identifying discrepancies, and ensuring correctness without little to none of manual intervention. It means that we can have real-time feedback because AI tools can within seconds, can provide real-time feedback on data quality during that testing process, allowing our teams to detect and correct issues on the fly, rather than having to wait till our post-deployment phase has been completed. So, our traditional challenges of manually testing large data sets, which is very slow, resource intensive, and prone to human error, we make mistakes, means that we're shifting away from this. We're shifting from static, predefined testing to dynamic learning systems. And the biggest part here is scalability. We can scale out artificial intelligence, right? We can use a whole heap of methods and processes at our disposal, which I will talk about later, and how we handle some of these large data structures and also the complex relationships, let's be honest, would overwhelm us as manual testers. So, some tools that are out there. So, I've come from both an infrastructure and application background, and was a DBA for 15 odd years. And so, using things like Mabl for test case generation, using things like Blazemeter for application performance testing are second nature to me. As a DevOps technologist, using things like Dynatrace and other application performance monitoring tools have a layer of AI that are within them. So when I'm feeding some of my results to those sort of tools, I can use them because they use AI in the background to detect anomalies and validate performance across, quite diverse environments. Another example is New Relic in there, right? So being able to augment our monitoring is brilliant. Looking for things like Databricks Delta Lake, and also a great utility, great expectations. Both these use AI to ensure data quality and correctness right throughout the testing lifecycle. I think hopefully by now you will have cottoned on to some of the benefits, but here they are: speed and efficiency, improved test accuracy, and enhanced test coverage, as well as predictive testing. Excuse me. AI, so when I talk about predictive testing, AI can predict potential areas of failure based on patterns from previous test runs. And I talk about evolution of our data environments, right? AI has this concept of continuous learning, where it will learn from new data, adapting to evolving data patterns, schemas, and application updates without, again, requiring manual configuration. Alrighty. For me, one of the first things that I got exposed to in terms of using AI is one of the things that is really hard to do properly, and that's generating synthetic test data. Why do we want to create synthetic test data? Well, rather than taking a copy of production data and putting it in our non-prod database, and trying to obfuscate it and do all that horridness, why don't we generate that test data on the fly? And so synthetic test data is artificially generated data that mimics real world data without exposing sensitive information, right? And the reason why we obfuscate, personal identifiable information, or PII. And so what we have is AI models create this data to ensure it's statistically relevant and covers various scenarios. And so think about, GDPR, HIPAA, all those kind of things, right? We need to ensure that we are protecting the privacy. And that's where synthetic data helps to avoid the use of actual customer data when we're testing. What we want is realistic data. And so again, AI is using machine learning models trained on historical data to create realistic test data sets. And don't worry, this isn't all bullet points. I'm going to be doing some demos, show you some of the stuff in action. And of course, diversity, right? We need to cover a wide range of scenarios, including test cases and, uncommon data patterns, which might be hard to gather manually from real data. Test coverage is so important. And what we need is comprehensive coverage. And so by creating synthetic data that includes edge cases, corner cases, and unusual data combinations, it ensures that we have better coverage than traditional methods, which might overlook, rare or unpredictable data scenarios. We also have some techniques. And so one of these is generative adversarial networks, or GANs. And these use AI models that learn to generate synthetic data by training two neural networks, one that creates the data and one that evaluates it. And this method is highly effective in creating realistic data sets. Now, as an aside, if you use Copilot, which I hope you are, Copilot does this, right? So when you ask Copilot a question, it will actually create the answer, and then it will actually evaluate that answer, whereas some other technologies may not do that. So please use Copilot. So part of the techniques and that we have is around pattern recognition, right? So AI can identify and replicate patterns in existing data sets, but it can also take those existing data sets and augment them by making slight modifications. Now, the limitations of real data, AI-generated synthetic data removes the risk of exposing our sensitive information, i.e. personal identifiable information. In cases where real data is restricted due to privacy concerns, regulations, or limited availability, AI can generate synthetic data that mirrors the structure and behavior of that data. Alrighty, so the very first time I thought I'd have a screenshot here of the very first time I wrote some code to synthetically generate data. And so I actually got Copilot to generate the code. I made use of the Faker library. And so this part of the code where we have the Faker part, excuse me. So around here. So we are importing the Faker library. We'll create a generator, and then because it's in Python, we're going to generate a data frame. And so we're generating synthetic user data such as name, addresses, emails, dates of birth. So I will be showing you this later. But for more complex data generation, we may use scikit, which, we might be generating numerical data that might be used in machine learning. Well, using scikit-learn, and in this example, I have where we're generating a synthetic data set suitable for classification tasks, right? So again, we're generating our synthetic data set, and we can, specify the number of samples, which is 100, the number of features, and a whole heap of other parameters as we want. The cool thing is we can bring in a file, an existing file. So this one here is our users.csv. And so we'll read in the data. So the function up here is reading in user data from users.csv. It then prints, excuse me, and returns the data frame for further processing. We then use some model learning, which is using Gaussian copula model to learn the structure and distributions of the input data. And then we're generating our synthetic data here, which we're creating new data based on the learned model. And the number of samples generated, is to set the number of the original data set. And obviously in our main workflow here, this orchestrates the process by reading the data, learning the model, and then generating and displaying synthetic data. And of course, as I said before, this is more machine learning than what AI is touted as in the media. Yeah, I won't harp on that. I'll show my cynicism. Anyway, some of what we're doing here is we do want to remove the limitations of traditional test coverage. We want to leverage the ability to identify edge cases and also optimize our testing path, right? And so what I mean by that is AI can examine the usage patterns and error trends in our application or data layer and adjust the testing paths to focus on high-risk areas, ensuring the most critical parts of the system are thoroughly tested. And again, we're broadening our test coverage and we're reducing human bias in our test case design. We humans by nature, we are biased. We like to say that we're not, but we are. And so traditional testing is often influenced by our testers' experience and assumptions. So we're reducing that. And as I mentioned before, being able to do test coverage in complex real-time and big data environments is an absolute game changer, and one reason why we want to incorporate some of what AI can bring to the table. Again, we want to automate, say, regression testing or, routine data validation, which are very repetitive. They're time consuming when done manually. Of course, machine learning models can observe an application's behavior over time and adapt testing strategies based on new insights, right? So automatically updating our test cases to address evolving scenarios and changes in the system. Feedback loops. If you've ever done anything in DevOps or done continuous integration, continuous delivery things, you know how important feedback loops are. This is where we're doing a whole shift left process, right? And that shift left process is integral when we're using fast-paced environments like, DevOps-based deployment lines. And so using AI-powered automation allows for faster feedback loops by providing immediate test results after each build. And this, again, is where applications like Mabl come in. Mabl is spelled M-A-B-L. I should have put the name in the slide, but anyway. Mabl have implemented machine learning algorithms in the background to really hone in how we can get that information to us a lot quicker. And of course, we want to reduce human errors. I'm sorry to keep harping on about how bad we as humans are, but it is a point to make. And it is something that we do want to reduce because we want faster test execution, but we actually want execution that is of higher quality. And the thing is that we can scale out, machine nodes. It's very hard to scale out a whole test engineering department. Alrighty, let's do the world's quickest demo. Okay, I'll just get a couple of things ready. So what I'm doing here is I have I'm going to be using VS Code, and I've used I actually had to change it from dark mode to light mode because it'll probably look a bit better here. And what I've done here is I've just got a very simple JavaScript file. And what I'm doing here is I'm just going to take you through a journey. I want to show you my journey as it was with this whole AI thing. And one of the things that I noticed was not that. That is the wrong thing to copy and paste. Was I had an example where I needed to create a dictionary of 2-letter ISO country codes in their corresponding country, right? And the thing was, I couldn't do it. And as you'll notice, what I'm using here is Copilot. And what happened was I started using Copilot in VS Code, and suddenly a whole range of things opened up for me. One of which was that it could give me something that I would normally have to go and look up, create this, do whatever. And this was actually for a particular client. They needed a JavaScript file that had countries in it, blah, 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 blah. And so, oh, by the way, I'm this committed to DataBash conference. Tested positive for COVID 2 days ago. And I slept a lot so that I could make my session today, which is why I'm drinking a lot of water and I might cough a bit. But that is the beauty, my friends, of virtual conferences, where I can be very quite sick in my house here in New Zealand, and I haven't infected any of you. That's brilliant. Anyway, so this was a game changer for me. This next example that I'm going to give, and I'll show you another way to interact with VS Code. You'll notice here, I just started typing, went to the next line, and Copilot, which is a great AI-based tool, gave me some recommendations. Well, it actually looked this up for me. This here, my friends, is another way to interact with Copilot within VS Code, where we can bring up a prompt, and it says ask Copilot. Now, normally when I'm doing a demo of, hey, you can use Copilot in a whole range of things like VS Code, M365 applications, right? So Word, Excel. I train a whole heap of people on M365 Copilot, by the way, but anyway, whatever. This example here, right, was a real world example where I had a client who were they were using Pulumi. They wanted their development teams to take over the deployment of infrastructure. And so I was brought in to train them, around DevOps principles. And they said to me, hey, we write in TypeScript, can you help us write a function in Pulumi? Pulumi is a infrastructure as code deployment orchestration tool. Here's the deal, my friends. At that point in my life, I had never written in TypeScript. And I was like, what do I do? And I was like, wait a second. Now, let's have the whole ChatGPT versus Copilot discussion. I could have used ChatGPT. I get it. However, one of the reasons why I suggest that people use Copilot is because Copilot is within your compliance boundary, right? So if you've got M365, right, Word, Excel, Teams, PowerPoint, whatever, and you're using Copilot within that, it gets all the security, governance, and all of the setup that you have is baked in. So that means that data does not traverse your compliance boundary unless you choose it to. Copilot doesn't go out to the internet to get things unless you tell it to for M365. Anyway, I did use ChatGPT at the time. But, so, I'm getting a whole range of code here. Now, this is not production ready at all. Okay? This is an attempt to give me what I've asked. Obviously, I have to go out and create, these secrets, store them in a key vault somewhere, blah, 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 blah. But for the majority of it, it gave me kind of what I needed, right? It's written in TypeScript. I'd never written in that. I know what you're thinking. You're thinking, wait a second, Hamish. This was called the intersection of artificial intelligence data. This wasn't about, hey, look at this cool thing that I can do with TypeScript. I get it. What I'm doing here, my friends, is just showing you kind of the journey of where we were, more importantly, where we're going. So let's do another one. And this is where, and I'll just get rid of these because I don't really want them. We're going to do something that is pretty cool. So I want it to create fake data for first name, last name, street address, and country, and save it to a CSV in this very long-winded place. Alrighty, I'm going to accept this. So what we're using here, we've imported a CSV. Excuse me. We've imported a CSV function for Python. we're importing Faker, as I showed you in my example before. Our output file is in this very long-winded location here, but that's all cool. I told it to do that. And what I'm going to do is I'm going to save this. Bash. So I'm going to call it fake data CSV Python. Right. This is pretty cool, right? This is my journey of creating stuff and things. And now what I'm going to do is just run a bit of local Python down on the terminal here. Now, just to show it's not smoke and mirrors, I'm going to click this lots. Look over to the left of the screen, this output thing. There's no output, okay? Just, making sure. Boom, boom, boom. Look at that. We've got synthetic data. And now if I open this, I've got a CSV file with synthetic data that has just created all of this for me on the fly. Now, some of you will be saying, Hamish, this is the most basic code ever. Yes, it is. I'm not going to go through thousands of lines of code just to show how cool I am at writing code. This isn't called, hey, watch Hamish write code. This is the intersection of AI and data. And my friends, we literally just did it. Thank you so much for being a great crowd. I'm kidding, of course. There's way more. So, this is all well and good, right? Created this somewhat good code. Again, and this, my friends, is where AI will not replace us, because there's no way I would ever productionize this. First of all, my goodness, let's not have that in there. Let's variabilize that. And there's a whole heap of error checking and stuff. Now, I want to show you something that changed my life. Pretty bold statement, isn't it? And that is Copilot Chat. Now, don't worry, this is not a demo, this is not a sell for Copilot, but this actually revolutionized how I did things. Because, yeah, over here I can use good old prompty thing to ask Copilot. Excuse me. But being able to chat with Copilot, that's a bit of a game changer. And again, the functionality here is very similar to what we're used to using with ChatGPT, right? I'm actually going to have a conversation with Copilot. And so what I'm going to do is, first of all, let's get rid of all this. I'm going to use my prompty thing. And I'm going to do something that I've wanted people to do, let's say since 2014, but I'll be nice and say since 2018, right? So for the last 6 years, I've wanted people to write unit tests for their data, whether it's written in T-SQL, i.e. for here, and the majority of people that I'm working with do write in T-SQL because I want them to incorporate unit testing in their life. But it's hard. There is a really cool utility, T-SQL-T, that you can use. It's very simple. It's written in T-SQL, and it's for testing T-SQL. So what we're doing here is for an order table with order date and order total columns, write a T-SQL test to ensure that the order date is not null and that the order total is greater than 0. This is a pretty cool unit test, by the way. And the best part is, you're going to see it written here. I'll just accept it. Now, don't worry about the nuances of T-SQL-T. Just worry about the fact that we now have the ability to have a unit test here. So, over on the left-hand side, I'm going to chat with Copilot. And I'm going to say, describe the code. Boomity boom, right? This is brilliant because it allows us to interact with the code on the left. Oh, I see what I've done. I've deny. Oh, please go away. I don't. Oh no. Okay. Here's the deal. I said, how do I install T-SQL T? Because this dude Hamish keeps talking about it. Well, we can go to the website, tsqlt.org. Quite a hard URL to remember. Extract all this stuff, do all this stuff, blah, 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 blah. Now, I'm sorry, but to me, that is brilliant. The best part is, look what it's done. It's given me a prompt. How can I write and execute tests using T-SQL T in SQL Server Management Studio? That's a quite good prompt. Thank you, Copilot Chat. And so, again, we have this. Well, that's all fine. How can I view the results? Oh, this is brilliant. T-SQL T.run, I think. I really should have not used my Python file, but whatever. What I might do, but anyway, we'll keep going. What I'm going to do is do something that for me just brings all this together. And I know this is a trivial example, but trivial's nice. Add this code into a GitHub action to deploy the unit test to Azure SQL database. Oh my goodness. Now, this would have taken me a wee while to look up and do. Don't have to, because it's done it. Now, I'll just do one last one, right? Because this one is one. I think this works. So I'm writing code that shows how Copilot can automate the generation of reports by creating code that compiles data analysis results into a readable format such as PDF or HTML. So again, it is writing this in Python, and some of you might say, well, I don't write in Python. Well, maybe you should. Go out and try it. The really cool thing here is I have at my disposal something that can shorten the amount of time that I'm doing things. The other thing is, we'll go back to our slides for now. So let's talk about some other things. And one of the main things is pattern detection and bias reduction. So I've showed you how AI can create code like that. I've showed you how it can look at the code, describe it, and extend it, right? We took some, T-SQL T unit test, and we suddenly had the code to put that into a GitHub action, deploy it, to Azure SQL database. But there's so much more. And so we want to look in our test data sets, right? So I could bring in, and I'm thinking I might do this in a future demo, where I bring in test data set and get AI to identify intricate and non-obvious relationships in a large data set. Because these relationships could be missed by our human testers or traditional testing approaches due to the scale or complexity of data. And, it will look at anomaly detection, so looking for unusual patterns or anomalies, and we're not good at that. And being able to look at inconsistencies, right? So checking for, say, irregularities across large data sets. And basically, AI is ensuring that data being used or generated by the application is accurate and adheres to expected patterns or formats. And being able to quickly detect inconsistencies between test data and real actual system behavior means that we can actually catch bugs that might have otherwise gone unnoticed. For example, if a data point is expected to fall within a certain range, but consistently falls outside of it, our AI will flag this as an anomaly. We also, again, want to reduce bias. And so one of the significant changes in testing is that the test data itself can be biased. And so we can actually use AI to generate diverse data sets that better represent various user groups. And so in my example before, where I generated, some users, I could actually have code generated by AI that can look over that and reduce the bias in that possible CSV that we generated. So what's some real world examples? Well, e-commerce platforms, right? So massive online systems. AI is being used to identify patterns in user behavior that lead to, say, cart abandonment, right? So I put some items into my cart and then I'm like, oh, yeah, I want to do something else, or I leave it. Or there might be system failures during high traffic periods. And you've heard about the Chaos Monkey, right? That Netflix use, where it goes through and it simulates, it actually fails components within the system. Well, they've gone next level and incorporated AI into that, and just being able to scale these out. I talked about data and privacy of data, and so think about healthcare data, right? So AI can detect subtle anomalies in healthcare data sets, such as unexpected trends in patient records or irregularities in, say, medical devices. And so these anomalies, when identified, during our testing, can prevent issues that might lead to errors in diagnosis or treatment. Test-driven development. So in test-driven development, this is where tests are written for the code, and AI can assist in generating diverse and unbiased test cases automatically. And this ensures that developers address a wide variety of possible scenarios from the outset, even before they write their code. And the thing was, as I was researching, different ways that AI can help us with data, test-driven development was probably top of my list because, and this is where I felt triggered, because speaking of test-driven development, so around 2018, yours truly went on a bit of a journey throughout the world talking about test-driven development in SQL Server. By the way, I look like that. So, yeah, maybe some things do evolve over time or devolve over time, but whatever. In 2018, so 6 years ago, I went and just talked about test-driven development within SQL Server so much. And why? This scenario, right? So we have a developer on the left who says, hey, this is a 6. We have a tester on the right who says that's not a 6, it's a 9. And so they're continuously arguing. I wrote the code that generated a 6. Tester says, I'm seeing a 9. The problem is, my friends, the client actually wanted a G. And I know it's a very trivial joke, but it's real because we write this code, we go to push it out, we deploy to production, and guess what? Gets to production, client doesn't want it, client doesn't like it, because we didn't think about the real use case of what we're writing. So what's test-driven development? Basically, we want to write a test for the next bit of functionality we want to add. And I know that test-driven development was not in the title, so you're getting a freebie here. We basically write enough functional code until that test passes. And we refactor both the new and old code to make it well structured, right? So it's iterative. And I'm going to show you a really cool animation in a sec. So we continually cycle through these steps, one test at a time, building up the functionality of our system, where we write the test first. We then, and the thing is, by writing that test first, we're actually thinking about, you know, what the code will have to do. And this focus on that means that, you know, we write better code. And the thing is, most people do, when they do test-driven development, do 1 and 2, but never do 3, the refactoring. And that's the best way to make it pretty horrible. So let's have a look at what test first or test-driven development looks like. So first of all, we write a test, which defines the function or improvement that we're doing. And this is linked to use cases and user story requirements. We're actually thinking about what this code will go and do. And this is a differentiating feature because, you know, it makes us focus on the requirements before writing the code. We then run all tests and see if the new test fails, which it should, because we want to validate that our test harness is working, which shows that the new test does not pass because it doesn't have any code. And so we then write just enough code to pass the test. It's not elegant, but we will hone that later in the next step. At this point, the only purpose of the written code is to pass the test. The developer doesn't write code that is beyond the functionality, right? And so then we again run tests. The test should succeed because we've written the code to make it succeed. And then we get to a point where, again, we can, we've written enough code, the test fails, and we get it to pass. We then get to the point where we want to refactor the code, right? We actually want to make sure that it's, you know, we want to remove any duplication. You know, we might need to make, split out, you know, our stored procs, you know, for readability, maintainability. And also, you know, our code is growing, you know, we're just trying things out, da-da-da-da-da. And so we do want to refactor for clean code. And so, again, we're just iterating through this, right, to make our code as good as possible. And so, again, this means that at the end of it, we have really good code. Okay, so here's the deal. Let's just agree on one thing. Whether or not you agree with test-driven development, I don't care. But I do care about us writing tests for our data. So please write tests. A bad way to deliver any form of change is not to do automated testing. So start unit testing your database code and data. I said please again. With this AI thing, you now have no excuse, because one of the arguments people say to me about test-driven development, it takes too long. I don't understand, you know, I don't know how to write the unit test. We can use AI for that. So, integrating AI with test-driven development. So, one of the major challenges in test-driven development is writing meaningful test cases up front. And so AI can assist by automatically generating test cases based on historical data, users pattern, or system behavior. It can analyze existing code bases and previous test cases to predict where issues are likely to occur, allowing us to preemptively write tests targeting those areas. And of course, it will have smart test suggestions. In my demo, I showed you how we can describe some of the code that that we've written. Excuse me. It means that AI reduces the time required to write and maintain test cases by automating some of the repetitive tasks and generating the relevant test data. So that's where we're combining a whole heap of stuff that I was doing before. Excuse me. And obviously, as the code base evolves, AI can dynamically update or optimize our existing test cases, ensuring that they remain relevant and effective, right? So this is kind of almost self-improving tests. And of course, this is going to help with improving test coverage and reduced bias. The thing is, I actually went out to ChatGPT because I thought, well, I can't just keep doing this visual code thing. And so I asked it, create an example of test-driven development example using T-SQL-T for a unit test of an orders table. And so, you know, I have at my disposal here a pretty good framework for what I want to do, right? And the great thing is, you know, after I've run it, it then starts, you know, it's talking about implementing, you know, business logic to pass the test, rerunning the test, da-da-da-da-da. And the get-go is that right up here, we install it. Whereabouts? Oh, goodness. I should have slowed down a bit. Yeah, so we write a test to ensure that order date cannot be in the future, da-da-da-da-da. We're doing all that. And then we're actually creating all the code around this to ensure that we can, you know, pass the test. And so the thing is, we have so many tools at our disposal now that we never did before. Alrighty. So there are a number of AI-driven tools like Testim, Applet Tools, and Mabel. I should put them in there. But anyway, my voice will do. They can be integrated into your testing frameworks. You can integrate T-SQL-T and utilize Copilot to run some of this as well. And again, what these tools are doing is generating test cases based on application behavior, usage patterns, or historical test results, covering scenarios that, again, we might miss. Oh. Excuse me. I guess what I'm trying to tell you is this will accelerate our development cycles. It will, it will improve our software quality. And there's some key considerations that you need to think about when you are adopting AI in your testing workflows. First of all, you know, we do have to have an initial investment in tools. Copilot in Visual Studio or GitHub Copilot, whichever way you want to call it, does cost money, but we're talking not very much. And if you think about the productivity that it gives me, you can save thousands of dollars a month in productivity for, like, you know, tens of dollars investment. So we do need to do team training. And so we need to be prepared to have some upfront costs, but the payback is massive. And of course, data quality. For AI to be effective, it needs access to high quality representative data. Poor or biased data can lead to inaccurate results or ineffective test cases. Well, that's cool because we can use it to reduce all of that. And of course, collaboration between teams. I wouldn't be a DevOps person if I didn't talk about collaboration. You know, we have QA engineers, data scientists, developers. These teams need to work closely to ensure that the AI models that we are creating are properly trained. The testing process is aligned with development goals. And of course, feedback is incorporated both efficiently and appropriately. And of course, we need to monitor how everything's going. Alrighty, so my summary. AI is revolutionizing data testing. The key benefits of this, you know, I've talked about what benefits it can bring to our testing. Adopting it into your process, you know, there's a number of tools that you can do. Please do start small, but have an aim or goal of integrating AI and AI-based testing into your CI/CD pipelines. And of course, you know, AI role is all about future-proofing your testing strategy, right? So being able to keep up with rapid development, being able to do adaptive testing. These are all game changers. And my final thoughts. AI is a key enabler of reliable, efficient testing. As AI continues to evolve, is becoming an indispensable tool for enhancing testing strategies. I want you to embrace AI for continuous improvement, because by incorporating AI into your testing workflows with data, you're not just improving testing today, but you're also setting your team up for success as software development, you know, continues to accelerate it. So look, just get started. I've showed you some very simple things where AI can accelerate the productivity of what I'm doing. Alrighty, at this point, if there's any questions, I will have a look in Steam. I don't know.
Hey, Hamish.
Hi there.
It doesn't look like there are questions in the channel.
That's okay.
Well,
We've got a couple of minutes, but most of all, thank you everyone for coming to my session. Like I say, a little bit sick, but absolutely thoroughly enjoyed being part of this wonderful, wonderful conference. Those are my details. If you do think of some questions, please feel free to just email me. Yeah, have a great rest of your day, wherever you are.
Hamish, thank you very much.
No worries.
Sharing your knowledge with us. I will remove your session slides, you from the stage.
Yeah, no worries.
And then I will also almost done with closing this. So
It's 4 hours.
Cool.
So I just want to say thank you all who joined us today. Thank you very much to my friends who helped me to get through this day, preparing everything. Thank you very much. Thank you very much to our speakers. And of course, thank you very much to our sponsors. Without them, this would not have been happened. Thank you very much. Enjoy the rest of your weekend and see you the next year. Bye.